So we're going to be, there we go. Now we're going to be getting started, officially getting started. Thank you all for being here and on time. Naturally, being conferences and Web3 and everything else, we're already running behind, yay. But such as just the joys of running live events. I'm going to keep my opening remarks very short at this point, just to keep us as close to schedule as possible. So most importantly, I just want to thank everyone who's joining us either in person or virtually. It's kind of crazy to think that just 2 months ago, 2.5 months ago, literally most of the people who were co-organizing this didn't know that we all existed. We didn't know of each other's projects. We didn't know what was going on. Around 2 months ago, we came up with the idea. A month or so ago, we just finally booked this place, and this has all come together for actually having a DeSci Day, which I think is pretty cool. And so we're just very excited to get to share this with the community and to really continue the energy that we were able to capture in Denver, what we're able to do here today and throughout this Devconnect week overall, and really carrying that energy forward into building a larger and larger DeSci community. And we know, especially given how last minute all the planning for this event was, we are not pretending that this was the perfect event or the most representative of the global community or in general shooting for all the standards that we all want to. But we just wanted to make sure that we got at least some starting point, because we do know there were blockchain and science conferences around 4 or 5 years ago. There were a series of them, and there just wasn't enough community support to keep them going. So we're really hoping that in kickstarting these again, that we're going to be able to build a really wide community of individuals to help us plan these, make sure that the setup is as ideal as possible for the community, that the community is represented appropriately in all of the events, both virtually and in person, and figuring out the right mix of activities there, and generally bringing together a group of volunteers, because everyone who did work on making DeSci Day happen was entirely volunteer. So we want to build the biggest group possible to make this as sustainable for those who are putting these events on, and to rotate out the different organizers as we go, also to make sure that people with different viewpoints and different approaches all have a chance to organize. And so today, we're going to be kind of splitting the day into a couple of sessions. We're going to start off with some DAO, govern, and meta-related panels. Then we're going to go over the tech build data section, where we're going to have a mix of some panels and presentations, and those will be sort of demos and pitches. And then we'll wrap up, we'll have lunch. There will be lunch provided here today, so make sure, I believe they'll be set up just outside as kind of grab-and-go bags for anyone if you want to eat here. And then we're going to wrap up the day with a couple hours on fund, research, and publish. So again, I'm just tremendously thankful for everyone who joined us here today, either in person or online, and I'm just very, very excited to get more of just the energy and activity around DeSci going. So without further ado, here's the full demo schedule, and if you're in the Telegram group, which at any point, feel free to scan that QR code and you can hop into the Telegram group. That way, that's where we're going to be adding any news, updates, changes that happen throughout the day. And this POAP link is for a POAP for the day. So you could prove to yourself and anyone else that you were at DeSci Day in person. So without further ado, I'm going to go ahead and invite our first panelist up. And we'll have Allison Dudeman, no, it's not going to be Philip now, it's going to be Chris Hill from the DeSci Labs DeSci Foundation side, Alex Smilek, who's also working with Foresight, and potentially Vincent, depending on how morning schedule is running. So with that, please come on stage and join us. Here for the moderator, please feel free to sit down and I'll swap computers momentarily. Here is the other microphone.
We can leave one for Vincent there, so he can run up on stage gloriously from his bike. Okay, good morning, everyone. How's everyone doing?
Woo!
It's 4:20, and you're here at 9 a.m. Give yourself a round of applause, guys.
Yeah, it's 4:20 at a science conference in Amsterdam. What a thing.
Yes, obviously. We are in 2022 after all, right? Okay, wonderful. Quick question. Who here was at ETH Denver already? Anyone? Okay.
Woo.
Very fun. Well, I really still can't imagine to some extent that what happened since ETH, first of all, everything that led up to ETH Denver, all of the community that came together, the way that it came together, then kind of the culmination became an explosion of different DeSci projects at ETH Denver, and then since then really a really wonderful gradual growth of the community. So thank you all, Shadi, and for especially you, Eugene, for making it happen. I know you're running around vicariously behind scenes right now, but I think it really, really takes, it takes a village and a lot. Thank you very, very much for all of your work here. It needs to be said. This was a ton of work to put on, so thanks. Yeah. And Eric, obviously, who has the boots on the ground here. And here we have Vincent, without further ado. No, we can wait. Take your time. All right, everyone. I'm really, really, really happy to chair the first panel here. I'm Alison. I'm from Foresight Institute. I was also one of the hosts of the DeSci track at ETH Denver. Good morning, Vincent. Still a little sweaty. And yeah, I'm really, really happy to open up the first panel today. And I'm really happy to open it up with the topic of art, creativity, and NFTs in Web3 and DeSci in particular. And the reason why I'm so excited about this particular topic as an opener is because I think when we all take a step back about the reason why we're all producing the types of work that we're like kind of like chucking away on every day, it's because we care about really wonderful futures, and we care about really wonderful like visions that we all have that we want these tools to create. And I think there's no better way to remind us of what these are than I think our creativity in the different scientific endeavors that we pursue. So I'm very happy that this is a starter for today's panel. Really, really happy to have wonderful panelists here. And I think you can introduce yourselves much, much better than I can. So perhaps we just take a little round, introduce yourselves maybe in a few words, and how did you find your way into DeSci?
Hey, great honor to be here. I'm Christopher Hill. I'm one of the co-founders of DeSci Labs in Switzerland, alongside with Philip and Sina. My background, I'm a scientist, I'm a neuroscientist. After that, I moved into data science, and now finally working on creating some infrastructure for decentralizing science.
Hi everyone, I am Alexandra Smilek. I'm working with Alison for Foresight Institute, and I'm a creative director actually. I'm not a scientist totally, so I've been working on creating some system linking digital sphere with creativity for a long time now. And when I met Alison a couple of years ago, we decided that there is definitively something to do with like bridging art and science. So yes, we decided to create this new path for Foresight Institute, which is like creating NFTs by bridging art and science.
Hi everyone, I'm Vincent. Thanks also to the organizers for organizing this. So I'm one of the co-initiators with VitaDAO, and I've been in crypto before and kind of exploring biotech as well, and now running product and molecule.
Wonderful. Hey everyone backstage, would you want to keep it a little down? They're having too much fun there. There's lots of costumes over there, so I think later today we all have to move backstage at one point. Okay. Great, thanks for the intro. Now we know who you are. Now I really want to know what the NFT projects are that you guys are excited about. I know you're wearing your NFT project, so you go last. I want to start with you first. Tell us what we have up on stage here. What is the cube behind us, and why is it exciting?
Okay, so first of all, I hold the firm belief that science and art need to go together. Anytime we've had in history periods of enlightenment and scientific development, if you look at the Greek city-states, if you look at later on the Renaissance era, art and science have often co-evolved and co-inspired each other. And what we have up here, first of all, we're working with a fantastic artist called Melody Sheep, so I really enjoin you to look up his YouTube channel. Melody Sheep has been doing a lot of work at the intersection of art and science to popularize and to inspire and to create a sense of awe, which is essential to the pursuit of science. This cube up here is a metaphor for a research object. And the idea of a research object is that it's a place where all the outputs of your scientific work can be contained in a singular on-chain manifest, which is stored forever. And you'll see later in my talk, in my presentation, how all of this fits together. But to give you an idea, is that the NFT technology that's out there goes far, far, far further than selling profile pics. And to give you an example, we're using non-transferable, non-fungible token technologies to handle the problems of editorial rights, of authorships, for scientists to be able to hold their work in a self-custodial fashion and to be able to push new versions and commit new advances on their particular researches. So that's one of the implementation of a non-transferable, non-fungible token. Another thing is that we can start creating grants, micro grants for scientific validations, which also take the forms of NFTs. These are essentially receipts that you can store in your wallet, that you can withdraw, that you can get benefit from having these proofs, these NFTs, which represents essentially proof of scientific patronage. So these are two of the applications we're implementing in our backend infrastructure. Now, down the line, down the horizon, there's many more applications of NFTs, and I'm sure Vincent will talk about IP NFTs and these really interesting applications. And there's another one out there, and I think that's the end game for DeSci, and it's going to be impact certificates. So NFTs that represent impact certificates are on the horizon. It's not going to come soon, but when it does, it can change everything.
Wonderful. Thanks. That's quite the strong start. Alex.
Yep. So we started actually a spin-off called Existential Hope. So Existential Hope has been existing for a few years now inside of Foresight Institute. And the goal of Existential Hope is actually to seed the hope within the brain of a larger audience than a scientific audience also. So it's basically based on trying to cope with just the vision, the dystopian vision that people can have of the future. So we thought with Alison that the best way actually to make it this existential hope project evolve is to also plug the project of the NFTs inside. So we started to have this quite large collection now of NFTs. So we are actually creating NFTs. We can show another example. So we are creating NFTs that are bridging scientific research with artists. So basically, we pick up one of our fellows from Foresight Institute that is working on some early stage research and linking him to an artist in order to see how the magic is operating. Because what is important also, and I am talking more from a creative perspective maybe here, what is important is to have the art being able also to inspire the scientists and vice versa. So I think what is important is not to only illustrate science, because this is what scientists are doing all the time. They are illustrating science also. But what is important is to have this synergy between the artist and the scientist in order to have this magic operating. So this is what we are actually trying to do with the Existential Hope project and with the NFTs. So to do that, we are creating a sort of guild of artists. So we have a pool of artists and we have a pool of our amazing fellows from Foresight Institute, and we are merging them together. So it's really a new also artistic collective that that we are trying to build right now. So we are working, just to give you a few examples. So this NFT, if you press the keys, maybe we can play this NFT. So this NFT has been created by an artist, but inspired totally by the work of maybe someone knows this amazing fellows, Kai Mika. Okay, he is working on longevity, and he created this project called Cryopets. So actually, Cryopets is a project that can talk to a larger audience, and this is also one of the existential hope goal, is to actually try to talk to a larger audience, because here we are among scientists, we know each other, we understand actually what is at stake with our research, with your research, guys. But with the NFTs, with the certificate impact, for example, if you want to actually have a larger audience participating to the vision of the future, to the way we can like decentralize the way we fund science, we need to actually address this audience. And this is how and why bridging art and science is so important, is to reach out outside of the scientific sphere in order to have like this social movement around those kind of DeSci NFTs. So yeah, this is what we do at Existential Hope.
Wonderful. I should also say that by buying the NFT, you are directly supporting the scientists. So I think one thing that research like university systems currently don't do very well is that they capture a lot of the grant money and only a little bit of that actually arrives at the scientists. And so this is a very decentralized way of like showcasing scientists in a really inspirational manner, and then having the proceeds of the NFT actually go to fund their research directly. Okay, Vincent.
Yeah, so with Molecule, we're kind of pioneering IP NFTs, of course, for kind of, to your earlier point, storing not just like a JPEG, but also actually attached patterns or like sponsored research agreements to the NFT, as well as like the research kind of metadata, like which researchers involved, you have it, as well as like which institution, and then also like you can plug other NFTs on top of that like, for example, do like specific lab computations, and it could all almost like serve as an access key to access all the data related to the research project. So I think that's like one application of NFTs I'm like biasedly very excited by. So we are kind of right now, it's kind of still stitched together. It's working, and we're funded the first 4 projects with 2 million. But the next goal is to kind of like make it like a completely open protocol that like everyone could trustlessly mint an IP NFT, attach data to it, attach patterns to it, attach whatever to it, and almost like a Uniswap pool, make it like completely trustless, which I think is the realization being in crypto since a long time, is kind of the projects like Uniswap that make everything really trustless are the ones that gain the most adoption, because they're like more becoming like a public good of like an open protocol everyone can work with and fork and change and make edits to. So we're really excited to like open this up to other protocols. And like one of our first like close allies, LabDAO, is also like pioneering kind of like usage of an IP NFT more in a data context. But then also to the earlier points, kind of, we also really care about like the art of it, to like catch the excitement and attention also of the science through like an artwork. So we're kind of like trying different routes, but basically also having like really amazing 3D artists like Danny from Ultra Rare doing like amazing artwork on kind of like visualizing also the science behind the research project. And yeah, I think it's really exciting also like to basically for people to understand that like NFTs can be much more than just a JPEG and enable much more ways. And I think like even on the like traditional NFT space, projects like Loot showed that you can even like get creative with the metadata and use it in different contexts. And yeah, I think it's only the beginning of like how NFTs could be used in science. And then also to the impact certificates, like was inspiring to see actually the Y Combinator founder bought like an NFT for 5 million. And basically what the title was like an NFT that saves lives. And like, I think each of like every dollar was donated, and then basically the NFT programmatically, depending on the price you paid, showed how many lives you saved. So like you whatever, saved 5,000 lives with this NFT. So that's yeah. Also, I think like into the like import certificate direction, a lot of interesting pathways.
Yeah, I don't know. I mean, do people here know what impact certificates are? Who knows? Okay, well, maybe, like a word or two to that. It's basically ways in which people can prove that they've been early on in believing in a specific cause and they've been supporting it early on. You can imagine entire marketplaces that spun up by people selling their impact certificates about the science or the researcher or even the risk researcher or whatever that they've supported early. Later on, there may even be whales that buy up entire pots. So it's a little bit like retroactive funding in that regard, that you have, you basically game on the fact that later on, people will realize that you have been early on in supporting something that's very valuable. In a nutshell, is that correct? Yes. And I think these markets are still being spun out, so they don't all exist yet, but we can already create the NFTs that can later even serve as the type of impact certificate. I think one thing that we would need to figure out is really attaching good metrics to that, right? Like if we actually want to track impact, we need to have like good metrics actually embedded in the NFT. Vincent, can you show us, is it on the back? Yes, please show us. So that's the current like VitaDAO, the new molecule, which, yes, with metadata on it. So I think, we are still really, really early stage in all of this, obviously, right? And like, I think we're like learning as we go, but I do think that actually bringing science closer to people is something that is like deeply inspiring and I still think a little undervalued. I want to see whether there's a question from the audience. I want to make this as interactive as possible. Is there a question, comment? Shoot away. Okay, good. Well, then I will continue until I see a raised hand, okay? Wonderful. So can you, we've already touched about this a little bit, with impact certificates. Can you tell us just like down the line, what do you see? Like, we mentioned IP NFTs, we mentioned impact certificates. What do you see like, other different interesting, NFT, either if it's collaborations or if it's like different artistic visions that we could create further down the line? Oh, 5 minutes? Okay, great. So again, reminder to you, if you want to ask a question, raise your hand.
So the end game is impact certificates. The question is how we get there. It's going to take a lot. I think we can start laying down the building blocks, and we have to make this in the most open and composable way. That's going to be very important. Basically, the idea of an impact certificate is you get a credible pledge ahead of time from a whale entity, like a funder. Funders are very risk averse. They don't fund interdisciplinary research very eagerly, as most of us in science have discovered painfully through the years. They don't like to take risk. They follow the path of minimizing errors. They don't follow the path of making big, bold bets. And it's much easier to fund a public good once the public good has actually manifested itself in reality and delivered its value. And that's the idea of retroactive public good funding. So an impact certificate will require funders to make a credible commitment on an idea. And this idea could be, for example, a drug extending longevity. It could be a method of carbon capture. It could be a milestone on a tech tree. And once this credible commitment is done, the idea is that scientists all around the world can work on adding building blocks to converge closer towards this goal until one day we reach it. And the problem of this approach is, as a scientist, you don't have the money up front necessarily to conduct the research. So how do you bridge that gap? Well, this is where impact certificates come in. Impact certificates are a way for people, for speculators, for people that are looking for returns, for people who are looking to make a difference, to make a bet on what research will be fundamental in unlocking this technology, this milestone. And that's why it's so important to get there, because it changes the utility function from a very risk-averse model to a risk-seeking model. It makes science funding closer and much more efficient to the way we do corporate VC startup funding today. It's also, we also have here the chance with blockchain technology to make all of this completely transparent and auditable, and to have no ambiguity around matters, of ownership, about legality and all of that, because everything will be programmatically dispensed through trustless mechanisms. So that's the end game.
I think impact certificates are also like creating a movement, and this is like, that's what we are trying to do actually with the existential hope, with the NFTs, with bridging the art and science. This is like so important to create this movement in order to have the ability actually to have a larger audience participating into the funding of our future. It's like actually making people involved in our future and having them like, when you create an NFT, what is important is not like the JPEG, as you said, is like the future of this NFT, the future that this NFT is unlocking. Like the NFT, the DeSci NFT is actually a key to unlock some potential futures, whether they are like VCs to fund science, they can have like, also we can have like a full society participating into some vision, into some research, into some early stage also, and we can like navigate actually through our society with that kind of tools. So yeah, I think it's super important.
Wonderful.
I keep it super
Last
brief.
words, Vincent.
Yeah, so I think there are like multiple things that I'm excited about. One is also like the financialization actually of, for example, IP NFTs, that you could like basically make science and patents liquid and tradable, as well as like fractionalized, so people could like directly fund science also with small amounts, and for example the 300,000 it takes for a research project, which also in a sense like a DAO enables that sits on top. But then also I think in the very like long game, I completely agree. I think like those measures of like impact certificates with NFTs are really exciting, and yeah, I think there will be like lots of things to like evolve, and I hope like all of it works out. I think there's like a bunch of different experiments to run, and a bunch of them already working, so it's like exciting to see.
It's a really exciting space. All right, I am very, very sad we don't have time for questions, but thank you so much, Eugene, for having us. Perhaps as we go on, just tell us one word about how we can find out more about you guys' work, Vincent. Twitter?
So the easiest is Twitter with my name, Vincent Weiser, and then molecule.to and vitadao.com.
Wonderful. Alex?
Existential Hope and Foresight Institute.
DeSciFoundation.org and DeSci.com for DeSci Labs.
Wonderful. Please give a warm round of applause to our three panelists.
Perfect.
Thank you so much. And yeah, we'll be, I guess, running around for the questions that we couldn't take. So thanks a lot for joining. And
Perfect. Thank you all for getting us kicked off and started with the first panel. Thank you all. Yeah, I can grab that green one. Yeah, perfect. So yeah, we're just going to be transitioning to our second panel of the day with Jason, Martin, Sarah, and Shadi. And I think then we're just going to do a quick repositioning. And let me get one of the mics over to Martin. And we're going to do a camera adjustment. Let me make sure this mic is, oh, right, you're mic'd up already, right, perfect. So y'all will have the two mics up here. And then we can move the chairs over so that y'all feel like you're together in a single conversation. Yeah, so let's do that. So we're gonna have that set up real quick over here. Yeah, of course. Yay on the fly logistics. Yep, it's all good. But yeah, so let's just give a round of applause to the next panel coming up. And I'll pass it off to y'all to talk about the potential impact of DAOs to open science and open access.
Thanks a lot, pal. Can you hear me? Yeah. Awesome. So my name's Jason Barkaloo, and I really am glad you're all here, obviously, early in the morning. So what I'm going to do is lead this panel about how DAOs and open science, open access could potentially be impacted by DAOs, blockchain, Web3. So what we'll do here is give everybody a chance to introduce themselves in a couple of minutes.
Hi, my name is Shadi. I'm a cognitive neuroscientist and founder of OpSci and working on building tooling for the DeSci movement. Oh, you have a mic.
I
So.
have one too.
I'm also a part-time Viking.
I'm Sarah. I'm a group leader at Imperial College London, and I'm trying to move much more of my research into decentralized science, open science. So that's why I'm here, and also starting a new venture in data diversity and drug discovery, which I've asked some of you here about. So yeah, excited to be here. It's my first DeSci event, so good to meet you all.
Yeah, hi, my name is Martin Kodire. I'm a neuroscientist and an engineer. I have a background before I kind of transitioned to the biomedical world in the algorithmic trading space. And I suffered a spinal cord injury about 12 years ago. And I then started looking at science, which I believed could solve all the problems, like going to the moon, etc. This was all something that could be done easily, or relatively easily. And I found a very, very broken system from the scientific side of things, even as simple as a PDF, right? Like it's back to paper days. And I was let down by that scientific system, in that there were no valid therapies for things like spinal cord injury, and I looked at a lot of other diseases as well, and I saw a lot of very promising science that was left on shelves all over the world. And so I also have a background in the crypto world. I've been involved in that for quite a few years, and I see opportunities to leverage decentralized ledger systems and new ways of organizing humans to kind of combine the two areas. And with Fleming Protocol, we're working on a data economy for patient-driven biomedical innovation, so that the patients are participants and part owners in discovery, and that, importantly, that can then composably interface with all of the work that we're all building here today and interact with things further down the stack, which is the actual molecular discovery, or the molecule itself that might be somehow secured via some ledger system, and that we can build this whole composable system. And that's why I'm here, and it's great to meet you all.
Thanks, Martin. So my name's Jason Barklew again, and after a military career in the U.S., which I ended running a medical research lab, pretty large medical research lab, I then took over teaching actually in high schools and colleges. The sciences, did that for 4 or 5 years. And I invented a technology to help people with special needs, and that led me into my very first entrepreneurial endeavor. And this is my 5th startup. I've had a couple of exits. And so sustainability is a really big, important thing for me. And I don't hear much of that in this space. You know, we talk about DAOs, we talk about blockchain, we talk about Web3, but those sound like science projects to me, engineering projects, and I don't frequently hear much about sustainability. So what I'd like to do is ask our panel about what ideas they might have about how we make science, particularly Web3, blockchain, and DeSci, sustainable.
Yeah, I guess I'll get the conversation going. So when we think of sustainability, I think there's multiple avenues of approach or attack. There's financial sustainability, right, which is the first thing that comes to mind. There's social sustainability, right? How do we commit to building protocols and services that can be maintained and that will survive even after maybe the original maintainers have gone on? I believe there's administrative or governance sustainability, right? So can we build protocols that have a core group of contributors that custodian and can transition in and out? So maybe I'll touch, and there's probably other versions of that as well, depending on how wide you want to bridge the definition. But maybe I'll touch on a few of those, and maybe everyone else has some ideas on that, or maybe other definitions too. When we think of financial sustainability, you know, it's important to really, for me personally, what struck me as an aha moment where it was like, hey, you know, I could go do a postdoc, keep my head down, and do what I love, which is developing pulse sequences and analyses and studying the human brain. The aha moment came when I realized, hey, there are open source finance tools widely available right now that I could spend just about the same amount of time that I do interacting with a program officer or preparing a grant or competing for funding, as perhaps deploying an automated market maker and launching a financial protocol that can serve the needs of a lab, for example. So this aha moment, of course, was very far detached from the actual execution of something like that as I've gotten to think about it a little bit more. But I do believe that tokenization is a really significant, important watershed moment in both the internet and in human society and how we organize in general. I believe that tokens allow us to track the value of things that were once valueless, right? For example, data, right? So now that we can actually tokenize and control access to data, we can represent them as these, you know, abstract digital objects that have some indication of ownership or some indication of where they came from and who's provided access control to them. And you can put them into a Uniswap pool or a balancer pool with other tokens that might be collateralized by other tokens, right? And so it's a neutral technology with both, I think, very significant implications in terms of good things and bad things. But one of the things it does is it allows natural price discovery for assets of data. And so you can extend that metaphor, I think, to all of the digital objects of science that might be coming out today as we're in this transitory period where science is transitioning more into becoming a software, to quote Eric yesterday from our panel, and becoming more digital. And I think maybe that's it for, yeah. Do you have any thoughts, Sarah?
Yeah, I guess I can add more from my perspective, which is from, I'm a scientist. So yeah, how we kind of onboard people and getting them involved in this area, in this space. So talking about sustainability, we need people to be in it for the long term, right? Not just for, maybe they do a small project here, a small project there, and that's a great starting point. But ideally, yeah, if we can find a way to make this sustainable for researchers, for people, I think that would be great.
Yeah, I suppose when I think about sustainability from the context of the end users of products out there in the world, and particularly from a patient perspective within the biomedical domain, a lot of the development of products within the pharma industry is about creating a product that delivers a certain improvement in some outcome measure, and then securing a IP moat, as they like to say, around that, so that nobody else can reproduce that. But then the producers of this are quite happy to just leave it at that level and not improve it, even if they can, because there's a newer way of doing things, but that might not be as secure from an intellectual property perspective as the original discovery. And there's no incentive for these big sales and marketing companies like the Pfizers, et cetera, to progress that biology and improve patient outcomes further. Whereas if the patients themselves or the end users of any product, biomedical is one, but you could see it in photovoltaics or battery chemistry or any end user product that I think in most domains the end users aren't really participants in, but the simplest way and the most people with the most skin in the game is the patient communities. And if the patients own or are participants in the development of improvements in their own outcomes, I think there's a lot more sustainability in creating a loop there where the goal is to actually continuously improve the molecule or the deliverability of the molecule or its efficacy or longevity within a tissue, for instance, rather than creating just a flat level. The patients themselves in those groups will continually strive to improve it and sustainably create better outcomes for patients and therefore societies.
Well, thanks, guys, for that. So for me, it's pretty simple. If you can't fund your entity, you're not going to make it. And right now, I think most people in this space are really reliant on grants and that kind of funding. But at some point, you've got to have a value proposition that makes it fundable. And that always means you have to be able to generate money. You have to be able to generate revenues. I know that's anti-altruistic for this group, but at the end of the day, you got to figure out how the world benefits from it, and that means there has to be revenues behind it. And so for another question that I have for you guys, how would, and this ties to funding, of course, because funders like to see intellectual properties, formal intellectual properties behind it, patents, copyrights, that sort of thing. How do you see intellectual properties being impacted by the DeSci movement?
Yeah, it's a very deep question, and I am in no regards an expert, but I'm happy to share my perceptions on this. So I believe that IP sucks. The mechanisms that we have for IP are pretty outdated and useless and unenforceable. If we take a look at the University of California school system, their combined total revenue of royalty in terms of how much they've made from all of their life-saving, society-changing, incredible advancements that have contributed to our thriving as a collective, they're not making anywhere near as much as Elsevier is on charging people and other scientists and other industry practitioners that are performing applied research and development to access their work. So there's, I think, like an evolutionary sort of selection of mechanisms that actually work and don't work. I think the numbers are something like the UC system makes something like $60 or $70 million turnover in terms of money invested in forms of grants. If you subtract that out and you take the remainder, whereas Elsevier is pushing like $600 or $700 million in turnover. So that's after subtracting all the costs for publishing, which are pretty minimal since people are working for free. So I believe in terms of how Web3 can improve upon this, kind of touching back to like why blockchain, why does everything need to be a blockchain, right? Like you get that question a lot. I think it's really important to identify the main value proposition of autonomous protocols in Web3 that run mostly on blockchains and consensus protocols, which is that these systems are always on, and once you deploy something on them, you can't turn them off. And what this means is that every interaction is logged, which has both pros and cons to it, but allows enforceability that wasn't possible before, specifically in how smart contracts are enforced. And Molecule is doing some exceptional work, and I'm really excited to take a look at their IP NFTs and their underlying smart contracts when they become open source, so that we can further explore that and see how we can build and iterate on it. You have one?
IP sucks. Yeah, that's my follow-up. No, I think it's, so I can take an example from my group now where I'm working on the structure of, it's a drug target, and I have to decide what to do with this, right? Should I just release it into the wild where more people would be able to potentially find a cure for this? Or more traditionally, send it to a journal, pay to publish it there. And that will take months as well. So what I'm going to do is find some way to work with some of you guys to release it that way and see if we can do something like that. But yeah, in terms of most people and how we're going to get them to do it this way, it's just, I think you said both things. So IP is messed up, and the whole way we do science is wrongly incentivized. And now we finally have the tools that we can really begin to change this. Yeah. Oh, okay. I won't repeat all of that now.
Yeah, so I got very frustrated when trying to translate or work on translating promising work in a lab into a product for patients, when most of my time and energy was spent trying to create an intellectual property proposition that the traditional investment community would be, okay, that's a good proposition, independently of whether the IP actually really made sense. It was very frustrating to have so much energy spent in that side of the translational pipeline, rather than proving whether the actual original concept was actually going to work in the patient community or the real world that we were trying to deliver the product in. So I think that there can definitely be a lot of improvements whereby the data itself that proves whether something is working or not becomes it's still a IP in some ways, becomes the product that people focus on and where the value is attributed. I mean, the traditional IP system dates back right to 1800s, I think it is, and it gives you the right to exclude other people from operating in that area or producing the product. But what if there was no concept of IP ownership in that way? How would society have progressed? It's a question that I sometimes ask myself and ask others to just think about. So that's, I suppose, a small bit input on the IP.
Yeah, so I think IPs, people say it sucks, but I think right now it's sort of a necessary evil. And again, it's tied to funding. Funders who are very risk adverse. I want you to imagine taking your checkbook out and scratching out a check for 25,000 USD. Just think about that. Do you want there to be some ROI, return on your investment, and would you like a very low risk? Or do you just want to go out with a match and burn that money?
And so that's kind of where I am with IP, is that it's a necessary evil. Now, part of what I think the promise of DeSci is to be a pillar of a much broader idea, which is open science. And this is kind of antithetical to intellectual property, but I'd like to have your guys' thoughts on how you think open science could be impacted by DeSci.
Yeah, absolutely. So it's a bit of a mind turner to start thinking of, oh, well, you know, if something is free and available, then what value does it really have? I mean, I can just go and take it and use it and voila, right? And I think that in Web3, we're challenged to think of public goods in a different way. So for example, developer tooling in the space, it's out there, it's available, but you know, how does it actually become, you know, maintained? And that's where I think sustainable incentive loops come in, right? Either through the form of perhaps protocol fees that are engineered to meet demand, so that they scale up and scale down, so that there's a clear, transparent, you know, predetermined or pre-thought out, right? Like pre-thought out mechanism for if there's a need for this, the overhead is paid for through the need, right? Through the demand. But if it's not needed anymore, then it should scale down and not consume resources that otherwise could be used for other protocols. I think that's just one of the many examples.
Do you want to go first, Martin?
Well, I think that the open science world, when you come into it and you have to pay for all of these, you see like a $39 access fee for a document, and the real IP there, or the real value add, was kind of the copyright or the editorial, and all of the scientists around the world are doing that all for free, notionally for free, but it is attributable to their H indexes, etc., and their publication metrics. It'll improve that ultimately. I think that there's definitely better ways to do that, and I think that even the concept of a sentence or a concept within a publication, that in and of itself, if it's a novel insight, that in and of itself could be attributable and owned by the person that created that. And I think that that's a new way of looking at how we value insights and publications and the data that supports that. And I think that we can figure out and create ways to fund that through, as Shady said, kind of small transaction fees on the usage of this that flows through all of these new decentralized systems that we're trying to build. And being able to historically access that and know really what happened back 10 years ago when it was originated is very valuable, and the market will define the price of that.
Sarah, can you finish up here? We've got 1 minute left.
I saw that, yeah. No pressure.
No pressure.
What was I going to say? I don't know.
Open science and DeSci impact.
How does your lab pay for open source tooling?
Yeah, so right now, actually, I'm funded by UKRI, so I'm only speaking from the UK perspective. But everything that I do in my group has to be open, published at least. But that's not the same thing, right, as open access. So I don't have a choice when I publish something, but I still have a choice whether to release the code behind it or how accessible to make it. And for me, I think that in the end, how I'll be defined as a scientist, it's all about your reputation and who comes through your lab and what they do next and who's using your tools. So the incentives are kind of there in the background anyway. But yeah, I guess we could make it more accessible, I suppose.
Well, thank you. And I really appreciate you guys being here, and hopefully we can take some questions from you offline. And thank you to the panel, and thank you so much, Timer.
Thank you to everyone for joining this panel, and we will be transitioning now to the next panel. Thank you, Martin, Sarah, Shadi, and Jason. Yeah, and I'll move those. Don't worry about that. Thank you very much. And so the next panel, we will have myself as moderator. We will have Kat from VitaDAO. We'll have Eric from DeSci Labs and Lily from LabDAO. So please come on out on stage and give them a warm welcome as they come out. Here's a microphone for you. Microphone for you. Come on up. All righty. So I guess let's find out what happens when I sit on this mic thing. Everything is fine. Great. So thank you all for joining this panel, the title of which is Governance, Diversity, Partnerships, and Onboarding. So, a few light topics to quickly cover in 20 minutes. But I guess just to start it off, it would be great to just do a quick introduction, and then we're going to jump and start on the governance side real quick. So let's just do quick intros going, or I guess, Eric, you want to start, and we'll go this way?
Sure, absolutely.
And yeah, make sure to keep the mics close.
Yep, you got to keep the mic close.
Yeah.
Hi, everyone. My name's Eric Van Winkle. Been in the Web3 space for a little while, focused on DAOs, and I'm currently lucky enough to be running operations for DeSci Labs with a focus on community.
Hi, I'm Kat, and I do operations at VitaDAO. Recently, I've been doing onboarding and governance.
Hi, I'm Lily, and I'm with LabDAO. I do UX and community there, and I guess a little bit of operations as well.
You might need to project a little more. I know it's early.
I have allergies, so I'm very congested.
Yeah.
I'll try.
Got it. Oh, no, I'm good, yeah. And hi, everyone. I'm Eugene. I'm the head of operations at the Smart Contract Research Forum, or SCRF, and very excited to get into a couple of different topics with y'all. So I think it would be interesting to start off of what are some unique challenges or what are some of the very interesting points in your own minds when you think about governance around DeSci projects?
Sure, happy to start with this. One thing to mention, I think it's incredible to see the space growing as fast as it is. It's amazing to see so many new projects popping up so incredibly fast. And this is an area where experimentation, or this is an era where experimentation in DeSci is going to kind of define the space. So to me, I think one of the most important things is that we have a large number of projects just throwing things at the wall and seeing what sticks. The problems in science aren't easy. They aren't simple. They aren't something that can just quickly be solved. What we really need is large numbers of smart people trying creative solutions. And I think that's exactly what we have right now. So that would be my answer there.
Yeah, to Eric's point, I've been pushing this idea for a while now that we should all just have a governance experiment now and just get people there and try out all crazy experiments. So if someone wants to do that, just talk to me. But to the point of specifically in DeSci, I think I've seen two different challenges. One is that you have this mixed group of scientists and you have this group of crypto native people, and they don't speak the same language, and sometimes you have to guide people to very basic steps, like what is MetaMask, how do you do transactions, and that's just very difficult. And the tools that we use, Discourse, are like foreign to them. I forgot what the second one was, but I'll leave it as that.
Yeah, I think just to expand on that a bit too, I think there's, those two groups are managed differently. They're not used to the same sort of, people coming from science are maybe used to a more hierarchical sort of decision-making process, whereas the Web3 crypto native people may be a little bit more open in the directions of how decisions are made, for example. And I think there's a little bit of friction there sometimes, trying to come together and figure out what works for both groups.
Actually, yeah, just to expand, I think that this is going to be a huge point for the space moving forward. And this is something I got the chance to talk a little bit about yesterday, but bring it up here as well. There are two very different cultural ideologies between academia and software. So for reference, I come from a more software product development, product owner background.
where everything that I have been taught is fast, is speed, is get it done, push it out the door. You'll fix it after the MVP, then you get the pilot, then you get, the actual version 0.1, 0.2. You can keep working on it. The project is never finished. And kind of coming into academia or into this DeSci space and interfacing with academics, part of what you see is that if you make a mistake in a paper, if you report findings that are wrong or incorrect, that issue propagates. There are network effects behind it, so there is this expectation of perfection in scientific research that is just 100% not there in software. In software, you're going for speed, you're going for fast. In academia, you're going for precision and accuracy. And to me, I think some of the cultural differences there are going to play into the space, into the governance, into the onboarding. Quite frankly, it's going to permeate throughout. So I completely agree with Kat and Lily on this one. That's going to be huge.
And so I guess building on that then, especially recognizing that, there's this Web3 audience coming in, there's this scientist academic audience coming in, and then who knows where the stragglers are jumping in from other spaces, but at least those two very different domains and cultures. How does that complicate onboarding in your minds? And feel free to share that either from your own experience of going through onboarding into this space, or more from the perspective of designing onboarding and how to help people recognizing some folks might not know what MetaMask is or need help setting up a wallet, while some folks are going to be fully in on that side but not actually know anything about how the scientific process works.
So this is something I've been thinking about a lot lately, because we're trying to figure out how exactly onboarding works for people that come from a really diverse set of backgrounds. And I think that, you could have, for example, with LabDAO, we have wet lab scientists, dry lab scientists. We have people that are onboarded into Web3, people that aren't onboarded into Web3. We have people that are, know how to use GitHub, people that are not familiar with GitHub. There's this whole stack that you have to figure out where everyone is new and where everyone already has experience in it. So I think at least, suggesting a solution isn't great, but the way I've been looking at it is trying to personalize onboarding as much as possible so people don't feel overwhelmed, because it's very easy in this space to feel, as a scientist coming into Web3, what's Discord? What is, I have to download a wallet app. Is that the one I have on my phone? What's going on, And on top of that, you're learning all these new concepts and all these, it's exciting, but it's a lot of information. So figuring out what information people need to know, what they need to download, and what they don't need to be told to do, at the beginning.
Yeah, I think the right information at the right time is really key here. And to your point, the two different groups makes onboarding a very complicated process. It's entirely two different onboarding process, and everyone is overwhelmed. The crypto natives get overwhelmed by the science and vice versa. And so, and we also have this question of what does onboarding means? Do we want to onboard people? Do we don't want to onboard everyone and get them to start contributing? I mean, that's a lot of work. Or at VitaDAO, at least, we see onboarding like a matchmaking process. We help contributors get to the DAO, but we also help the DAO figure out who has what skills and who can contribute and who needs upskilling and so on. And so there's also a question how much do you should how much should you make onboarding extremely easy? Because maybe you want some natural filter there as well. But I think what we're seeing, it's really interesting, is that onboarding has become this Schelling point for a lot of DeSci communities and DeSci DAOs. And because we're seeing that we are basically solving the same problems. And so we've been talking a lot about how do we solve onboarding together.
And yeah, just to expand on that, we have been, and I personally believe that onboarding can be a public good for the ecosystem. And it could be something that actually drastically improves user experience into DeSci. So instead of a scientist trying to figure out how to onboard into 90 different projects, There's one standard onboarding where you learn, okay, here's what a wallet is. Oh, should I give away my private key? No, unless maybe Eugene asked for it. I don't know.
Even then, don't trust me.
Yeah, don't do it. And just kind of thinking about onboarding as that kind of a public good to bring people into the space. Two other things that I wanted to mention with respect to this point right here. Number one, nobody cares about the fact that you're on blockchain. And it kind of hurts to say a little bit, but for most end users, they just want better technology. Blockchain, is an incredible backend with unreasonable potential. That being said, people get scared by technological concepts. It can be a lot to learn. It can be a lot to pick up. So one huge point for onboarding is in product development, trying to abstract blockchain out of the user interface, trying to make sure that it has whatever platform you're building or technology you're building has a very familiar feel to it, is going to make onboarding so much easier into a community, into a product, into a platform. Then a third point to bring up, a lot of scientists tend to be very reputation focused and can sometimes be a little bit skittish by nature coming into new technologies. It's got to be something that's proven out. Blockchain and Web3 doesn't necessarily have the best reputation at all times. You have people trading dog coins for monkey pictures, and it can be a lot. So I think it's important for us to focus on the technology that goes into it and conveying the benefits that can be given there, while still having that familiar user interface. To me, those are huge onboarding points.
I think I agree with you on the abstracting the blockchain part.
Yeah.
And I've been kind of adamant about that for a while, but I'm starting to come around more to the, specifically with scientists, that as users, they're the type of people that want information on like how things work. So this is doing this. Why is it doing that? Like what's the background on this? As a use case, like they're very curious. So I think there are ways to, not. I always say like, don't put the word crypto in the first paragraph. It's not, it's going to scare some people off for sure. But having that information available if they are curious to learn more. And I think that's really like, specifically for science, that's a way that we're going to get people actually interested in this technology and realizing the potential of it, is like having the resources available. And I also do agree that I think that having an interface that's familiar, because when you look at a lot of tools that scientists use right now, it's like maybe an Excel spreadsheet, or, so jumping from that to some of these Web3 like dark mode with bright purple, like and everything's squiggles and is all animated. That could be a bit overwhelming. They're like, oh, this is maybe not my space. So keeping it consistent or at least a little bit familiar is very important.
Yeah, and I think it's an interesting balance to toe between wanting to be fully transparent and open, and it's like, hey, here's the GitHub repo and all the code. But to your point of what you were just saying, Lily, of if the word crypto or going to the moon or anything along those lines is anywhere, especially early on in the pitch, eyes have glazed over and no one's paying attention already, and there's so much skepticism that, yeah, it's an interesting balance to toe there. But I also wanted to, touching to one of the other four massive topics that are in the title of this panel session, I wanted to specifically kind of look at the intersection of onboarding and diversity. And because, we're just talking about diverse backgrounds from the perspective of just like different domain exposure and expertise, but both of those domains individually, both science, academia, and on the other hand, Web3 have their own massive diversity issues. So in your opinions, have you seen anything that sort of, especially from the onboarding perspective, that really helps with initially bringing people in who might see themselves as the only contributor, as a female or a person of color or someone with any other kind of cognitive or physical differences of any kind, just anything that you've seen that kind of can make it more welcoming in that environment?
So when I first joined DAO, I remember my first day joining the Discord. And then I started talking to the people in the Discord a little bit. And then this woman, Beata, and also Ariella, they're both long-time contributors to the DAO. And they just pulled me into this private group chat and like, hey, we see that you're a girl. We don't want any girl to leave. Please, like, stay here. And then there's like this woman of VitaDAO group chat. And then I wasn't really, I mean, that was a good thing. It wasn't something that I was looking for, but I think it was good in that getting into a Discord can be really confusing for anyone really, male, female, like any background. And having like that small group chat when you feel like you could just ask questions and people are starting sharing their experience openly through that like common connection, whether that's being a woman or something else, was really helpful. And I mean, it's hard to say the counterfactual, right? But I think like I attribute a lot of my like involvement in VitaDAO to that. So.
Yeah, I think also, you know, like seeing these like the women in Web3, sorry, in science and Web3. What's the order? Anyway.
Yeah, I think it's women in Web3 area. Yeah.
You know, those groups starting up and kind of creating this community, and it feels like, okay, well, you join that, and you kind of meet some people there, and then you can join another Discord or, you know, a group and see, okay, well, I actually know this person already from that group. So even if, you know, X DAO is not super diverse or friendly and they haven't really worked out their onboarding yet, at least, you know, there's this community that you're already a part of. I don't think that's the solution, but right now, like a long-term solution, it should be on the responsibility of the DAOs to make people feel welcome and comfortable. But at least there is a sort of community growing that's kind of pushing for that a little bit more. And I think that having that visibility has made people start to think a lot more about, okay, how do we make our environment a bit more welcoming for anyone who isn't the majority, which is, you know, a lot of men, a lot of white men. So anyone that's in that secondary, or not secondary, anyone who doesn't fit into that mold. I think that also, you know, there's very basic things in just the welcome page on a Discord that you can include that, you know, like a code of contact, you know. And just seeing that, most people are going to skim that. But someone might see that and feel a little bit more comfortable. Like, okay, if someone is like homophobic here, I can actually refer to this and go, okay, this is not okay, and I have that there. And having, for example, pronouns available that you can put as a tag on Discord, you know. Some people won't interact with that, and some people will even be scared off by that, which is, you know, probably a good thing maybe. But having that there really makes, it's just a small thing that can make people feel a lot more welcome, I think.
Yeah, and that also makes me wonder then with the last of the massive topics as we hit our, we're hitting a last minute, so we're not even going to get to touch on partnerships overall. So let's wrap up. I guess we touched on onboarding, on elements of diversity, on another topic that was at the governance. I had to look at a cheat on that one. But any kind of final thoughts as we're getting started, as we're organizing folks together, kind of what things do you want people to be keeping top of mind when it comes to these big challenging areas?
Yeah, absolutely. I would say focus on community, focus on experimentation, and as much as anything else, focus on building. Right now, if you don't have a product, there's really no point in governance, so definitely just keep throwing stuff at the wall. I love all the discussions, and it's exciting to be a part of.
Because we have this, VitaDAO, we do longevity funding, so we also work not only with scientists, but also with universities and what we call tech transfer offices to work with the intellectual properties. And like a while ago, we were so excited to find this guy, this professor in the tech transfer office at Newcastle University or something. He was both a professor and a DChan, like a DeFi DChan. And we were so excited about that, like, oh no, they exist, this is probably the only one. But what we're seeing is that like there are, you know, early users of like from the science side, and getting them on board is really huge, and they're already very open to it. And when we're talking about onboarding, partnership, governance, I think those are the people that you want to get to first, right? And then they will help spread the message. Like if you have a successful product, you welcome them to the community.
Yeah, I think just echoing that, I think onboarding and making sure that you retain those people, like you keep them interested, you keep them involved. You know, if someone is really excited at first, but they just don't have something to do, find something for them to do, or suggest something, you know, because getting involved in the community is going to be what gets them to stick around, and tell their friends about it and tweet about it, and that's how this organic growth is really important at this stage, I think. So.
Yeah, and thank you to the three of you. Let's get a round of applause for the panelists here. Thank you all for joining. And so next up, we are going to have the first of our demo presentations. So we will have Joshua Bates coming up from DeSci World. Let me go get Josh real quick. There we go. Oh, yeah. And we're going to keep the fun hat party going because we're at an improv theater, so why not? Oh, that's the wrong one.
Test. Hey.
Yeah, you're good. Yeah, that's the one that's connected. There we go. Lovely. Take it away, Josh.
Hello, everybody. I'm Josh Bate, and I'm from DeSci World, as you can see here. I'm trying to channel my ancestors here, but I don't actually know if they are my ancestors. I think there's some DNA testing projects in this crowd, so please let me know afterwards, because I don't actually know if I have Viking blood or not, but I was told to wear this, so I'm going to take it off now. Okay, so this is the launch sort of reveal for DeSci World, which is a project I've been working on in the background of my life for about 6 months now. As you can see, we like design, we like color, this is our kind of thing. So DeSci World, our motto is to shine a light on the world of decentralized science. Originally, I started this project as an NFT project because I was experimenting with some friends about basically bringing art to the metaverse and to science and research. When we were doing it, we actually named the project DeSci. We said, oh, what a great name, DeSci, catchy. And then realized that there was a whole bunch of stuff happening in DeSci that we didn't realize was happening. So we decided to pivot entirely from this NFT project to basically build an information aggregator, like a dashboard, sort of like DeFi Pulse or DeFi Llama, but for DeSci. Okay? So we believe that with community, research, and a disruptive ambition, that we really can challenge the status quo. And for me, that's why I started this project, because I wanted to see a bit more challenging of the status quo from as many projects as possible. And I think that DeSci is the perfect breeding ground for that kind of disruption. So we have three products at DeSci World. First one is a dashboard. So an information aggregator. It contains links and concise information for you to interact with individual projects. To begin with, for this MVP launch, remember, only an MVP launch, we have 8 projects listed, and I'll show you them afterwards. You can get information about the project, about the token, about the governance systems, about recent developments, this kind of thing. We have a DeSci job board, which will be basically everyone that onboards with us. We're going to ask them, do you have any positions available for your work? And people can come to DeSci.world and get a very high-level overview of what jobs are available. We have a blog, a podcast, and we have an aggregated events calendar, which I will talk to you about again in a bit. Just going to quickly show you. This is the new front end. Can I get a woo? Nice, thank you. Yeah, so this is the new front end. This is the landing page. So you can sort of come here, get a nice view of the sort of thing we're going for. You can have a read for this in your own time when I show you the link. So you can come down here and you can see here, this is like an NFT spotlight, okay? So part of the project that we have is the dashboard for information aggregation, but we're also doing this sort of NFT launchpad and spotlight service, which I'll give you some more information on in just a sec. So we have this NFT launchpad and gallery. I know we have a friend, Emmanuel. I can't see you because of the lights, but Emmanuel is in the crowd, and he is launching an NFT project, and he's doing it through DeSci World. So our first launch project will be through DeSci World, and that is going to be live in about a week's time. So we essentially assist researchers with NFT launches. Anyone that has great visual data and wants to sort of make it onto the blockchain but doesn't know how to, we can help you with the NFT launch contracts. We're hoping to promote the beauty of science and research, especially with data-driven research as it is right now. Lots of great visual things that we can see that people don't really appreciate. Connect artists and researchers. Lots of researchers around without much of an artistic flair, and likewise artists without much of a research background. Connect those two through DeSci World and launch these great NFTs. showcase further DeSci art, and we want to standardize NFT data sets as well. So there's an idea of basically providing standardized NFT data sets for a variety of different reasons, and we're hoping to deploy that through DeSci World's NFT launch contracts. Oh, just going to show you here. Okay, so this is like, for example, the NFT Spotlight. So for launch, we have our own NFT, which I said at the beginning. This is currently in the Spotlight. You could come here, click mint, get some information about the NFT. You can check out on OpenSea. You can mint directly through the website, get some more information from the collection. If you come back here, you can see here, full market on NFTkey.app. These guys are good friends of mine, and we've partnered with them. So DeSci World and NFT Key have a partnership. NFT Key is a multi-chain NFT marketplace. It's a curated gallery. So you have each individual collections, you click on here, and each individual collection has a decentralized marketplace here. So what we've done is they've basically given us NFTkey/DeSci as a domain, and we're now basically creating this curated DeSci-based NFT marketplace. Multi-chain, so anyone that comes, not just through DeSci World, we'll also connect everybody directly, but anyone who wants to launch an NFT project and wants it to be in a showcased gallery, this is a website where we now have that available for the whole of DeSci. So DeSci World is trying to basically just like lift up the whole space as much as possible, but in particular provide some kind of infrastructure, decentralized infrastructure. Okay, so moving on. I'm somewhat conscious of time, and I want to get to this, so I'm just going to skip to this because it's most important. So DeSci is an incredibly collaborative and connected space, right? Everybody is always doing Twitter spaces and AMAs and just general calls in general. So the idea of DeSci, in my opinion, to flourish needs an events calendar. We do have a current solution, which is a public Google Calendar, and it's a nice solution and it works, but I don't think it's very scalable and it's not Web3 native. So to maximize the efficacy of DeSci networks, we need an aggregated events calendar. So this is a call to action from DeSci World to the rest of DeSci. Please, I'm going to show you a platform just in a minute. It's called backdrop.so. We're going to release an article, and we're doing an AMA with them, and we're going to run a Twitter Spaces in the coming week with the Backdrop CEO. But basically, it's a Web3 native events aggregation system, and we want to integrate it across the whole of DeSci so that we can start to move towards a unified Web3 solution for events aggregation. I'm just going to show you it right now. So this is Backdrop. Okay, they're really great guys. You can log in with your MetaMask, go to profile. So DeSci World is my wallet, but we have here the project that we're involved in, which is DeSci World. I don't know if you can see clearly here, but you can see, this is the project here, and this is the one that I'm a founder of. So we go here to the project, and you can see a whole bunch of information about it. Here you can see the people that are involved in it, and here you can see the activity, which is the events. I'm just going to quickly walk you through the events creation flow. So here, just click create event, create a cover, the name, DeSci Day Test. So the description, we're showcasing the events calendar. So here, it says which communities are hosting this event. So obviously DeSci World is hosting, and I just tagged VitaDAO. Thank you for being a guest. So this means that anyone that is following either DeSci World or VitaDAO will receive push notifications via email or EPNS from that subscribed DAO. So if you're only following VitaDAO and DeSci World has an event including VitaDAO, you'd also get pinged. Here again, you can have speakers onto that also. So if you're following me and I sign up as a speaker, you will get notifications that I'm speaking. Date and time, standard, location. So here's another interesting part. So you can see visibility. You can choose members only or public visibility, and for attendance, you can do members only or public attendance. And this basically means if you have a token that is required by that DAO or by that organization to be a member, so for example, if for VitaDAO, you'd hold the Vita token, you can have it so that your event is visible only to holders of the Vita token and is only attendable to holders of the Vita token. So this is a really interesting Web3 integration that most projects in DeSci will probably take advantage of at some point when they release a token or an NFT. Again, it's not completely necessary to have token gating, but it's just something that you can have. This whole integration with hosts and speakers, I think will be really, really valuable for the whole space. And moving from this, let me show you. So here is the front page of the dashboard, which is sort of again, staging area, so please bear with. But like, for example, here's the VitaDAO page. 1 minute. Here's the VitaDAO page you can see. Okay. And just quickly, this here should be an events aggregation calendar, okay? So what I think is really important, we're going to release an article today, so please put out for that. I think it's really important that we come to a decision on some kind of unified choice of an events calendar, and I think Backdrop is the best option for that. I encourage you all to go and look around on it, and for the future, if you'd like to support DeSci World, these are the things you can do. You can contribute to our community. Please go to @DeSci World on Twitter and join our Discord. You can connect us to other projects, to other researchers, or to resources that you think will help. Share your ideas with me directly or with the community. Apply to be a core contributor if you're interested in working in DeSci and haven't got any sort of experience in the field. Or you can purchase a Microbes NFT, which is available at dci.world/NFT. I bootstrapped everything myself, so this is very helpful if you do that. Thank you.
Thank you, sir. Let's get you unplugged. Cool. All righty. Thank you again to Josh showing off some of the cool stuff they're working on over at DeSci World. Next up, we're going to have Rand coming up to talk about bridging, there we go, bridging NFT to traditional culture. So please, Rand, please come on up, and yeah, the floor is yours.
My name is Ran. I'm the founder of Ranado. Ranado is a virtual museum for handcrafts that we established in Paris in 2019. So thanks to the French Tech program. I personally have been doing research on this cryptocurrency and CBDC field in the past 5 and 6 years, but I'm very interested in connecting every domain in this very dynamic new field. So today I'm going to talk about my new findings about bridging NFT to traditional culture. So the thing that motivates me to do this project is as this. So as you can see at the left-hand side is a single pixel NFT art that is sold on OpenSea. It values $751,000. With this price, you can buy a really nice small studio in Paris. And on the right-hand side, this is a pottery museum that I visited last Sunday in a small town in Holland. This pottery painter, he has to practice decades to make a masterpiece. So what should we bring to Metaverse? In our trips to interview all these craftsmen, almost all of them are the last generation to do this business. So today I'm going to divide my topics into 2 parts. The first one is I'm going to explore the possibility to connect the digital and physical products on NFT. And the second one is I'm going to explain how to use the blockchain features to protect the cultural heritage. Actually, there are a few existing projects already. And the first one is that I found out OpenSea is a hybrid project that link an NFT art and a physical painting that is signed by the artist. But the problem is, as is stated on the OpenSea website, the OpenSea doesn't really take the responsibility to the physical part shipment and logistic. It's not like Amazon or Etsy. And the second one is Whiskey project. It's a very popular use case in this domain. You can reserve an NFT bottle in the next 20 or 30 years when the cask is bottled. But the problem is there's no insurance for this possibility in next 20, 30 years. There could be a risk for the redeeming this bottle. And the third one is the NFT project. It's called Currency. It is created by a British artist. There's 10,000 copies of these dots. The interesting part is you can choose either physical or digital version of this art. Once one of them is chosen, and the other one will be destroyed. But from what I'm understanding, the physical version of this art is a little bit devalued because the owner will take the responsibility, will take the risk of the responsibility of the logistic process. So how we do it? How we do this subject? Renado started this NFT project early this year. We created 2 types of NFT to explore the possibilities. And the first one, the left one, is a normal traditional NFT. And so we use these small objects that we bought from Morocco. It's a wood turner objects that inherited 4 generations by a family to express how we understand the urgency to preserving this traditional craftsman. So we use this to create mimic a symbol of Ethereum logo for expressing what we should bring to metaverse, what we have to give up to enter metaverse. And the right-hand side is SFT. It's combined with the digital version and physical version. I'm going to explain further. So what is SFT? SFT stands for semi-fungible token. A very classic use case of this concept is concert. For example, if you're going to the last concert of John Lennon, you can buy a fungible digital token by spending $100. And after you attend this concert, this fungible token turns to be non-fungible because you cannot use it in the real world anymore. It becomes a collectible memorial digital version. And at this time, the value will be changed as well. We don't know. Maybe it values nothing. Maybe other people would like to collect it, and it values a lot. Who knows? And why handcrafts could be possibly mimic this concept? First of all, handcrafts cannot be massively produced, such as the concert tickets. Because the concert ticket, you cannot have unlimited John Lennon concerts in this world. And secondly, normally the handcrafts, the value is modest. It's not like luxury products that you have to trace it in every transaction. For the modest value products, Renado only ensures that we transfer the physical, this 100% wood box to the first customer, but for the future physical product transaction, we cannot really guarantee, and it's not worth the time and effort to guarantee this part. So in order to realize this function, there are 2 blockchains that we can use. First one is the Ethereum blockchain under 1155 standard. However, if you use 721 standard, you can only put 1 copy to 1 NFT. And the second one is Polygon chain. It's the second layer of Ethereum. So with these 2 chains, you can list multiple copies. Oh, why there's no video? Actually, there's some problem with the PowerPoint, but no worries. So this is a process that we do this experiment. We listed 100 copies of a video, like 15 seconds video on our NFT on OpenSea. Well, you can just check it later, but it's a process that how we make these projects. And when you purchase one from OpenSea with Ethereum, you own 1 copy. And you can contact us by seeing the unlockable content. And with the future logistic shipping information, we will ship you these physical products. And this physical products has serial number in the back. And this is the 15th of the 100. And this time, NFT, this SFT become NFT. Why the NFT is also valuable? Because we have online exhibition that you can use it for educational purpose. So, it comes out perfect, but it's too late. Anyways. So for the future project possibilities, the blockchain, a smart contract as is essential actually states, is possibly to use it as protect the traditional culture by using its authenticity features. And because this happens a lot in the fashion industry, the brands just copy the traditional patterns and motifs into their own designs. And secondly, we can build new blockchain, maybe, especially for this feature, because this case does not exist in our world yet. So ultimate goal is to build economic benefits to craftsmen and let us to remember what our ancestors, the spirit of ancestors brings to us. So thank you. Please check the related resources and thank my co-founder who's in charge of the design work of this amazing project. She's also here today.
So much, Ran. Perfect, thank you. Great, thank you again, Ran. We did have a schedule break. We're running slightly behind, and bringing us perfectly back to time, we'll be skipping that break. So obviously, please feel free to grab some water, use the facilities as needed, but we do want to keep the programming on schedule as much as possible. So with that, I will be inviting up Shadi Eldamadi next to present on something from OpSci. So a round of welcoming for Shadi.
Hi, everybody. Long time no see. So I'm going to give a quick recap, kind of about what OpSci is, what the DeSci DID registry is, and why we're doing that. But I want to make sure that everybody who's here today has an opportunity to enter themselves into the first academic social graph that's put on chain, right? That links your off-chain academic activity using OrcID with your on-chain reputation and history. So if you'd like to be a part of that, please do get started by downloading MetaMask, or if you have MetaMask already, make sure it's updated. Scan this POAP, and when you scan this POAP QR code in MetaMask, use MetaMask to do that. And if you don't know how, just ask someone next to you. And this will airdrop you all the tokens that you'll need to get through the demo. All right, so now that I got that out of the way, make sure I didn't forget to tell you guys that. Hi, everybody. My name is Shadi Eldamadi. If you were here earlier, you probably caught my intro. I'm a cognitive neuroscientist building tooling for DAOs in DeSci. So I started OpSci about a year ago to kind of think about how I could make my research better by running my lab in the cloud and taking principles of open source with me and putting them into the tooling, open science and open source, and putting them into the tooling that we use for DeSci, or for science in general. So this project actually started out of a need that was demonstrated when we were working on a Filecoin grant to archive large amounts of data on Filecoin to make it available for other researchers. And so we realized that if we did deploy a decentralized data commons or data marketplace, that we would need strong guarantees of identity. So we put out a call in January to our community at the OpSci DAO halls to start thinking about how or what's a transcendent academic credential could look like in Web3. We put out that call, and then at ETH Denver, we put together a pitch for the hackathon. And that hackathon, we assembled a team, and actually we built something, a working, functioning product that was able to store ORCID credentials on chain. ORCID is the identity tool for academics, if you didn't catch that already. And won a couple prizes, and then we doubled down over the past couple weeks and pushed this demo out for you guys to take part in today. All right, so autonomous DeSci protocols need an open and persistent identity layer. Okay, so we have OrcID. That's the Web 2 version. What it's there for is basically allowing researchers to prove, not even really prove who they are, but to like make sure that a particular researcher's name matches up with their academic history, and so you prevent issues of impersonation, supposedly, or at least assumedly, impersonation or mixed identities. It also allows for tracking of research activity across different journals and websites. So when you publish a paper, you're supposed to use your OrcID. They highly encourage that you do that so that you can kind of have your research accessible, not only your research, your peer reviews, your data, and so on and whatnot. So as you can tell, OrcID will only work if there's widespread adoption. And they're doing pretty well, actually. Right now, there's like 50% of scientists have been reported to be using OrcID. But again, that's kind of clustered within very specific countries and cultural practices. So I've been talking about DeSci and DeSci dApps. What are DeSci dApps? I mean, this space is brand new, it's nascent. People are building, and we have only a few examples of what DeSci could look like. Here are a few hypothetical or work in progress dApps. So for example, one thing that distinguishes Web3 from Web 2 is that protocols on blockchains or smart contract consensus layers are always on. So what you can have is a permissionless automated journal where anybody can submit a paper permissionlessly, right? You don't have to go to an editor and query them. I mean, maybe there is an editor you could talk to, but you don't need their permission to do so. And then all of the matching between peer reviewers or with resources for archival and so on and so forth, for cross-referencing, cross-listing, is all done in a way that there is no centralized party that's performing that or maintaining that. It's a protocol, it's a public good. So some other examples could be decentralized data or protocol markets for laboratory services, kind of like what LabDAO is doing. And of course, on the back end, we're really effectively building the first interoperable knowledge graph in DeSci. That's something that a lot of us, I believe, here are striving for. So what do DeSci dApps need to succeed? The data needs to be interoperable. So linked data from LabDAO, from NeuroDAO, from Axon DAO, from all the other DAOs that I can't all mention in the space that I have, needs to be portable, right? So if a user is interacting in one ecosystem, they should be able to take their reputation, their history, and bring that into another ecosystem and contribute to the ongoing knowledge graph. Credentials need to be verified, and this is a safety feature against permissionless apps. Right now in Web3, permissionless is actually a bug, not really a feature. Anybody could, at this point, if we just use OrcID as is, could submit a paper as Albert Einstein and assume his identity and his reputation and use that to wreak havoc on ongoing debates about nature of universe and cosmology. Another really important thing is to be able to maximize discoverability. So where the graph structure is embedded by default in the protocols that we use and not after the fact where we take existing data and then do meta-analyses to plug it all in. It should be just a feature of the infrastructure we use. And then some other kind of really important, but I'll just glance over these because I really want to take you guys through the demo, is it needs to be user-owned, right? OrcID claims to be user-owned, but it's not. It's running on services that are operated by OrcID. There needs to be transparent governance. So the community, the people that actually use the service should have a say in how it runs and how it's organized, and what the rules are for payments or sustainability long-term for the project. Developers need to be able to use it really simply. All right, so to solve this, we built Holonym. It's a decentralized identity layer for DeSci web services and apps. So it's actually an on-chain protocol with a smart contract library that you can import the module, and you can perform different actions on identities that have been stored on-chain. So what this enables are actually very versatile web views on web applications that can generate views on the underlying data. The DeSci DID directory is just one example of that. Anybody could write a front end that resolves the information that's being stored on chain along with any other linked metadata that's associated with that. For example, resolving papers or maybe token gating things or based on activity, and I'll give you guys an example of that. So the name actually comes from Holonym. It's in respect to Nick Szabo, who you guys might know as a original CryptoPunk. In '94, he published one of the first instances of describing smart contracts, and then in '96, he came back and talked about virtual persona and how important pseudonymity is on the decentralized internet. So he called these NIMs, right? NIMs are little pieces of information about a person. I have 3 minutes. Wow, I'm talking way too much. Okay, so let's do the demo. Yeah, so if you want to get started with this, go ahead and download MetaMask. Here's the link. You can open up MetaMask and do so. So I'm just leave that up there one more moment. I see a couple people with their phones out. If you haven't, please do claim the PO app. You will be airdropped some XDAI. And go ahead and scan this code to get to opsci.io. And once that happens, you'll be able to, and if you're not able to follow, you can just, here's the POAP code again one more time. You can go to versa.opsci.io. It'll prompt you to switch to the Gnosis network. Just wait a second for the smart contracts to load. Then you'll be able to create your ID starting with your bio. And you'll be submitting for fractions of a cent. So this is, XDAI is priced 1-to-1 with the US dollar, so these are really, really cheap transactions. You can add your other identities, like your OrcID. And you sign 2 transactions. It's a commit reveal. I won't explain that now, but it's important to prevent front running in case someone wants to steal your valuable identity. And then you can add more accounts. So when you do create your account, you'll be able to create a QR code like this, and if you scan that, you'll be taken to my profile page. So if you want to follow me on Twitter or see my publication history, which actually isn't linked on ORCID, but I should probably do that, or send me an email, you can do that by scanning this QR code. And you can also do that with each other if you'd like to. And I think that's it. If you do have any feedback on this, we are giving NFTs to people who complete our user research survey. Thank you.
Thank you, Shadi. Thank you very much, Shadi, and cool idea rewarding folks for user research. So now we're going to have a slight reshuffling of the schedule. So apologies for me doing that on the fly with y'all. But next up, we're going to have Sava come present on crowd-funded cures. So please give a warm welcome to Sava. Thank you. Here's your microphone. And yeah, you have full control of the slides here.
Crowd-funded cures. I'm a patent attorney and lawyer, but also did biology, so I'm kind of a frustrated scientist, but never really made it into it. But this is a chance to bring all that together. So today I'm going to be talking about pay-for-success contracts and IPNFTs, which are a new financial model for developing public good medicines. So as I was saying, we're from crowd-funded cures. Our mission is to lower healthcare costs by repurposing off-patent drugs and nutraceuticals with these financial instruments called pay-for-success contracts. So at the moment, healthcare costs are soaring. It's around 20% of GDP for the US. And also there's a principle called Eroom's law, where basically every new drug produced is costing over $1 billion now, probably about $3 billion, and it's exponentially increasing. Generic drugs can actually help. So the issue is actually missing incentives under the current patent-centric model. At the moment, large pharmaceutical companies will never fund phase 2 or 3 clinical trials unless they can secure a monopoly price. So as a result, you've got safe, low-cost, and effective treatments that are being ignored. So basically, 90% of US prescriptions are actually off-patent or generic drugs. And the issue is method of use patents can't prevent off-label use by doctors. So basically, any doctor can prescribe an old drug for a new use off-label. And therefore, new uses for off-patent drugs are essentially non-rivalrous and non-excludable public goods. So there's this considerable market failure. As I mentioned before, developing a new drug is around $3 billion. It takes about 15 years. A repurposed generic drug is about 100 times cheaper. You could do it for sort of 30 million, and it could, because you can start phase 3 clinical trials immediately, it can take about 10 times faster as well, so maybe even 3 years to get FDA approval. So there's this massive opportunity, missed opportunity, because basically all pharma is focused on finding new patented drugs, and there are like different kinds of things that don't fit within that patent-centric model, like off-patent drugs, diet supplements, and just non-profitable therapies generally, like antibiotics. As I was saying, there's significant cost savings from using generics. Generics are basically available at a marginal cost of supply, so they save around $2.2 trillion to US taxpayer in 2019. So if there's a way to basically channel some of those cost savings into generic drug repurposing, you can create a scalable business model with plenty of upside for everyone. So there's a lot of examples of repurposing opportunities. It's not just like science fiction, so oxyphenobutazone for drug-resistant tuberculosis, low-dose naltrexone for chronic pain, clomipramine for brain tumors, simvastatin for MS, tetrathiomolybdate for metastatic prevent recurrence of breast cancer, BCG vaccine for type 1 diabetes, also can be used for COVID, repurposed for COVID to boost innate immunity. Dichloroacetate got quite a bit of press for neuroblastoma. IV vitamin C, it's a bit controversial, but there's some real science behind it. You should look it up. So it creates a hypoxic environment for cancer cells. And then fluvoxamine for COVID-19, it's been shown to reduce risk of death by about 90% in a Brazilian phase 3 clinical trial. The big elephant in the room is around plant medicine. So cannabis flower, you can't really enforce a monopoly price over cannabis because it just grows in the fields. But we've got an opioid crisis that's about $1 trillion a year. Also, psilocybin mushrooms can be used. There's a particular treatment protocol, I'm sure, that can treat depression. And depression is also, a massive health burden, cost burden as well. So the issue is that clinician behavior is basically driven by FDA approval, and you need large randomized controlled trials. So, you know, the FDA only will listen to you if you've got a large RCT, and also doctors will only prescribe your drug with large RCTs. And as I was saying, you can only get that funded if it's a patentable drug. You aren't going to get government funding large phase 3 RCTs. If they do, it's extremely rare. So what's the solution? Basically, we're looking at the concept of retroactive public goods funding, which you could think of basically like a prize model. So in this particular model, we're looking at, we've got 3 stakeholders: the doctor, the investor, and the insurer, and they want to work together to help prescribe off-patent drugs. So the solution is that the investor basically puts up the money, researchers do the clinical study, and if the repurposing is successful, then they get an outcome payment from the payer, which could be government, charity, philanthropy, or the public. So the advantages versus direct, currently they basically rely on government funding to do these clinical trials. The advantages are you transferring risk to the public, to the private industry. It's also better technology. Pharma is better equipped. The free market is better at aggregating capital than centralized government organizations, and it's also lower cost. So you've got repurposed generics, a lot cheaper than patented drugs. So massive cost savings for generics as well, as I was saying, 2.2 trillion. So why DAOs? Basically, you can create these open source pharma IP NFTs that allow fractionalized ownership, and open source pharma NFTs create a market for public good medicines, and DAOs also create a way to basically transact for a lower cost globally in a transparent, secure way. So looking at Bored Ape NFTs, you know, pictures of monkeys, 2 billion market cap. What would be the market cap for an NFT that represented a safe and effective off-patent treatment protocol for a specific disease? So at the moment, we're looking to do a pilot for rapamycin, repurposing off-patent rapamycin. Dr. Brad Stanfield, he's looking at basically doing a clinical trial versus 400K, and we're looking to raise a prize working with VitaDAO to do a generic drug repurposing prize. We've currently secured 100K, we're looking for $1 million. And any questions, you can contact me at Crowdfunded Cures or reach out on Twitter. Thanks.
Great. Thank you so much, Sala. Thank you very much. And then next up, and sorry again for the live juggling of slides, but next up we are going to have Brett coming up to present on impact finance. So let's give a warm welcome to Brett. There you go, sir. All yours. You have full control of the slides.
All right, hello everybody, and thank you for having me here. My name is Brett Cornick, and today I'll be presenting Impact Finance, which is a project that I founded with my co-founder Cameron, who's here somewhere. Really quick, a little bit about me. I have a master's degree in material science from UCLA, and I've spent the last 7 years working in materials informatics space, so really digitizing the material discovery process. And I have 7 years experience working with startups trying to commercialize technologies out of universities, specifically in scalable synthesis of nanomaterials. But I have been bitten by the bug of Web3, and specifically DeSci, and founded this project to really strengthen the role that communities and individuals can play in the development of new technologies. So a lot of the projects that you've seen today are really targeted towards current scientists and getting them into the Web3 space. We're actually targeting the Web3 and crypto native non-scientists and trying to attract them to DeSci. And so why is this important? It allows us to access untapped community capital, and this doesn't just mean financial capital, this means intellectual capital, social capital, any type of community capital that can really advance this space forward. It'll also allow us to boost scientific literacy and trust in the community. There's the growing trend of distrust in science and the growth of alternative facts, anti-vaxxers, flat earthers, climate change deniers, and a lot of that is because the community is not involved enough in the development of new technologies and in the scientific process, so we want to change that. And we also want to combat doomerism, the rising nihilistic trend that is felt specifically amongst younger individuals that feel like they cannot show a demonstrable, impactful change on some of these global existential threats that face us, like climate change. So we want to build tools to fix that. So our target market, I stole this graphic directly from Greenpilled by Kevin Iwaki, and he describes it as the path from degen, so someone who is in crypto for short-term personal gains, to crypto regen, so someone who wants to build sustainable systems using regenerative crypto economic systems. I resonate with this because it's actually the path I took. I got into crypto because I really wanted to pay off my student loans as quickly as possible. And while that didn't exactly work out, I would argue something better happened because I'm here right now speaking. But I would say that this is a much more common path that people take. They get into crypto, they're down bad, and then they quit. And they say that crypto is a scam, and that's the end of their journey. And they're not able to make it to this regen phase of trying to, build better systems like I think we all here are trying to do. So we are targeting really those people in those early stages, and hopefully we get them before they enter this down bad stage. And so we're building DeSci tools to really help people in these early stages see the value in regenerative crypto economics, specifically through a scientific lens. And so how are we going to do that? We want to build platforms with a familiar user experience for those that are DeFi and crypto native. We want to emphasize a lot of educational content to help educate our users on the impact that they are having and the science that they are helping to support. We're using DeFi native marketing tactics to reach our user base, and we want to put an emphasis on community engagement so the community knows that they have a lot of influence and say over the decisions that we make. So what are we building? Our first one, Impact Invest, is an investment platform for direct exposure to scientific discovery. Think of this as a DeSci native decentralized exchange that'll allow token swaps, staking, and investment into specific research projects as well. And then we also want to build Vector, a DeSci native digital wallet that is going to have a familiar and similar experience to something like MetaMask or Phantom or Kepler or any of the major wallets that are out there, but will be DeSci friendly and will be specifically made to tailor to DeSci functions. So that's it. I want to emphasize that I heavily believe in collaboration over competition. So if anything that I said sounds like something you're building, let me know, and I'd love to work on it with you. Thank you, and that's it.
Awesome. Thank you, Brett. Perfect. Thank you so much. So, and by the way, for anyone, whether you're wondering here or if you're tuning in remotely, we will be sharing these slides afterwards. So I know we, unfortunately, with the schedule, have to rush through a lot of content, so we will make sure to make the slides available. But next up, we are going to have Arita joining us to talk about a project. Yeah. Thank you.
Thanks. Hi, everyone. 6 years ago, I experienced something that I wouldn't wish on anyone. I was working as a humanitarian doctor in the Middle East, and a baby arrived to our clinic. She was incredibly small, a Syrian refugee, and she was clearly very unwell. We tried to escalate care to the nearest hospital, but we were held up at the door. A mixture of xenophobia and fear by the hospital that we wouldn't be able to pay for her care. And in those moments, baby Layla died. I now work as a family medicine doctor in one of the UK's most unequal areas, where life expectancy between the richest and the poorest is about 10 years. And nothing held a mirror up to how inequitable global health is as much as the COVID-19 pandemic, where despite having highly funded global health institutions with a purpose of reducing health inequity, billions still don't have access to the vaccine or PPE, ventilators, and other resources that have enabled us to meet here in person today. Our failings aren't due to lack of innovations in medicine. Health 2.0 no longer serves us. Where we think of disease as being treated solely through a biomedical serviced model of healthcare, as was the case with much of polio, AIDS, and TB, for example, that no longer stands true. Non-communicable and chronic diseases are the defining healthscape of this century, and they are very much bound up with commercial and social determinants of health. They are influenced by politics and where you were born, and environmental threats such as climate change. And so Health 3.0 is required because unless we create the conditions for people to thrive as active agents, we'll never achieve human and planetary flourishing. And I think I've just changed the slide. There we go. Oh no, another one. So the question is, and I come to you as very much a medic and a scientist and not at all a blockchain person, can blockchain help us move from health 2.0 to health 3.0 by enabling community, agency, and decentralization in healthcare and the systems that support it? So we are recently set up, and we're testing this hypothesis by running 2 experiments in parallel. So planet.health, which you can link to above, is an online learning incubator, and we're going to be doing a lot of what has been discussed today, so bringing together planetary health people and crypto-native people and seeing what emerges. So part of that is going to be online through a cross-collaboration and learning journey. We're also going to have an in-person event in the autumn, and we predict that a DAO is going to come out of it, but we're not going to dictate what happens. And part of the function of bringing these communities together is to consider whether there's L2 apps that can support global health in the context of climate change. So that's everything from translocal governance to anticipatory action for extreme weather events. And so if you have either technical tools or a sectoral interest in either of these areas, then please definitely click on the link, sign up, and it's also going to be very fun. Secondly, we have been approached by a major global health entity to try and fundamentally restructure how global health is financed. So we're talking something on the scale of moving from the global fund, which is highly monopolistic, centralized, and currently distributes about $4 billion a year, and making that DeFi. And so we are working out how to do that, and we're building that from the bottom up. We don't want to replicate current governance structures, and part of the way that we're considering doing that is whether we need novel consensus mechanisms. And so very much specifically, given that that's what we're looking at, part of my pitch today is to draw out from the crowd people who can help us on that journey. So firstly, we're looking for builders, especially experts on building. Secondly, we are looking for people working in the areas of global health, so people who can help us create a visionary blueprint of planetary health through Health 3.0. And then thirdly, looking for implementers, so people building dApps across health and planetary well-being to help us see our blind spots and also think about how what we're building can work for you. Thanks.
Thank you so much. Great, thank you so much, Rita. All right, let's do a little more slide. Oh, no, this one is actually in the correct order. Perfect. So next up, I'll be passing the mic off to Angelina to present on Sci2Sci. So please take it away.
My name is Angelina, and today I would like to pitch here a Sci2Sci platform for digitalization and publication in science. And, sorry, what happened? Oh, yeah, okay, cool. So, and there are so many ways to talk about this problem, and I've decided to pick up an ecocentric approach, and I was so happy, actually, that the Open Science panel resonated on that already in the morning. And as a society, we have been investing a lot of effort into making sustainable use of resources, like green cities, trash recycling, and so on and so forth. But as scientists, we don't really use our information in a sustainable way. The thing is that we waste lots of resources into producing large data sets that are very expensive and that are originally digital. But then we reduce them into words or graphs at best that neither people nor machines can really make proper sense of. And it's difficult for people because the amount of information that is produced daily is just too big for our biological brain to digest it. And it's not that good for the machines because it's just not interpretable by the machines at all, or very poorly. And then there is another problem, is that scientists often don't care about the data they publish after they submit it, because there are no tools that incentivize further responsibility of the data. And this has led to reproducibility crisis that we are facing nowadays in many areas of basic research. Luckily, there is something different about information that makes this problem relatively easy to fix as compared to the problem of recycling of old-style goods whose value is based on scarcity. And this is the fact that information value actually increases when it's used. And think about a popular song, for instance, or a YouTube video, and the more it is played, the more it benefits its creators and the audience. And thus, I think it's crucial that we offer access to information at every single point when it's published for everyone, and it will benefit everybody simultaneously. And to do that, we need to pair electronic lab bookkeeping to ensure organized and lossless way for data and metadata acquisition and storage, and an online platform for showing this data in a format that would be both human and AI friendly. And such an online platform would allow many benefits that are not even thought of in traditional manuscript publications. Like, it can redefine the publishing units completely, shifting the focus from long manuscript stories to single experimental result publication that would significantly speed up knowledge dissemination. It can also be used for computational modeling and hypothesis testing, and then you can easily see how your model behavior changes by just tweaking certain parameters. Then it can facilitate collaboration between separate labs and even individuals. And it can also significantly improve cross-reference to specific statements and experiments. And just, for instance, by clicking a button, you can go directly to, it can lend to a specific statement that will be highlighted from another study. And also, it can offer interactive and customizable knowledge representation. And for instance, like an example here, you can easily change what information you see on the graph, whether it's bar plots, whether you want to see individual values, or whatever. And importantly, it will also return the agency of one's intellectual effort back to the scientists, so that scientists would have recognition and for how their data is used afterwards. And also, digital CVs can easily be assembled to showcase one's expertise and contribution to the field. And in a nutshell, I think it will offer great solutions for co-working between humans and machines to effectively use information to create the knowledge-based economy that I think many of us aspire. Thank you very much.
Perfect. Thank you so much, Angelina. So next up, nope. Let's try that again. Next up should be Anaf. There we go. Take it away, Anaf.
Hello, everyone. My name is Anaf, like the word enough, but with an A. I'm the founder of NeuroDAO, and in the past, I built a bunch of neurotech projects just in my bedroom. Some old projects of mine, kind of embarrassing pictures. This is just what I did when I was 15 and 16. Well, to be honest, I'm still currently 16, so still doing like stupid shit. So when I was, most notably, I worked at this company called Muse, which is like a leading neurotech company, and I was doing neurotech development for them. And I noticed that they had a lot of issues when it came to doing some of their neurotech research, and it wasn't like internal issues, like they had like bad teammates. It was issues with academia and how it functioned. And 16-year-old me was like, okay, what the hell does that mean? I thought academia functions completely fine. Totally does not. As soon as I went on Google, started searching up just like issues within academia, this article popped up, and I was intrigued, so I went deeper. What actually is the issue with academia? First thing I found was grants. So unreliable grants are a really big issue, as grants are the main form of early stage funding, just in academia in general. And they're becoming more and more unreliable as they're stagnating, competitive, and they have a shorter lifespan. So 2 to 5 years is not really enough to do monumental research, that actually changes the landscape. So first thing I thought was, okay, what about the people who are actually funding the grants? What can we do to help these people fund more grants? And how can we actually change the way that grants work? Then there was a plot twist. Well, we, the taxpayers, are actually the people who fund the research. So, of course, really great incentive to actually pay your taxes. But there's another plot twist. Despite funding the research, we don't get any ROI on anything that we really fund, and then we also don't get access to the research that, of course, we produce, or kind of, well, fund. And still pay your taxes, though, right? And after all the research is done, collaboration, when it comes to actually sharing the data, really isn't the norm. So positive and especially negative data, you're not really economically incentivized to really share this data with other researchers, and also just spends a lot of time doing it, so most people just generally don't. So with all these problems literally stacked on top of each other, the first thing I did was tell everyone that I knew, hey, dude, this is the issue, this is the issue. Like, dude, why is there so many issues with academia? And what really did it for me was that I was sitting at dinner with my brother, was telling him about this thing that I just found out like 2 weeks ago. And what he said was, like, yeah, everyone knows this. How do you not? So first thing that came to my mind is I just have to do something, right? And this was the inspiration behind NeuroDAO. And in short, it's a DAO to fund and decentralize neurotech research. So I'm sure many of you guys have heard of VitaDAO. Think of VitaDAO, but for NeuroDAO, but with more speciations. So the journey of our DAO starts like almost any other DAO. We swap you swap in for our governance token, just a ERC20 token called Axon. But unlike many other DAOs, our voting system isn't just based off of your tokens, it's also based off of reputation. So by using reputation voting, we're moving away from a one token, one vote system where you kind of only take into account how much someone earns, and more so moving into like how much someone has actually contributed to the DAO and actually how much someone is actually committed to the DAO. So moving from plutocracy, where the government is kind of owned by those who are rich, to a meritocracy, to the government is kind of like regulated by the people who have the most merit. After using this governance system, then you can just directly finance research, similar to how VitaDAO does it. You just kind of vote on different research proposals, and then the research proposals get funded. And then we will then commercialize the data and the IP. So fundamentally, NeuroDAO is really all about aligning economic incentives between different stakeholders and parties. So for data specifically, some of the major barriers when it comes to actually sharing the data is about privacy and cost. So it costs quite a bit of money to actually record the data, so why would you just send it out? And then also, you need to maintain the privacy of the data. So, and then also when it comes to IP NFTs, we just monetize it, or we intend to monetize it through VitaDAO's IP NFT protocol, and plan on monetizing data through Ocean Protocol. So through this, NeuroDAO is essentially cyclical in nature. Put in money, you get some research makes money, and then you put in more money to make more research. Very big cycle, closing the loop essentially. So we, instead of moving towards a boring dystopia, or like the landscape right now is kind of moving towards a boring dystopia, where this beautiful thing that's called science is kind of locked behind layers of bureaucracy and scarcity. Yeah, let's try and move towards a better future. This is the team, a bunch of people, and yeah, let's create a more interesting future with NeuroDAO. Thank you.
Thank you, Anam. Alrighty, so next up, and in the correct order on the slides, is going to be Jonathan presenting on Science Publishing DAO. So Jonathan, please join us on stage. Hello, sir. There you go. And yeah, you have full control here.
Hello all. My name is Jonathan Kang, and I'm going to be talking about decentralized science. Now, obviously, that's too big of a topic to cover in 4 minutes, but since we're still redefining the entire space, but kind of wanted to take this time to talk about how our group has been discussing it from trying to focus on the spirit of the law as opposed to the letter of the law. So people have been talking about standardization and such, but effectively we're trying to create an abstracted, tunable structure that uses various different voting topologies to navigate this uncertain terrain. So starting off with our application, the science publishing specifically. Big publishing tends to be this third-party, for-profit digital marketing company that has adopted a lot of the business practices of, for example, like Facebook and Amazon and such. Now, this is problematic because these are mainly advertising hype companies and not very good at managing truth economies. But this isn't just their fault. This is basically the limitations of Web 2 in general. So, but these companies also own the majority of the knowledge assets that are created by the scientific community, and they also represent the short to mid-term reputation infrastructure. And this becomes very problematic. Okay, and this has led to the affordability crisis and the replication crisis in science. So, it's kind of hard to see. Formatting doesn't seem to have worked out, but so I guess healthy democracies generally require an informed populace that participate in voting, as well as understanding that there are many voting topologies to fit the various contexts so that we can best elicit the wisdom of the crowd as well as its experts. So we've created a reputation-based economy using NFTs, but these NFTs are non-tradable, they are hyperinflationary, and they are non-interoperable. But you can earn them by publishing work and by voting, and you can lose them by producing bad work and voting poorly. Okay. So from the forum perspective, the kind of creating the knowledge architecture, it's basically going to be a weighted graph with topological features, where, for example, if you were to publish a paper, you're going to mint a certain amount of reputation. A portion of that is going to be staked to your paper, staking your reputation on a paper. A portion of that, maybe 30% of the minted reputation, is going to be staked to your works cited, where there are now going to be various different citing type topologies. And then the idea is you'll accumulate both negative and positive citations or peer reviews or replication papers throughout time, as opposed to having to go through peer review just to get into the system. For example, now you might have 10 formal peer reviews over the course of 10 years or something like that. And then this is basically showing the 4 different topologies of voting that we've come up with. So you can either choose one at a time, or we've kind of also combined voting systems where you would have an informal vote to kind of figure out where people really are, discuss it, and then you'd have a binding vote where your reputation is going to be on the line for voting a certain way. And then finally, this is basically an abridged table of some of the problems that we were addressing, as well as and how our solutions are associated with those. So I guess to make sure that things are sustainably decentralized, the accruable resource is actually hyperinflationary, and we think that the system that we've created is basically to focus on the spirit of the law and create the various different tunable structures so that we can okay, well, there you go. Cool, I'm done.
Oh, thank you, Jonathan. So next up, we will have Renee presenting on the Journal of Decentralized Work and from representing Talent DAO overall. So Renee, please join us on stage. Renee, there we are. All yours.
Hi, everybody. How are you doing today? That's great timing. Well, nice to meet you. I am Renee Davis. I'm here to talk about the Journal of Decentralized Work, which is a community-operated, academic, peer-reviewed publication journal. It's being built by Talent DAO, which is a decentralized community of researchers. And our mission is to really just help DAOs thrive, and we do that using sort of the best scientific research possible. So most of our core team, about a dozen people, are organizational psychologists. Many have PhDs and have been doing a lot of great research studying people at work a long time. And we believe that DAOs are sort of the new human coordination structure to emerge within org systems. So we're just really excited to study it, and we thought a really good way to go about this is solving some of the problems you see in academia. Many of you are probably familiar with that, but the 2 problems that we're really focused on solving is the publication problem, mainly IP being centrally owned and not having the option for those creators to benefit from that research, and then also the peer review problem being very centralized, ivory tower, and slow. So we've created sort of this incentive protocol that we built sort of an economic model around using some token. And basically what it is we've gamified the research submission process and created incentive systems for everyone involved. So the main users within our platform is going to be the researcher themselves, the reviewers, the publishers, as well as the DAO members. So kind of like at a high level, just walking through this, the researcher has the option to submit the paper. When they do, they can mint it as an IP NFT. The way our contracts work, we have a few different IP licenses you can do. If you do open source, which is what our journal is, you can stake that NFT on our platform and you'll get staking rewards for doing so. So there's incentive for open source. And then all of the IP is kind of tokenized and owned by the DAO members. We're leveraging sort of open peer review networks. Some might know them as reputation networks for our reviewers. And then our publishers sort of work like delegates. If you're familiar at all with DAO governance, you essentially have to nominate either yourself or be elected. You get voted based on your qualifications on what you can review. And then people delegate governance rights to you. We also have sort of a data marketplace where our research provides deep liquidity, and that is using Ocean Protocol. All right, let me do the quick demo. I did a record just to make this easier for everybody. Where is the big screen? Okay, so this is just a high-level walkthrough of the platform currently. Really quickly, just kind of high-level user interface, sort of how you submit. Something that's really important is a lot of open source journals, the reason they don't do well is because they're not indexed well. Sometimes it's sort of a misnomer about journals that the open source ones aren't as reputable or creditable and like you can't find them. And it's less of a reputation or credibility problem, it's actually more of a technology problem. So we spend a lot of effort indexing our journal, making sure it can be found. So that's kind of some of the submission forms you see here. Most of this is built on Arweave. For those who are familiar, we're using most of their tech stack for data storage as well as smart contracts. We're also using lit protocol for encrypting all the files within the system. So for those who want to get into the weeds about why I picked Arweave, come find me afterwards. Really big on some of the technology decisions we made. Okay, back to the presentation. Awesome. So just kind of quickly going through our roadmap, we're really excited. We've kind of been in stealth mode, I guess, the last like 8-ish months. We really kind of had our breakout at ETH Denver. And up till now, we've built sort of the core team. We've got a really strong community in Discord. We've got all our tooling set up as well as our business structures. The MVP is complete. As you can see, we're just migrating all of our contracts over to SmartWeave. So we're going to be doing an NFT membership drop this summer. NFT membership provides you essentially all DAO royalties of intellectual property indefinitely. So we're very excited with that model and the type of people that it will attract. And then this summer, we will be doing a call for submissions. So if you want to submit to the Journal of Decentralized Work and be one of the first researchers to ever mint a IP NFT peer-reviewed journal, definitely be on the lookout because we will be making pretty big announcements about that. We'll have our first sort of release of that journal later in the fall, as well as some airdrops of some sorts. Wink, wink. So I want to talk just like really high level about tokenomics. This slide's probably less relevant for this community, but one of the things that we spend a lot of time doing is sort of token simulations and talking with game theorists and economists and things like that, because I work at a few DAOs and they kind of just drop a token and hope it works out. They didn't put a lot of thinking into like supply or allocation. So we feel pretty good about this. Third of the treasury going to the community, the founders, a little less than a quarter, but there's about 12 people within that group. And then we'll be doing an airdrop to contributors of the journal, as well as users of the platform, and all of our friends and early adopters. High-level traction. Social media has been buzzing a lot. we recently secured investment from Arweave, which is really exciting. We're also working on funded research with both Ocean Protocol and SCURF, as well as some unannounced partnerships that I'm very excited about, that I'm sure will probably be announced sometime in August. So this is kind of the high-level team. Yeah. Oh, thanks. I thought you were just asking a random question. I was like, please hold the questions till the end of the thanks. But yeah. So this is the team. I like this kind of power statement we made. We wanted to do real science, not just thought leadership. So we built a team that could. I kind of joke that like I'm the only one that hasn't really finished their PhD yet on this team. So very smart team doing a lot of cool stuff. We have sort of 2 studies I want to plug quickly that are already have content released, are out in the market. We're looking for people to participate. One is our decentralized leadership study. So that is led by Lisa Woken, and she is doing interviews with different DAO leaders all over the world. The other one is the codename Project Lion, I believe it is. And what this is there's basically a decentralized people analytics platform, sort of like a Web3 native survey tool. And this is the funded research we have with Ocean Protocol. So this is led by Kenneth Francis. And he just actually released a Mirror article open sourcing our tool. So if you want an off-the-shelf, psychometrically sound DAO health organizational assessment, for free, go check out that Mirror post. And that's it. If you want to learn more, you can go to that link, and it'll pull up like the website, the newsletter, everything. And come talk to me if you have questions afterwards. Thank you.
Cool. Thank you, Renee. Perfect. All righty. And so next up, we are going to have 2 folks from Fleming Protocol presenting. Martin will be speaking on Fleming Protocol, and we will have Leah join on stage here to cover the slides. So yeah, thank you both, and passing it off to you.
Boom. Hey guys, Martin again from Fleming Protocol. I wasn't supposed to be doing this. Andre Chaguadera, my co-founder and our CEO, is actually stuck in a plane somewhere. There was issues with that getting here. So yeah, this is last minute stuff. So I'm going to run through this quickly, and Leah is going to help me along. So yeah, we're Fleming Protocol, and we're essentially a patient-led data economy for biomedical discovery. And this is sometimes some groups are terming this it's Health 3.0, but we want to integrate very, very closely with the DeSci community, because that's where all the novel discovery actually is. And just as there's a lot of intellectual property left in the literature, we think that what you guys are all what we're all building here and what's going to be created is something that patient groups are going to have very good insight into and can tap into. So, yes, next page, please. So, I'm sure you all know of Henrietta Lacks' HeLa cells. I worked with those, and I didn't know why the hell they were called HeLa cells, but it's because of this woman who, a long time ago, had some of her cells taken, and they're used in nearly every lab around the world. And there's actually a movie about it. I think there was a book written, and I think there's a movie about it. But there was nothing was attributed to her, the value she created, and I know her family now are kind of trying to address those issues. So we want to try and solve these kinds of issues where the people who provide their bodies, essentially, participate in the economy of research and translation. And for me personally, this is about having the skin in the game for the patients themselves who have the issues that everyone is trying to solve, to own and drive the problems. And that can be translated into all the other issues that society faces at the moment. Like I mentioned earlier, batteries, better batteries, photovoltaics, whatever it might be. Okay, next page. So yeah, we've got some fancy diagrams here that show flows from one thing to another. That's all going to be in fancy smart contracts, we expect. But this is all kind of nascent stuff, and we're planning on building these things in a way that they can integrate and be very, very composable with everything that everyone else is building in the community. So we see kind of the patients that, like I said, the patients are going to be providing the data, and they're going to have ownership over that data. And that's going to allow them to have the motivation to continue to be involved in the projects and also to fund those projects because they want the better outcomes primarily. But as those products get kind of moved down the translational pipeline, they can then participate with the investors at the next level, who might be a distribution partner or a government entity like say the NHS in the UK, or a payer in the US, a single payer, one of the insurance companies. Next page, please. So we will have a token to kind of incentivize and trace a lot of this, and it's most likely that transaction fees will be the way that we fund the regenerative side of this, so that the system itself can also create a treasury, whereby we'll have a DAO type system to actually allow the communities, the patient communities, to elect and decide on decisions. Okay, next page, please. So, yeah, we'll be participating in the translational, kind of the drug discovery process at the later stages. So that's the phase 1, phase 2 clinical trials, et cetera. And I think the next page. Very importantly, I've worked through the pandemic in trying to translate work quickly into the clinical world, and everything moves at light speed when we were working in an open source way. People weren't fighting over patents, intellectual property, et cetera, but the issue that everybody faced when trying to speak with the clinicians was, okay, how is this data gathered? And institutional review boards are very, very important to this, and we plan on providing that to the patient groups as they participate in this whole program. Okay. Yeah, so there'll be a legal wrapper in order to interface with people like the regulatory authorities and clinicians and hospitals and et cetera, et cetera. So it won't just be some people on the internet, we figured this out, which was the problem that we faced when trying to translate stuff during the pandemic, even though there was a lot of intellectual horsepower behind these projects. Okay. So this is our roadmap. At this stage, we are just about closing kind of a pre-seed round. We do expect to do a private sale at some stage in the next kind of few months. And then we've got a few more plans. Very importantly, engagement with patient communities is a very important part of the project, and we'll be investing a lot of time and energy in that part of things. Okay? I think we're done. Go next. Yeah, so that's it. We're here to work with you guys and pull what you guys are creating and building into the patient communities and cure more diseases. Thank you.
Thank you, Martin and Leah. Sorry, unfortunate Andre could not join us today, but yeah, we appreciate being willing to jump in last minute and still cover some of that. So yeah, thank you again for presenting on Fleming. And next up, we'll be transitioning. So that was actually the last of our demos and pitches. Now we're going to be transitioning to some presentations and then panels. So we will have 2 presentations now before lunch, and then we'll do lunch, and then we'll go ahead and finish off with the rest of the afternoon. But for now, I'll just pass it off to Allison, who will be presenting on some cool work at Foresight. So there you go.
Eugene. Hi everyone, me again. Yay. All right, how's everyone doing? Enjoying this space? I mean, I'm so impressed by just all of the projects. Like, this was like an entire treasure trove of different projects that I think are going on right now. I'm like deeply, deeply, deeply impressed by all the work that people have been doing. So congratulations everyone on all of the fantastic work. Okay, so I will present to you a little bit about Foresight Institute. where we came from and what it is that we're going to be doing over the next 35 years, because that's how long we already existed, and particularly how that's relevant to Web3 and to DeSci. So this is, I guess, if you want to join later on after this presentation, feel free to do so here. What I will want to be presenting you on is this Miro board. And, oh, let's see, I'll do it here. Maybe that's the one. So in a nutshell, Foresight Institute is an organization that has been around for about 35 years, and we've supported very long-term futures. Oops. Allow. Oops. Okay. Here we go. Okay. There. All right. So this is Foresight Institute in a nutshell, and it is where we are, and then also where we still want to go. And I want to tell you a little bit about how both of those interrelate. And then I want to tell you a little bit about Technology Trees, which is a new project that we're currently starting. So Foresight Institute is a nonprofit organization that has been around for quite some time. We were founded by Eric Drexler and Christine Peterson on a long-term vision of molecular nanotechnology. And over time, we've also accumulated other technologies that we've been supporting. So we're one of the first people where most of our folks that were actually with Foresight were signed up to cryonics. Many people care very, very deeply and have been for a long time about brain-computer interfaces. People were really, really out there in early-stage space technology development, like asteroid mining. We had the first sea launch attempt for a rocket and so forth. So like, I think safe to say that I think we've been always at the fringes, but always at the very, very ambitious fringes of early-stage scientific development. And we're usually doing that through a bunch of different, through like really creating ecosystems in these different domains. And so the areas that we support include molecular nanotechnology, all the way from here to atomically precise manufacturing. So actually manufacturing things with atomic precision. Second one is longevity, and that includes rejuvenation, but also cryonics. Third one includes decentralized computing. So that's what, the early cryptography space that is now moving into crypto commerce, and will later on, I think, also have a lot on privacy preserving machine learning to do. And then fourthly, we're doing newer technology all the way from here to brain-computer interfaces, and then ideally whole brain emulations. And finally, the space technology group, that is another group of the groups that we're supporting. And how do we support this work? So we run through a variety of different programs. On the one hand, the first thing I think that really builds our core are our technical groups. And so these technical groups basically are a group of experts that are about 200 people that are application-based and invitation-based. And these are our different seminars. They meet in, I would say, really like weekly to bi-weekly seminars, and it's a pool of different younger students. It's a pool of entrepreneurs in the space, and it's a pool of more senior folks that are collaborating on pushing these technologies forward. If you're interested, all of these seminars, even though they're like they run through these expert groups, they are afterwards available openly online if you want to check them out. And we have seminar summaries written up for all of them. So if you want to dabble in these spaces and you don't really know quite how to get in, there's usually seminar summaries written up for all of these that you can look at. So these technical groups crucially also meet once a year for workshops. We have the biotech workshop coming up now in San Francisco that will be on biotech tooling and biotech prizes and enabling technologies. And so these groups are really trying to build ecosystems where usually there are none. Right? In normal academic departments, you are really constrained to your own department, and crucially, there's not very much really like transdisciplinary collaboration, but also not really very much thinking outside of the box or thinking on working actually on the sci-fi technologies that many of us here think are quite important and quite interesting to realize. And so these are really groups of people that are really deep in the field, but nevertheless care about the very, very long-term goals. And we're trying to provide for them a space, a container, which is Zoom meetings and workshops, where these people can collaborate across generations, across different disciplines, to actually work on the stuff that many people care about, but where there's not really a venue for or funding organizations for. So that is kind of like our pool of people. From that pool, people can then apply to become our fellows, and they can apply to become our mentors and judges. So crucially, our fellows are people that we just spend a little bit more time and effort in supporting, and those are really, really brilliant scientists. We used to have the fellowships now running for 5 years. We used to have 10 a year, now we have 40 this year. So we're really scaling up, and while we as a nonprofit currently all that we provide is one-on-one networking opportunities to mentors, invitations and to presentations, and really trying to create like a cross-disciplinary ecosystem, even though we at the moment don't support grants. I'm super flabbergasted by just the amount of amazing applications that we get. So now just imagine strapping a grand layer to this. But here are a few of our really wonderful fellows. I think a few of them you already saw in the NFT presentation earlier, because one way that we try to promote their work is by doing NFTs, for example, this one on Cryonics for Pets, to support their work, where people can just buy an NFT and immediately fund the work of the fellow. More senior folks in our technical groups can apply to become our mentors and judges. So we have a really wonderful list of mentors, and I'm telling this because many of you are probably people that could also be really great fellows for us. So if you're interested in actually making use of this opportunity, if you're working in either of these spaces, nanotech, biotech, computing, neurotech, and space, and if you're looking for mentors in these spaces that have a little bit more of a longer view, then this fellowship may be for you. So here are our mentors. It's, again, like a really fantastic list. I'm just showing this to you to give you a little bit of an understanding of like, hey, this ecosystem already exists and you can benefit from it if you're interested in it. But so this part already exists, right? Black in this box is all the things that already exist. And so we have the technical groups, they can apply to become mentors, they can apply to become fellows, and they already support each other. And that's working out really fantastically already. But here's the thing that I actually want to talk to you about, which is we're currently building technology trees. And so technology trees, who here has played Civ or another game like that before? Who here knows what technology trees are, roughly, very roughly? I think I can see some heads. Okay, wonderful. So this one here is the tech tree project that we just started at the end of last year, and so it's still relatively new. But in a nutshell, this was the presentation that we actually gave at ETH Denver, but now we have a few updates. And so what we're doing is we're building tech trees to map the entire space. So the idea is that oftentimes I get emails from new funders or new talent that are trying to enter our groups, and they're really eager to help, but they don't really know how to plug in. And so for that, we're building technology trees. Why trees? Because they're a mix between top-down, which would be a roadmap, like if you just want to push on a technology and move it along, and a mix between bottom-up, where you're just trying to map a space. A tech tree actually maps a space, but also provides some guidance for those people that want to build roadmaps through it. So we specifically make a digital, constantly updated map of technologies that comprehensively lists the companies, labs, and advocacy groups working in these places. We get feedback from domain experts. Many of these trees, as you will see in a second, have been built out already. We do bottleneck analysis, so we see, actually, we ask these people, what are the undervalued challenges currently that you're facing? And then we do decentralized bounties and crowdfunding mechanisms on that, which I'll show you now. We have a really wonderful team. Those are all of our fellows. And so we have Johanning, who is with Nobel laureate Stoddard's mechanochemistry group on molecular machines. He's building out that tree. We have Marina Polyakova. She's building out the neurotech tree. We have Ying Tong Lai. She was at Ethereum before, and she's now building out the intelligent corporation tree, so that's decentralized computing. And then we have Romain Fontaine from the European Space Agency building out space. And finally, Aaron King, who many of you met at ETH Denver, who is building out the longevity tree. And so, in a nutshell, well, this I can show you a little bit more about. Those are the areas that we're building the tech trees out. Here you see like a very, very rough prototype of what the nanotech tree already looks like. So the idea is to map the space, to map the companies and organizations already working on these areas, and then to ask for different challenges that would move individual nodes along. That's nanotech. These are our advisors. So we have a really wonderful panel of like more of the senior folks advising these technology trees, including really like the giants in the field. For neurotech, we're currently building out the same tree. This one is mapping the way from here to brain-computer interfaces and beyond. Again, with a really wonderful panel of advisors that will be reviewing these technology trees. The intelligent corporation tree is all code, and they're like recreating the different ways in which you can build tech trees, obviously. And then we have, again, a really wonderful panel of advisors here. And finally, the longevity tree, which is the one that is furthest built out, because that's, I think, our strongest group still, and that one is building out the longevity space. And again, a wonderful panel of advisors. And space tech is also really shaping up to look quite good. So I think, why am I telling you this? I think I want to show you a little bit like what these tech trees actually look like. And as you can tell, if you actually follow along the link here, the Foresight Join link, it will link you to this Miro board that I just showed you, on which you can actually look at the tech tree challenges. And so I give you for today a little bit of a look into the prototypes that we already have. And so I really, really welcome you to just check out the trees if you're interested in and checking out where we're currently at. This one is like, you can zoom in. I'm not sure if the computer now can handle it, but it's basically building out and mapping out the entire space of molecular machines. Crucially, you already have the first subnodes created. So by double-clicking on them, these are the nodes that actually map out a specific area in more detail. And on those, we now have Gitcoin bounties and challenges. The same prototypes exist for all of the other ones as well. And so I really welcome you to just like scroll around the folder and to actually figure out if there's one that is mapping a space, you know, that you care a lot about, that you could potentially contribute to. This one is the longevity one. Again, if you double click on one of these areas, it will open up into a node that will show you advocacy groups, labs, and so forth. Crucially, I think, as I said, you know, you really want to double click on the challenges in each of these fields, because it's easy to ask people just like, what is the most undervalued thing in your area? And they say, my lab. But if you actually ask them, what is an undervalued thing that is not related to your research, but that's an enabling technology that helps you along, you get really, really great answers. And so we've been doing this a bunch now. Here you can see, for example, the newer tech tree scaffold that is currently being built out. And we have the first subnodes again for an area that our fellow is focusing on, which is dementia. And so you can really see that, you know, gradually we're coming up with key challenges of the fields and so forth. And we're not only coming up with the challenges, but crucially, we are also putting bounties on them. So we have the first bounties that were launched yesterday to make progress on these tech tree challenges. So if you are working in these areas and you want to gain easy money, then I would welcome you to just answer these questions. And we're not asking you to solve those. That would be billion-dollar projects. But just give us your first project proposal of how you make progress on these challenges. There's a few for molecular nanotechnology. There's a few for intelligent cooperation on private smart contracts, sustainable communities. There's a few for longevity. There's a few for neurotech. And you can just scroll down the list. And so if you're already working in these areas and you have an idea of how to make progress in these areas, just click on one of these bounties, answer with a quick project proposal. If we like it, you get an easy $500 or like 400 something in ETH. And then if we like the proposal, maybe we want to fund actual, like a longer term collaboration on you working and going after that one. So this is just a project proposal bounty, but you know, it's one way to make progress on these technology tree and doing so in a very decentralized way. Okay, so that's the current state of these tech trees. That is only one of the things, you know, that we're currently working on. I'm also really, really fortunate to have been approached by VidaDAO, which are doing really wonderful longevity prizes. And so currently we're hashing out a few longevity prizes, and I'm sure that, you know, Vincent can tell you a little bit more about that. They're still under construction, but I think safe to say people are really, really gearing up in the community to launch a bunch of prizes on really wonderful challenges. Foresight has been doing the longer term prizes for quite some time now. We've been giving out the Feynman Prize for molecular nanotechnology since 1993. And our Feynman Prize winner of 2007 then went on to win the Nobel Prize in 2016. So we are really quite good, I think, at catching early stage stuff. Okay, wonderful. So that is currently being under construction. As you can tell, it's in green. Then crucially, currently our funders are already donating to Foresight Institute, and I think that's working nice and well. But I think what we, as you saw from the last panel, from the NFT panel, one thing that we really, really want to work towards is actually building more of these DeSci NFT collaborations out. And Alexandra, I think, just joined here in the room, but the idea is that we really pair our scientists with artists to produce an NFT of the science that the NFT is supporting. And by buying the NFT, people can, in a very decentralized fashion, support a scientist. Crucially, they then have a really token of their appreciation right in their wallet. We have exhibited them already at South by Southwest and a few other venues. We then tour around and just really try to raise a little bit more of awareness of the amazing science that people also are producing. As you can probably remember from the panel this morning, there's a bunch of other use cases that, you know, I think are just coming online now. One of them is impact certificates. And so this is not something that has been built out yet, and it's something that is really pretty new in the space, but one can really imagine that our funders receive impact certificates that they can later on trade on marketplaces to actually show that they're a very early stage supporter of this particular scientist. We could even have, you know, different bounties on the tech trees correlate to different impact certificates so that you can prove that you were very early on and funding a node on the technology tree that then later on made it all the way to the very long-term goals of brain-computer interfaces. Once we get there, we can reward the early ones, I'm sure. So here's another thing that's new.
Another thing that's new is that our funders, currently they only donate to Foresight, but my day job is that I run around, usually like a headless chicken, between our fellows and our funders to one-on-one matchmake them, because our fellows are currently, I would say, 50-50 in either entrepreneurs or researchers, and the ones that are entrepreneurs actually building for-profit companies, I matchmake them with our funders. But that's pretty unsustainable if you have 40 fellows, and so many of our funders actually were interested in starting a fund or in pooling together and starting a fund. And there's different ways of doing this. I'm mentioning this to you here because many of you are working on DAO tooling. I've done my deep dive in it in the last 3 months, and I've vetted a bunch of them. But if you have a really good structure that you think would be useful for this, I would be really happy for your feedback. Currently, there's 2 ways of doing this, and this is not solicitation. I'm just putting this out as a brainstorm. One could be a Foresight-sponsored rolling fund on AngelList that basically kicks the carry back to Foresight Institute, which we could use to pay more prices and to actually pay our mentors and judges to get some upside on doing due diligence on our fellows. So it would be like a kind of, one could call it a black hole for good, in the sense that carry wouldn't go to individuals, but carry would flow again back into the research projects that can then provide more profit to the funders that are funding through the fund. Another project is that many of you probably here know about Syndicate DAO or Kali. Those are different like investment club providers in the Web3 space. So people can basically band together, and it doesn't even necessarily have to be a Foresight-focused fund, and people can band together and basically fund an entire ecosystem. And then the tech tree challenges are like one way in which they can get deal flow through the prizes, and that they can then actually launch and invest into these challenges. So currently, just by virtue of simplicity, I think the rolling fund makes a little bit more sense for us. That being said, if you do work on really good DAO tooling that is easy to use, then please let me know. One very, very, very big thing I want to mention is, and we've heard this really wonderfully from Lily and Kat earlier, is onboarding. It's really difficult for our scientists to actually get excited for much of the Web3 tooling. And so one thing that Web3 DAO tooling, I think, is very difficult to do. If you want to reward scientists for due diligence, then you need to make it very easy to do that. And that is still a little bit different with models like Syndicate DAO, where they need to have a MetaMask wallet. And even though it's synthetic tokens, it's still very difficult to do that. So if you have a very easy work around that, then please hit me up. Okay, cool. So that's being under construction. We have a bunch of people already interested in the fund, like Balaji and a few others, even the crypto space. We're really interested in this. But this is definitely a part that is still very much under construction. Finally, we are a nonprofit institute, so at least Foresight, the institute, that will be separate from the Foresight fund that can actually profit our individual investors. We care a bunch about the different risks that are arising from technologies too. I don't personally necessarily think that we can stop different technologies, but I think we can speed specific technologies up. And that's why I want to talk to you about this, because I think that there is what we heard about earlier is the existential hope presentation that Alex gave. But for a while back, I tried to make it easier for people working in long-termism to just onboard into different buckets that they care about. So imagine you care a lot about individual risk arising from a specific technology. You can go to existentialhope.com, and you have a positive wrapper around positive long-termism, and you can actually plug into the different categories, and you can make progress on these areas. I link to a bunch of organizations that do fantastic work in this space here. And so that's one way in which we really try to just create more community around thinking about the risks as we develop the technologies. And then the second one is the Gaming the Future book, which I bring to you because you're all working crypto. That's a book that we recently wrote on how crypto technologies in particular can support long-termism. And we had really wonderful presenters here, and many of them I think are quite familiar to you, including a bunch of people that really work quite closely in the crypto space. And so one idea for us really is that we need to have the risk assessment and the risk development deeply informed by the technical work. So we need to do, I think, what Holden Karnofsky calls differential technology development, of pushing the positive use cases of technologies first before the negative risky use cases can come. So we need to actually develop the safety enhancing technologies first. So this is, I think, interesting because it just provides a little bit more of a wrapper of like, where do we want to go on the long run, right? There's a ton of stuff to build. We need to take the risk into account, and we need to do it with our technologies. Otherwise, other people will move in. And if we can't protect the technologies that we're building, I think then ultimately we have, we will have done it wrong. So I think I just want to encourage you all to also have the risk in mind as you're building much of the Web3 tooling, and to come up with good Web3 tooling for that. So again, if any of this looks interesting to you, if you want to plug in, there's a ton to build, as you can see in green. This is still very, very much under construction, but it's my way of porting this institute that has existed for 35 years into the long-term future. So if any of this is of interest to you, then please, I welcome you to check out the link. You can have the QR code here, or it's on foresight.org/join, and you'll be ported to a Google Doc on which you can join our different efforts. Thank you very much. Thanks, Eugene, for organizing everything.
Thank you, Allison. Perfect, thank you. And then next up, we will have Chris from DeSci Labs presenting. Let me get my laptop out your way. There's the dongle. And then just to give a heads up, after this presentation, which will be the last of the morning session, we're going to jump to lunch. So if you walk by the bar area where you just walked in, we'll have bags ready to go. There's some gluten-free, dairy-free, vegan, vegetarian options out there as well for anyone with dietary issues. And then we'll have an hour break starting shortly, but not just yet. And first, we're going to hear a presentation and demo from the DeSci Labs crew. So Chris, take it away.
Thank you, Eugene. So today I'm going to present to you a DeSci Nodes, which is a Web3 native unit of knowledge. Before that, I'm going to zoom back a little bit and talk about the tragic state of the scientific record. The scientific record is our greatest achievement as a species. Currently, it is a cloud database with the read and write function entirely owned by Elsevier and Clarivate Analysis. It relies on an obsolete unit, the archaic and solitary PDF. There's no business model for anything besides PDFs. It is fragmented, it is insecure, it suffers from link rot, content drift. It is also vulnerable to cross-national censorship. 3 out of the big 4 publishers are presently censored in China. And it has a raging replication crisis because of bad incentives. And as a result, public trust in science is fraying. And finally, it is exploitative to scientists. We pay to write on this record. We pay to read on this record. I published a paper in Nature Neuroscience back when I was a scientist. This was before Nature Neuroscience charged for open access $11,800 to peer review your work, to format it, and to put it up on their websites. And even in those days, when Nature Neuroscience was exclusively closed access, I still had to pay $2,000. Why? Because I had color figures. So let that sink in for a moment. This system has lost its legitimacy. And it is grand time to create an escape hatch. And this is the mission of DeSci. We have to build the infrastructure. We have to build the communities so that we can fork it and we can reclaim our scientific record and secure it for future generations. So what do we have to build? Well, we have to build gateways. We have to build systems for scientists to put their works into a decentralized ledger of knowledge, an index of scientific discoveries. We need a Web3 unit of knowledge. We need to upgrade the solitary PDF. We need interops, we need APIs so that we can integrate with the traditional scientific system. It's very important that we add value to the current workflow of scientists. We need a governance system, so we've set up the DeSci Foundation, which is a foundation with great meta-scientists and other scientists that help us and advise us on designing better incentives and better systems to reward good science. And finally, we need a place to dream, a place where we can showcase excellent scientific work and illustrate it beautifully so that we can draw people to this mission. And this ledger of knowledge must be curated. And for this, we are building ARCs, autonomous research communities, running DAO stacks, who can operate on composable and securely stored knowledge. And in doing so, recapture the value that they provide by securing information and verifying scientific discoveries. And finally, we need ways to interop with the wider DeSci space. And for this, we're very excited to work with Shadi and his team using Holonym to secure scientific identities so that we can create secure funding channels that will bypass the traditional system and go directly to scientists. So let me zoom in on the unit of knowledge. We're all familiar with PDFs. This is how we share our work. This is our token of knowledge as scientists. We need something better than that. We need a Web3 native unit of knowledge. We need to upgrade how we create, how we share, and how we verify knowledge. PDFs essentially are held in silos owned by publishers. The PIDs, or persistent identifiers, rely on the DAOist system, which has been created 20 years ago by the American Association of Publishers, to have a primary key and to allow them to trade, to basically decide who owns what piece of copyright. PDFs are DOIs are unsecure, they break, they get crawled constantly. Crossref has a shame list of publishers who have double entries or more for in this, what basically is a lookup table. We need a better system. And finally, the publishers own the metrics that track attention. They own our citation graphs, which is basically the currency of science. And on top of all of this, they impose upon us a rigid, arbitrary, print era formats of arbitrary requirements on length of manuscripts and other things. It's very rigid. And their claim to value, and this is very important, the claim to value of the scientific publishing industries resides in the idea of the version of record. The version of record is the state of the scientific graph of knowledge. All of these versions out there, forming the version of record, form our graph of knowledge. What is the version of record? It is basically a PDF of record. We need to move beyond that. So what could a Web3 unit of knowledge look like? Well, how about a place where you can put all of your research outputs, including your manuscript, and link them together so that you have the full history, so that every element that you create as a scientist can gather credit? How about secure PIDs? Persistent identifiers that don't break, that encode the content of the underlying object and not simply the link to the publisher's website. And these research objects need to be made reproducible. We must facilitate reproducibility and return independent replication as the gold standard for scientific validation. And finally, they must be openly verifiable. Everyone should be able to verify the science that is posted out there in an efficient way. For me, Web3 is about freedom. And this is also about creating an open, creative, experimental space. This unit of knowledge needs to be something communities can claim for themselves. If you want to do micro-publications, you can do it. If you want to publish reproducible science, reproducible documents, you should be able to do it. It shouldn't be a constraining space, but a place of freedom. And ultimately, the DeSci space needs to claim the research object of record as its claim to value in the scientific ecosystem. There's this whole concept of reproducible research. The idea is that our PDFs, our manuscripts, are simply front ends. The back end is a database, code, a computational pipeline. All of this is integral to any claims we make as scientists. We must put those into the open domain and connect them to our research outputs. It is very important if the DeSci space is to claim legitimacy in the scientific sphere, that we enable and that we facilitate the creation of reproducible research and enable researchers to connect easily their manuscript with all their underlying outputs. And the research object is likewise not a new concept. You have projects like Arrow Crates. The idea is to have a space where you can combine all your outputs together in a secure way. Now, what is new and what is Web3 native is the data model. And this data model is called IPLD. It's based on the content addressable web. And the idea of IPLD is we can store Merkle DAGs, and these Merkle DAGs will have are tamper-proof. All the underlying components will not change. They remain cryptographically secured. And you can take these Merkle DAGs and very efficiently index the root node on-chain. So I'm going to give you a little demo here. Now I want to stress that what's incredibly important beyond everything I said here is UI and UX. None of this can succeed if we don't provide excellent UX to scientists. And UX is about being in a familiar space, being in a space that is simplified, and enabling cooperation. So here you have a page of Protocol Labs research. They're a Web3 native organization. They've done a lot of the fundamental building blocks of the decentralized web, like IPFS, libpeer-to-peer. So as a researcher, as a scientist, where do I want to go when I'm on a website like this or on any other website that links to academic research? I want to go to the PDF. That's where I feel good. Now, finally, I'm exactly where I want to be. So this is a paper, SnarkPack, Practical Snark Aggregation. Very interesting. It's about scaling snarks. It's a very important contribution to the public good ecosystems of on-chain research. Now, as you can see, this PDF has a mysterious symbol in the corner. What is this? This is a link to the immutable token ID that is stored on chain that links to the Merkle DAG, which contains your research object and all of the components of your research in an immutable and tamper-proof way. And now I can click on this. And oh, I'm back in a PDF viewer. Still feels good. This is a familiar environment. Now what can I do here? Well, there's a couple of differences. You can see at the top, it's Web3 wallet integration. There's also a mysterious symbol on the side. So let's see what's in here. So we have here a research object navigator directly in your PDF viewer. And this research object navigator has attributes of your research object. It has information about all the validation trail that your research has gone through. Has it been peer-reviewed? Has it been published in a conference? Are the artifacts reproducible? All of this is stored transparently in that data structure that is queried on-chain. And now you have all the components of your research. And researchers take great pains to create things outside of the PDF. They make slide decks to explain their results. They also do video presentations to talk about what they've done. All of this can be aggregated now in a single place. And it's very easy to do. This is the other thing. We need to simplify the experience. Editing, adding components should be something that is extremely straightforward. Copy links, drag and drops. It has to be that simple for users to adopt it. What else do you have here? You have a history and you have source. If you go on history, finally, GitHub for scientists. You have the trace of all the previous versions, all the updates you might have done to your work. And it's all transparent and accessible by reading the Merkle root that is indexed on chain. You also have source. Those are all the metadata, all the author contributions, their identities, their organization, tags. And now, on top of all of this, you can add annotations to your work. You can take all of your component and start speaking to the public or creating reproducible documents. So for example, what are trusted ceremonies in ZK snarks and why are they important? Well, now as a researcher, I can add an annotation very easily into my manuscript. This allows me to go direct to the public with my research. We also have support for LaTeX and Markdown. You can add beautiful equations to complement your work. And most importantly, and this is where I really want to put the emphasis, we need a reproducible document stack that is Web3 native. So what do we have here? In your PDF, you can now embed the CIDs. These are the persistent identifiers, the encrypted content that links to the component of your research object, and you can embed them directly into these PDFs. And that also means social interoperability. You can keep sharing these PDFs like you do as scientists, and anyone can click on these embeddings to query the ledger. And so here, you have to replicate the benchmarking results shown in this figure. Execute the script, generate figure 2. This is the key result of this paper, is showing the improvements in computational efficiency for ZK snarks. Now, in your PDF viewer, you have an IDE, which allows you to reproduce these results. And we can run this code in a Docker, which contains your code, your environment, your data. We're working with Protocol Labs on a solution called COD, Compute Over Data, which will allow researchers around the world to use decentralized compute, to compute new model, to do their work, but also to create reproducible manuscript like what you've seen here. And this is very important. You have organizations like the ACM or the Open Science Foundation that have been trying for a long time to promote good research. They have been trying for a long time to promote the sharing of research artifacts, the opening of your data, the opening of your method, to share all of this. And they've created badges. Badges that say, well, artifacts available. Badges that say, well, your artifacts are functional. Results reproduced. Results replicated. There's over 1,500 papers in the ACM conferences that use the ACM badging system. Unfortunately, these badges remain on the pages of the conferences. Now, they can be part and permanently tied to your research object. And best of all, they are easily auditable because all of the criteria necessary to prove that you deserve these badges are all within this research object. And something that's even more important and is validation, right? There's incredible info hazard out there. Maybe some of you remember, the Lancet article from Peter Daszak saying that anyone out there even entertaining the idea of the lab leak hypothesis is a conspiracy theorist. How valuable would it be if anyone in the world could openly verify such claims? So, here, for example, I can openly verify research by adding a replication grant that will be handled and dispensed to an ARC, an autonomous research community. And the value of this will be returned to scientists. These validation grants are NFTs, and as you see, it's being added here. They will be added to your wallet. I also want to say that these research objects themselves, they are non-transferable, non-fungible tokens, and this is how we handle versioning. So what do we have here? So we propose a Web3 native unit of knowledge. A unit of knowledge that allows to easily obtain proof of reproducibility with executable capsules stored in Docker containers using decentralized compute. Secure time capsules that are permanently stored, that depend only on the survival of the underlying networks on which they're built. They're resistant to link rot. Storage is decentralized. They also allow us to form permanent knowledge graphs. CID graphs are better than PID graphs. CID graphs, content identifiers, do not break. They're tied to an immutable token ID. And this allows research objects to provide incredible metadata for AI readiness, for machine readability. The fact that all of this content is tied together and linked gives us the ability to gain valuable context. And finally, they're openly verifiable. Anyone can add a validation grant. Anyone can say, I want this finding to be independently replicated. And here, I'll put 1 Ethereum in the pool. And finally, I think we need to dream. This is a project of such magnitude. The idea of forking the scientific record, of creating the necessary infrastructure to create this escape hatch and to onboard scientists around the world and to onboard the people. We need a place to dream. We need an open metaverse library, a place where the best science and the best research object can be showcased to inspire the world, to inspire future generation, and to show that self-reproducible, openly verifiable time capsules of knowledge can be created, and that people will create them, and that those that create them will be rewarded, and that they will be accessible to all of humanity. So, thank you. We'll be launching on nodes.DeSci.com, and thank you to my fantastic team, CNAV for DevOps, IPFS Ops, Brian, Science, Philip, UI, Andrew and Bean, Community, Eric, Event Organization, Georgia, and Onboarding Ops, Carla. Thank you so much for what you've done so far.
Thank you. Grab that. Thank you, sir. All righty. Let's not just give it up for Eric, but also for all the speakers who have presented so far. It's been a great morning of activity. Hopefully y'all have been able to enjoy all the various talks, panels, pitches, all the wonderful knowledge being shared. We're really thankful to all the different teams that helped sponsor this, that helped organize this, that just came and contributed. So we're just tremendously thankful to all of you. But I don't want to ramble on because it's lunchtime, so let's step out. Everyone can just feel free to step out and grab some food. You're welcome to hang around, and we will be back on at 1:20, so in just under an hour. More quick thing. Yeah, I just also wanted to say, for anyone who wants to actually grab their lunch and step out, we do officially have the policy for the day of no re-entry, but we're opening up a window till 1:30. So if you do already have a wristband, you're welcome to come back. We'll make sure to reserve the seating till 1:30, even if we get to capacity, but don't think that'll be the issue. But yeah, enjoy lunch. We'll be around. Let's go talk to... All right, hello and welcome back after our lunch break, everyone, or just hopefully some time off if you're joining in the stream. But we will be picking up our programming in just a moment. I'll actually be the one presenting as well. But I just again want to thank everyone for all their time and energy and dedicating some time to spend with the DeSci community and being part of this. I do just want to say for folks that are physically with us in the venue, we did have shirts made. We weren't sure how many people were coming, so we kind of had to reserve a bit for folks who paid for tickets and for some of the organizers and speakers. But and if you're one of those categories and have not grabbed a shirt yet, please do as soon as you can, because by 3 o'clock it's just going to be first come, first serve on grabbing those. So we do just want to give one final opportunity for some of the folks who contributed, and then it'll be just open for anyone who's hanging out with us for the day. So yeah, let me go ahead and get kicked off with our presentation from the Smart Contract Research Forum. Again, I'm Eugene. I'm the head of operations at SCIRF, and today I'm going to be chatting with you all about research impact networks. So in general, and if you want to grab the SCIRF POAP, which we did across a few of our events that are taking place this week, please feel free to grab that while I run through the agenda. In short, I'm going to talk about impact networks for a little bit and just what they are and how I see them relating to research and to systematically changing knowledge environments. And then talking about what I'm kind of defining as knowledge ecosystems, talk about what we see that looking like in Web3 specifically, and about the SCIRF roadmap in the context of that. So to start talking about research impact networks, I figure a good place to actually kick things off is with the question of what is a network? Let's start with defining our terms. And so, the whole idea of an interconnected group, here it says of people specifically, but it could be of a variety of biological systems or some extended group of individuals with similar interests or concerns. And so, networks can be seen in more of the pure biological systems, as well as in social networks, something that we're all, I'm sure, very well aware of, probably even more so than we'd like to be. And then, humans have also built a variety of technical networks as well. And so in the context of impact networks, and I don't know how many folks have actually specifically heard of impact networks before, but I really like this core concept of impact networks being a mix of vibrant communities and healthy organizations. And so as a result, they can be relational while being structured, they can be creative while being strategic. It's being able to manage and have some both the benefits of just healthy, vibrant communities as well as well-functioning organizations. And I think this idea of some of the shared principles around, the community principles of shared principles, of resilience, of self-organization, some of the elements of healthy organizations in terms of actually having an operational backbone and having a bias towards action is one that personally very much resonated for me. And the whole idea of sort of trying to increase the flow of information, decrease time wasted, energy wasted, encourage as much strategy alignment as it makes sense for the various network components and players, and trying to think through different players at different scales and how do all these groups work together. And this is all quoting from David Ehrlichman's book, Impact Networks, which is a great one if you're generally interested in the topic. So as I'm going through the remainder of the presentation, please just keep in mind this idea of impact networks, the fact that different networks will actually be most impactful and be most effective at different scales, depending on what they are trying to accomplish, and recognizing that fact that any kind of future system of change will most likely actually be composed of a network of networks. It's not just going to be a single network or a few, but networks will be built around concrete missions and focus areas, and a collection of those kind of coordinated impact networks could actually lead to a much more focused systematic change. So when we think about knowledge networks, or as I'm going to bucket these as intellectual networks, which I don't like that term, but there's just too many similar terms being thrown around, so I need some disambiguation. So for any networks that are actually focused on adding to the overall base of knowledge, at least in the scientific sense and especially academic sense, there's the actual research component. So I guess presumably in this, right, you're starting with an existing base of knowledge, then there's a network of individuals that want to run experiments or tests, have hypotheses they put together to propose new knowledge to get added. That knowledge then gets reviewed and published and put out somewhere. And as a result, we can now kind of amend our general shared knowledge database with this new information. And so on the research network side, because it is easy to just broadly say research as if that's one cohesive thing globally, forgetting of all the actual constituent networks that play into the overall kind of research network landscape. Because there are a variety of academic institutions, there's a variety of private institutions in industry, there's more independent research groups as well as citizen science groups, and then there's groups that are trying to build across those. For anyone who spent time in academia, the whole idea of the mission of we're connecting industry and academia, it's super trite because of how often you hear that with no real actual meaningful change on the back of that. It's just sort of realistically a company saying of like, hey, we just want to get connected to both of these areas. Right now, I'm kind of bucketing review and publication networks together because I'm actually unaware of many that disambiguate the two and that separate out where review happens that is not directly tied to conference publication or to a journal publication specifically. So I see these two networks as of now really having high overlap. And as I briefly alluded to, these three networks of research, review, and publication, for me, kind of constitute what I'm dubbing intellectual networks here, but they're only one aspect of a larger ecosystem. And so for me, this is what I'm thinking of as sort of the knowledge network stack, so to say, where you need a set of intellectual networks, right? You need the people doing research, doing review and publication, but then you need the actual social network layer, and how are we actually connecting and building community across those? How are we performing communications in terms of both media and advocacy? How are we letting the world know about the research that's coming out? How are we trying to actually affect change and make sure that people adopt some of this knowledge and it doesn't just live on, as we heard, predominantly on PDF somewhere in someone's virtual filing cabinet? And then at the end of the day, all of this work actually needs to be financed and operationalized. And I'll go through in a little more detail right now at some of these, the actual components of the networks within them. I already spoke about this one, so I just want to add that I added a researcher training component. So for me, in my mind, this is kind of taking PhD level folks and getting them dedicated to a lab, right? So it's someone who's already put in a lot of very focused time and attention, and it's giving them that final kind of nudge of training or the opportunity to actually do the work, to be an actual researcher and then, perform review, publication, etc. On the social side, this is where I see a much wider sort of learning pathway into it. So anywhere ranging from people who are aspiring researchers themselves, all the way through budding researchers of, say, equivalency of being a master's student, and you're almost there and ready to be at that kind of depth of research level. You just might not have had the opportunity yet, or some concrete focused learning opportunities. And combining that kind of layer alongside media and advocacy and alongside actual community building can really create strong culture binding activities across all of these different networks, right? Because I think one of the important aspects of thinking about this through the prism of networks is recognizing that each network has its own people constituting it, which means they have their own culture. And if you think of these larger ecosystems as being systems of many, many networks coming together, there's a lot of room for cultural misalignment. And that's even before we get to where's the money coming from and who's doing the work, right? Just people coming together, we do need some kind of culture of acceptance of differences. And that itself can take many different forms. And so I think that this social layer is actually tremendously important to focus on, to think of how can we create enough overlap on cultures to make sure that all these various networks, bless you, can actually work together in unison. I think on the financial side, it's probably a little more straightforward. I have a feeling everyone here has dealt with funding in some kind of way or other, and the joys of finding the groups and pockets of areas where there are actual funds to give out to research. I think the operational one is one that I want to click in on for a moment, because ops, in my opinion, is one that it's usually a function that is very not glamorous. It's not sexy. No one's like, yay, I want to be an ops person when I grow up, right? It's not one of these things that attracts as much attention. And yet, talk to any DAO these days or anyone building a project or a community, it's usually one of those most desperate needs of, hey, I just need people who can really get stuff done. And when they tell me they're going to do a thing, it actually happens. And that really exists within organizations, and that's already challenging enough. So what does operations as a public good look like? What is actually providing, in the context of research, training people up to be quality research project managers, and then giving those resources away to other ecosystems? So how do you genuinely support intra-organizational collaboration by injecting some of those operational needs? And as mentioned on the culture side, right, this is not a network itself. I don't think it's fair to categorize culture in any kind of network base, besides the fact that I don't see any kind of network with humans that cannot have culture. Like, humans inherently bring culture to the table, whether or not, I don't see why we wouldn't like it, but just like there's no way around it, right? When humans get together, inevitable cultures form. And so I think it's very important to think of, again, where is there room for that potential misalignment? And so this is just an overview of kind of, the stack side here with the intellectual, social, financial, and operational, and some of the appropriate network layers under each one of those. And so this is what I'm kind of dubbing as a knowledge network overall, this combination of all of these different networks coming together in a focused topic area. And so what does it mean to actually operationalize something? Because I'm sure it sounds like I'm hanging out up in the clouds, and I want to really bring it back down to reality and thinking about how do you put something like this into the world. And so that's where I'm really interested in, and we're excited at SCURF, and I'll tell you about the specific project in a moment, but we're really excited to kick off an effort of trying to create a variety of decentralized research centers that will effectively create all of the component networks, and realistically, we don't want to create it from scratch. It's about finding all the existing groups that are doing the relevant work and bringing them together and building that ops and financial layer around them to make sure there's more incentives for groups to want to play well together. And doing that in a focused topic area with a focused scale and really clearly defining, especially to kick off, of who is doing the heavy lifting and where is the money coming from. Ideally with as few strings attached as possible to truly focus on the end outcome and not on just helping a single organization who's in the position of influencing funding more so. And so I just want to briefly mention on the architecture side as well, because I was just mentioning, here on the left side of all the different knowledge networks, but networks are one component of it. All networks, especially if they involve information, if they involve communication, if they involve decisions being made, we are using some tools. There is architecture in place. And each one of those networks can have different tooling across all of these areas. And so how do you actually create technical alignment for people to just be able to share their information and have the infrastructure and the tech stack so that people can actually facilitate more collaboration? Because when these things are disjointed and non-coordinated, that again just increases the fact that there's 12 people doing the exact same thing and never really realized that just because they didn't have the right channels of communicating and sharing with each other. And obviously, culture and the convenience of use of some of these tools, as a few projects have mentioned, are also highly important, because we can create the ideologically perfect thing in the history of all things, but if it's not actually convenient for people to use, it's only going to be in small enthusiast communities. So for me, this is all leading up to what we at SCURF are really excited to try to support creating around Web3 research specifically. So we see this landscape up here of a variety of different decentralized research centers, and each one of them will have their own focus in terms of topic area. So the first one, to give a punchline from a few slides from now, the first one that we're actually going to be supporting is creating a DAO research hub in coordination with MetaGov and with the DAO Research Collective, and we are going to be working together on building a wider network that brings together academics, that brings together all of the relevant industry players doing research, and that injects more funding, creates actual pathways for new structured research opportunities, or for those coming out of academia, for gift-based funding opportunities, for sponsored research-based funding opportunities, as well as at least providing opportunities of potential consulting work as well. And if we have this kind of landscape where there's these variety of decentralized research centers that each go super deep into their focus areas, so say from our perspective, we want to see governance and then security and then cryptography and then privacy and all of these research building blocks in the Web3 space, there do need to be some meta layers to be able to support the overall activity. And we see at least things like review and publication, technically they can live within each one of these centers on their own. Right? Governance can have its own journal, and so could security, and so could every other kind of research subcategory. But is that actually what's best for the space? And we don't know the answer to some of the questions that I'll be posing, but we're excited to see this landscape of experimentation and to work with all the other groups doing interesting work in this space to just see how can we all support each other so that within a few years and as soon as possible, we can actually confidently answer some of these questions empirically and not just purely theoretically or gut feeling based. And at SCURF specifically, we've been working very hard to create this meta-level knowledge network layer where I will show in a moment what that kind of looks like for us and where we've been adding that activity. But again, I was just mentioning this DAO Research Hub, and if any, this is a QR code to the Telegram that we created, because yay, crypto, more Telegrams. But we created a Telegram group to actually focus area for at least folks who are very interested in this. And at Global Governance Gathering over the last 2 days, we actually had a 6-hour breakout on Monday on DAO Science, and then yesterday we got to do another panel on it, and we're excited to see some of the community coming together around that. And we are actually going out for funding on this. And all of the funding will go towards embedding postdocs and academic fellows across some of these networks and to build those bridges, as well as to build that operational layer and to introduce what we see as a new role type in the Web3 ecosystem, which haven't thought of a better name yet, but for now I'm calling them community cross-pollinators. So can you hire community managers, but their role is, hey, you as a community manager, go hang out in those 4 communities and tell each one in their community calls what you're seeing in the other communities, and then write about all of that on the Scurf forum. And that way there's this area where we can bring back some of the knowledge of what's happening around governance in a few governance communities in a single repo where we're not actually trying to own anything. We're only pointing back to whatever all the original information is, but there does need to be some intellectual facilitation layer so that people can at least be aware of it. And so the work that we've been doing at Scurf, on the architecture side, we've been building our forum and our GitHub to have this publicly available repo. Everything we do is free and publicly available. We don't charge anyone for any of our activities. We've been actively building a community, both in terms of Discord and the forum, starting to be more at events such as these at ethDenver, where we also got connected with a bunch of DeSci projects initially, and really thinking about what does providing that operational layer look like. And so we're very interested in hiring a bunch of project managers to figure out how can they best actually be supportive for a variety of these research communities. And we've also had a variety of funding opportunities that we provide for researchers in the Web3 space as well. And so to date, Scurf has very much been focused across Web3, and now we kind of want to split that focus into the meta layer as well as starting to dive deep into each topic layer. And in a world where we had more time, I'd tell you a little more detail about this. Happy to chat about any specifics on Scurf stuff later, but it's really getting to the point of we are starting with the DAO Research Hub, and we are very excited to then start working with other relevant communities later this year into next year to start building additional hubs. And security is going to be the next one that we're most excited about around smart contract audit security and security in the space overall. And we recognize that there are a tremendous amount of open questions around how to do science better, how to do Web3 research better, how to do governance better. Pick any layer of information we're talking about. There's a ton of open questions. And we are not pretending to have the answers. What we are trying to do is create this active experimentation landscape and to build bridges and communities as much as we can, again, so we can collectively work towards answering some of these questions together. And so if anyone here is actually interested in getting involved and wants to work and collaborate on Web3 research projects, we're definitely hiring for a bunch of roles. Please come find me later. I'll have my social stuff up later so you could ping me there. And in my final remaining time, I also want to mention that part of this experimentation landscape for us right now is actually starting a series of open peer review experiments where we are creating a minimum viable peer review process. And if you want to learn more about this, we're actually having a community call at 12 p.m. Eastern next Thursday on the 28th, I believe that is. And Umar, who's one of the folks who's been awesome in helping out with all the event planning here, him and another contributor, Nick Link, will both be running the community through our current process. But short story is we're focusing what peer review could look like for independent researchers, for folks who are not pushing towards a publication venue or towards a conference. And so we're definitely going to be presenting more on this soon. We're going to be running our first experiment starting May-June timeline. And this is sort of, just updating with some specifics of the first of the decentralized research centers is this DAO Research Hub that we're building. We're starting to experiment on open peer review, and that bottom layer is what Scurf is overall really focused on. So thank you all for spending some time, both for the presentation just now and also for just joining overall. There's my socials info as well as our forum info. This QR code goes to our Discord in case anyone thought that was fun enough that you actually want to be part of some Web3 research community and you want to get right involved. And yeah, yay over notification. I see people are joining. Lovely. So yeah, thank you all. And with that, I will invite up Patrick, who is going to be the moderator of the next session, as well as Thomas, Sina, and Nicholas. So round of applause for the transition in the next panel.
everybody. Is this on?
It should be momentarily, yeah. Try it out again.
Hey.
There you go. Here's
Hey, so
another
my
one.
name's Patrick. I'm
You'll
one of
have
the
fun.
co-founders of Research Hub. And we want to take a second and talk about open source development in DeSci. Thomas, go ahead, introduce yourself.
Hey, I'm Thomas. I'm the first engineering hire at Research Hub.
Hey, I'm Sina Iman, and I work at DeSci Labs.
Hi, I'm Nicholas. I'm a physician scientist, and I started LabDAO.
Yeah, so to kind of set the scene, there's like a wide variety of different projects within the academic ecosystem. For instance, ResearchGate is a private company that has a closed like source code. And then there's Zotero, which is an open access citation manager. And then of course Sci-Hub, which everybody knows, which is actually a closed source project as well. So I wanted to start things off and just hear the panelists' thoughts on like, is open source code important for science? Either way, and understand better why they think it is or isn't.
Yeah, so open source, it really is just like congruent with the ethos of open science and open access in general. Like it's right there in the name. And yeah, just like Web3. So I think like we all kind of know sort of the benefits of like open source, like the collaboration, the increased sharing of knowledge. And like Research Hub actually, it got its name because our founder, Brian, basically noticed that like academia, it's kind of like stuck in its old ways. It's like siloed, and it's been happening for the same kind of way for like centuries. And he pretty much noticed that like open source software, it's transformed the world, and like it's a big reason why like software is eating the world. Is most of the software you rely on every day is powered by like open source libraries. And yeah, the paradigm works, and it's the opposite of what's happening in academia and the world of research. So at Research Hub, we're trying to accelerate science and research by making research happen more like open source software.
Yeah, just to build on that, I think there's a couple of different reasons why you would go open source. Like a really obvious one is if you need to make your code like transparent so that anybody can understand what it does. Like in the case of smart contracts, it's really straightforward. It's like, if I'm going to put money into something, I want to have a guarantee that, I know reasonably well that the money's going to go and this contract's going to do what this person or entity says it's going to do, right? So that's transparency is one reason. Another reason would be basically to do, in a very mission-focused environment, to create a mission-focused community around something that has a high degree of utility. Open source shines when you have a high degree of utility in a project, because people don't like, okay, so something, if people don't want to reinvent stuff, and you kind of want to remove the encumbrance of having to reinvent stuff, right? And move on to solving actual problems beyond the infrastructure, right? So that's another reason, and creating this community, of folks that are mission-driven to solve actual problems and provide utility. And then I think another reason would be, it's a vector for adoption, right? Because by having something open and free, right, why wouldn't you just use it, right? So it's interesting, people, like, I know, like, in my consulting days, I would, like, constantly scour for code on GitHub and just be like, oh, we can just use this. So it's a vector for adoption, right?
So at LabDAO, we believe that open tools accelerate progress. And the reason why we believe that is because we've seen it in tech before. In tech, when Facebook develops a really good JavaScript front end, some of the engineers decide to open source it with the okay from Facebook. And then everybody has React, and suddenly it sort of resets the playing field, and the quality of everybody's work is increasing, and the security of the tool is actually increasing as well, because suddenly a lot of people are working on it, people are contributing to it, and actually it becomes a public good. So open source is really the OG public good when we think about sort of language that we tend to use in Web3. And that is, however, unfortunately missing in biology a lot of times, where when we have a laboratory workflow, when we have a new method, that method is shared in the form of a method section of a paper, but there's not a lot of incentives around maintaining a tool. and making sure that it works well, making sure that it becomes a community resource. And I haven't yet seen a lot of biotech companies, and thankfully that's actually changing, that open source some of their core infrastructure, some of their core tools. And we believe that LabDAO, which is at its heart an open source community, can take sort of that open source spirit into biology, into life science research, by basically creating a token incentivized community that maintains these tools that are being developed by scientists, gets them into like production grade state, and then deploys them and use revenue that is generated from such an exchange and plows them back into funding the maintainers that keep these tools running. Because the incentives in the academic system that we all know are not actually around building something that's particularly useful and will get a lot of users, but it's all around let's publish this paper quickly, let's make the code be good enough so it's kind of skates by through the peer review process, and then sort of move on to the next paper, move on to the next grant.
Yeah, I think the smart contract example is great too, because it actually it makes you build things in a more rigorous manner too, because you know if your code's like available for anyone to see and potentially exploit, like you have to be ready for it and actually build things.
It's so important to go early with releasing your smart contract code versus late. You know, it's because there are actually genuinely nice people that will point out problems, right? So.
Yeah, and so in theory it sounds good, right? Like you want like a big community of engineers who are just willing to spend their free time helping you build your project. But like, what are some of the challenges of having open source development? Like when you've participated in open source projects before, like how have they been run? How have you contributed? Like how does it actually work in like a day-to-day practice?
Yeah, so yeah, I've contributed to a few different open source projects. I've created a project, and I remember I created a project that was open source, and I was like, holy crap, everybody's giving me PRs and issues, and like, this is not my job, right? This is like a random side project I did on a weekend, right? And so that can be tough, right? So that can, but so there's a challenge there, right? There's a challenge where it's like, you know, we have a lot, like you have on one side, you've created a community that's interested, which is great, right? And you should, given that opportunity, probably capitalize on it and attempt to shepherd the community and attempt to just move things forward because it's clearly solving a problem, right? You know, but then there's certainly, you know, there's certainly a different model where you're building in the open, but there's not really much engagement, right? And that also has benefits too, right? Because, for example, by building in the open without necessarily a hugely mission-driven community behind you, there's benefits like, you know, transparency, this sort of thing. You know, you have a vector for adoption that's out there. You have certainly the opportunity to have a community in the future, that sort of thing. You certainly have the ability to, you know, potentially spin that off into, you know, its own separate thing and can take a life of its own. Like, and then also it also divorces the actual tech from any sort of corporate entity. It's because the corporate entity can, you know, for whatever reason, it could fail, right? It could be, you know, go out of business, but the code can still be online and available so that you're saving a lot of time. You know, you put a lot of work into this stuff. Just because your company fails doesn't mean, yeah, a lot of people should do more work in the future, right? So.
Yeah, just open source reduces like that risk of like vendor lock-in, or you invest all your time into like this platform and then they go insolvent or something, and then your work is like worthless. But now with open source, like it could continue on. The community, if it's passionate enough, could keep the project going. Yeah. And like it reduces like this the centralization risk, like the single points of failure. Sci-Hub, like you mentioned earlier, the founder, it's a pretty centralized project. She closed sources the code, and she doesn't really want to like open source it. We interviewed her for Research Hub. We did an interview with her, so. And yeah, we asked her that question, and she just kind of like shrugged and was like, I don't really feel like open sourcing. I kind of want to own it, right? So it's kind of like an ego thing, but yeah, it kind of ended up biting her in the butt because she got sued, and like basically she got sued by Elsevier and wasn't able to like keep uploading papers to Sci-Hub during this lawsuit. And like, yeah, science suffered for it because, yeah, this flow of information was stopped because of this central point of failure. And yeah, and it probably came at good, like, personal risk to her too. Like, being this central point of failure gives like people like a target to go for. Whereas if it's decentralized, then like there are like a lot of people who like express wishes to like if they could host their own like fork of Sci-Hub, they would do it, and they would do it like maybe anonymously, so that like be hard to come after them. But she kind of assumes all of this risk for herself, and yeah.
I always think too that open source code gives the community optionality. We can think back to like the block size argument with Bitcoin, and that's like a kind of divisive topic back in that time. And so since Bitcoin's open source, it actually allowed for the people who believed in different directions to fork the project and kind of take it in their own direction. And then there's like a Cambrian explosion of different kind of attributes, and the strongest one wins out eventually. So it's cool in a way that it protects the community from like the ability to kind of take it in their own direction, as long as you can build a coalition of people who go along with it. So I guess like the point of why I wanted to talk about this is like we've got a lot of cool projects here in the DeSci ecosystem, and I think it would be worthwhile for us to spend some time thinking about how we can build an open source developer community, kind of like Eugene was talking about during his presentation. Having project managers who show up to everyone's community calls, who are able to like share the learnings and like take some of the best parts of each project and make sure that they're spread around to everyone within the whole DeSci ecosystem. I think we could do this kind of like on an engineering code level, where like as a community, if we put effort into recruiting open source engineers, we'd be able to take the best parts of each project and make sure that they get spread around to everyone, and have like a pool of people who just want to see DeSci succeed. So I guess another question I have is like, as a community, what can we do to help like recruit open source engineers who like are personally motivated by trying to like address the issues that DeSci is trying to address?
So at LabDAO, we try to open up as much as we can on GitHub, and we try to build this sort of GitHub-centric organization, which is sometimes difficult if you have people that join the community and they're not familiar with contributing to open source. But I do think that if your ambition is, and it's certainly mine, to grow LabDAO into this like, global community that has thousands and thousands of members, it has to use the tools that have been tried and tested to coordinate useful activity at that scale, and Git is that tool. So I think building on GitHub is definitely a core element of like just sharing what you're doing, and then generally the idea is that you try to optimize the surface area that the organization has to the whole internet. So whenever I have an idea, there's no internal Notion. So with Notion, you have 3 people that are pilots. They can actually write into the Notion, and every additional seat costs you money, and there are a lot of viewers that can just see what happens. Well, with GitHub, you could just open an issue with an idea that you've had, and you don't necessarily need to even assign it to someone. You can also just wait for the internet, like this sort of coincidence machine, to have someone that stumbles over it and makes a useful contribution, and that at least within LabDAO has worked surprisingly well so far. We've some of the greatest contributors to the DAO have sort of just seen the tools that we're working on, seen the issues that we have, and just made pull requests. So I think that, just sort of using the right tools, tools shape culture, and at LabDAO we want it to be an open culture, so we use open tools.
Yeah, I think you have to make stuff that's so useful that it would be kind of stupid not to use it. And then from there, like, take a look at something like IPFS and libp2p. Like, IPFS started, and then it became, it was clear that this was a new way of, interacting on the internet, right? And then they pulled out this core libp2p, right? And then libp2p became almost adopted in like every major like crypto project, right? And it's a novel way of doing peer-to-peer communication, and it's freaking useful. It's tough to get started from the ground zero, right? And because it's so useful, it's created an amazing community around it. And so I think, you know, that's what it comes down to. You have to make something really useful, and then that solves like problems, and then people will adopt it, right? And then another thing on top of that is, you know, if your mission resonates, you're going to get people for that reason as well, right? So I think it's a combination of those two things.
Yeah, totally. So one thing we've actually experienced is like Research Hub is not useful enough for some people who are using our product. And we have like a pretty small team, and we have a roadmap of features we want to develop. And so engineers will come in and just say, man, I really wish you guys had an API, right? And so they'll be like, hey, make us a ticket, make us a bounty, we'll build you an API. And so, yeah, I guess like practically, like I don't think building not good enough products is a great recruiting strategy personally, but like, well, what can we do practically to try and help like bring more engineers into the ecosystem, so that way like a lot of these like cool projects that are here today can actually, you know, like come to fruition and build something that actually makes science better for the world as a whole.
Yeah, I think like events like this one are great, like recruiting tools, and just like help like give like a bat signal out, and like engineers around the world who are interested in science will like become aware of like, wow, there's this movement that's building. And yeah, so more events like this, I think.
I guess the other thing too is we have 3 minutes left, so if anybody has any ideas, like feel free to raise your hand. I'll come bring the mic to you as well.
Sure, absolutely, and thanks for offering it up to the crowd. I want to echo what Thomas is saying here. More events like this and more community engagement. I think we need as many of these events as possible, whether physical or virtual, and I think we need some dedicated people who know how to execute, maybe not necessarily know how to develop, but are willing to give their time to putting this on as a public good for the community. We're working very hard to build out a community organizer, community management layer across the space as a horizontal to focus on public goods like this. So I think it's building, nurturing, and respecting that layer in a way where we can really work to publicize the mission of the space, as Sina said.
Maybe as one additional thought, let's just build something that's useful. I think if we build something that just can't be ignored, if looking at a PDF, using a research object, or running a laboratory service, be it computational or in a wet lab, using OpenLab, or interacting with Research Hub instead of bioRxiv, or giving a paywall publisher, is just more useful. Then I think we'll just get organic contribution from people that are as excited about the mission that we're on than we are.
Yeah, I think our mission should be like unified to create as many composable Legos on DeSci as possible, and then all those composable Legos that we can make that are useful should naturally be able to form communities around them. And the DeSci, the idea of DeSci means something different to everybody, right? So there's going to be communities formed around whatever that means to you and what the problems that you're trying to solve are. But I think like there's like certain core things like data models that's just like, oh my God, let's just agree on something, right? Let's just do something that works, right? And like, let's get it done right, and like never have to think about that again. Like, you know what I mean? And just like, or like have a team that's like working on that and getting it done, and then like, and then push adoption that way, right? And so that we can agree on these composable Legos.
Yeah, there's an Aaron Schwartz quote that we like come back to all the time at Research Hub, and it's like, what is the most important thing you could be working on in the world right now? And if you're not working on that, like, why aren't you, right? So with DeSci, like, we have an opportunity to fix these like foundational meta level issues where like we're kind of like learning how to learn. We're like researching how to do research better, and like if we succeed, we'll have like tremendous knock-on effects across like many different disciplines. And like we're all on the same team here, like Scurf, Research Hub, LabDAO, DeSci labs. Like we all have the same goal of improving science and research. And if any one of us succeeds, like we all win, right? The Elsevier's of the world, their iron grip over academia loosens just a little bit.
Yeah, want flying cars?
Thank you, guys. Thank you very much. So thank you, Patrick, Thomas, Sina, and Nicholas. And we will now be having Philip, Darren, Chris, and Joel joining us for the next panel. So yeah, please welcome our next panelist as we get up here. And here, I'll give you the other mic at the other end. Perfect. All yours, Philip.
Hi, everyone. Okay, so we're here to discuss with you guys peer review in science. I would like to start off with a little intro round. So I'm going to start myself. So I'm actually a scientist. I've been in academia for the last 16 years. I'm a professor here at the Free University in Amsterdam. Been running a lot of different large-scale research consortia, published a lot, reviewed a lot. I've also been an editor in a couple of journals. And now I'm full-time with DeSci Labs and the president of the DeSci Foundation. So, Escape Hatch launched. All right. Chris, want to go next?
Well, thank you, Philip. Yes, we're building infrastructure for decentralizing a lot of the scientific publishing industry, as you've seen this morning. My background, I'm also a scientist. I did a PhD in neuroeconomics at the University of Zurich. After that, I worked in data science, machine learning, did a couple of private equity work where I studied investments. So I've been on the other side of the table and decided I was too young for this. So I went back into the startup space and met some fantastic people, including Philip right here.
Yeah, hi, my name is Joël, Joël van der Welen. So I'm a scientist, like Philip used to be, still trapped. No, so I work at the University of Amsterdam. I'm an associate professor of behavioral economics, so that's something in between psychology and economics. So we have a lab where we have people with a background in economics, but also psychology, neuroscience, etc. So yeah, that's my day job.
Hey everyone, I'm Darren Drew. I was a scientist for a short period of time before leaving as part of the first group of Teal Fellows to work on various biotech startups, especially in the synthetic biology space in the Bay Area. But got excited about new mechanism design for thinking about how we could rethink and build new tools for scientists to encourage more collaboration, more funding of high-risk, high-reward research, and starting an organization at atoms.org to do that. So thanks for having us. It looks like my photos from when I was 18 years old, though, so really appreciate that.
Hey, I didn't pick it. Okay, so let's start by discussing a little bit what the current status of peer review is. So, Joel, from your perspective, so how much value does the current peer review process actually add to the scientific literature? What are your personal experiences? What are the things that worked well for you? Which parts didn't?
Yeah, thanks. Yeah, so I think it's a bit, peer review is a bit like democracy. It's sort of the worst system except for all the others. Like nobody really likes it, but we don't really know what else to do because, as you might imagine, the questions that come up in science are often super specific, like, what does enzyme X do in context Y? And then there's really only like the people that work on that particular question that can evaluate it. So yeah, it's really hard to get around something like peer review to do quality check. But of course, what you want is something that's sort of unbiased or fair, and then also accurate, weeding out the sort of the bad research. So yeah, I mean, on both of these criteria, that things could be better, of course. So if you ask any scientists about their experience, you will get a long list of things about the times that they were treated unfairly by the system and people who had it in for them, and so reviewers are like people, so they come with their biases and their preconceptions, and so there's evidence for some discrimination also towards minorities or women in peer review, so that's of course serious. So one of the things there is that of course it's made anonymous for that reason, and but that creates its own problems as well. So people can get pretty nasty in an anonymous setting, social network style. So then things can get acrimonious, and that's of course unpleasant. So yeah, there are trade-offs there, but the anonymity. Yeah, I think, then the accuracy part. You want things to be, you want the bad research to be weeded out, and I think on balance, probably the worst errors will get weeded out, and I think most scientists will agree that research in top journals is better than that in less prestigious ones, because it's more scrutinized. It's partially because of the peer review, but it's hard because it's a voluntary job. I get like a couple of requests a month. I have a couple of hours to do it. I get a 100-page document on my desk with all kinds of appendices, and then I have to review that. So we can't just rely only on peer review. We need things like transparency codes and so on to help reviewers do their job, so that you can't hide inconvenient things. We need transparency codes for journals, making data sets public, etc., so that it's not just the reviewers who do the job. So yeah, basically it works, but imperfect.
Okay, let me jump in there. So the way that you describe the peer review system, it sounds like that primarily the function of the current system is gatekeeping to the top journals rather than actually improving the work that people are submitting. Is that what you're saying?
I think it's part of it. It's a bit of both. I mean, there are a lot of reviewers who do keep their, who are well-intentioned. But yeah, we have our biases, but also we have our, we feel like some people might, we kind of, it's typically single blind, the review process. So I know who the authors were, and in in the age of Google, it's anyway hard to hide these things. And so yeah, so there will be favors and so on, and there will be like biases towards more senior or top people at top institutions. Yep. So there is a fair bit of gatekeeping and in-crowd.
And I guess that makes sense to a large extent, right? Because as a referee, you have a limited amount of time, and you also, to some extent, just rely on cues, right? Cues that are easy to evaluate, and editors are basically doing the same thing, right? So if you have a famous name on the paper, it makes it much more likely that you're going to look at it with an open mind, and yeah.
Yeah, if there's a famous name, well, their preconception is like, well, probably it's not going to be terrible. This person typically does good work, right?
Yeah.
So that's human and maybe often correct, but sometimes it will lead to very bad outcomes.
Yeah.
But yeah, these things are in general they're human, right? So they're hard to combat, like in any system.
Okay, so Chris, maybe you can add a little bit from your perspective. So what do you think are the pain points of the peer review system as it currently is?
Very, very, very simple answer to this. The pain point is always reviewer 2. So besides reviewer 2, so I like to think of peer review as a system that works provided 3 conditions are met. Expertise is sufficient, the reviewer is motivated to tell the truth, and the reviewer is motivated to do an in-depth analysis of the manuscript, right? And there are many, many conditions, many situations in which one of these preconditions isn't met. And that leads to, all sorts of problems. I mean, it can be gatekeeping. Maybe remember that you're being peer reviewed by your competitors, and very often. And remember, you also compete with them for grant money. And they know that depending on your publication record, you might be attracting more grant money. So there's a inherent, competition, tension in the peer review process. And what I've been seeing more and more, which is really interesting, is the idea of creating open peer review. So I've had my work peer reviewed behind closed doors, and it's very, very hard to get actually the people to allow you to publish these reviews publicly. There's all sorts of process for that, and these processes are not simple to navigate. And one of the things, that people have started to experiment with is the idea of open peer review with real identity, or open peer reviews with pseudonymous identities. So these are all interesting things. And ultimately, another thing that's striking for every scientist, I think, is the heterogeneity of peer reviewers. When you get your peer reviewers, so very often it happened to me, I have one person who says, this is the best thing I've ever read. The second one says, this is, hot garbage. And then the third one is, the more balanced, constructive one, which gives you constructive feedback that you can build upon to improve your manuscript. And I'll also add to this that I've had a lot of constructive feedback from peer reviewers that have helped me produce a better scientific manuscript. So I want to also stress that point. So at the end, all of these are basically predictions that are done on your paper. Your paper is a high-density, information-rich object. And that object needs to be basically simplified. And editors rely on this simplification process that reviewers provide. And the editor ultimately is the one that is weighing all of these reviews and forming his own judgment on the reliability and the trustworthiness of these different reviewers so that the editor can make the informed decisions to accept or reject your manuscript.
Yeah, I was going to say, in some ways, I feel like we can kind of unbundle this process of peer review, at least in publications, into sort of two core functions. There's like this piece that's around feedback to the original researcher of, here are some things we've identified in terms of how we can improve your methodology, your analysis, your conclusions. But there's another piece of it that's around credentialing, right? This is sort of the gatekeeping you're talking about. We need sort of a form of scientific reputation that's legible, and sort of acceptance into the journal is a highly binary, legible state. And in some ways, there's a question of whether we can perhaps unbundle those two jobs. There's like the feedback portion of it, which is constructive and always necessary, and then there's the sort of reputation credentialing system.
Great, yeah, I totally agree with that. And just to add like a little bit the perspective of an editor, so one of the things that many of you may not know is that the editors for scientific journals, that they're also working for free in the vast majority of cases. So it's not only that the referees are not getting paid for their work, it's also the editors that are not getting paid for their work. So when I was doing editorial work, it often ended up in a situation where I was just getting a lot of papers on my desk, and my main problem was finding qualified referees. So people that were available to do an in-depth, highly qualified peer review in a limited amount of time. That was the main pain point that I had as an editor. And as an author, probably the most frustrating thing is the long waiting times before you actually get the first decision from a journal, right? So I mean, in economics, it's particularly bad. So we sometimes have like turnaround times of half a year or a year, and then you get a desk rejection, right? So it's okay. So let's move on to the second part, which is how can Web3 potentially improve the situation? What's special about Web3? Maybe you want to say something about that, Darren.
Sure thing. I mean, there's always a question of like, why crypto? There's it's often used as a hammer, trying to find nails out there. And in the case of science, I think there are a few things that caught my attention as somebody who has always been crypto curious, but also fairly crypto skeptical. And I think one of the pieces is, one, there's a lot of interesting experimentation going on in the general public goods funding ecosystem, and science is perhaps one of our most important public goods. And I think there's a lot of perhaps learnings from the overall public goods experiments going on. I think there's something powerful also about the sort of credible neutrality and the credible commitments one can make with these sort of crypto economic systems, where we can tie funding to potential either markers of reputation or other activities that we want to incentivize. So there's a vast sort of mechanism design and incentive design space that I think is interesting about how we could potentially foster more collaboration. Also the part around sort of credible neutrality, there are things there, I think, where we can guarantee perhaps open access to knowledge, these knowledge graphs in perpetuity, and I think that's something pretty uniquely powerful about crypto. I think there's also a lot of experiments on sort of open collaboration in kind of the DAO ecosystem, and I think there's always this balance, both in science and nonprofit models and for-profit models, of the tension between sort of collaboration and competition. I know a few folks kind of talked about it in the talks earlier today, and I think, again, there's a lot in terms of what crypto offers in the incentive design space on that front as well.
I wholeheartedly agree with this, and I think one of the most exciting things about this Web3 movement and the tools that are being created is that it's a vast playground for mechanism design, and it allows people to make credible commitments, and it allows an unprecedented level of transparency. And I think these are three specific properties that are not shared with other types of backends, other types of stacks. And out of that, we can start creating an ecosystem where we experiment with different modes of scientific validation. And I would like also just to stress that the emphasis on peer review is just a subset of the range of services in scientific validation. There's other critical things like independent replication, which are not incentivized, if at all, nowadays. And we need to create environments and ecosystems where we can credibly incentivize quality independent replications.
I could not agree more, but I would want to talk a little bit more about the peer review process itself. So how do we get the best scientists to actually use Web3 technologies? Most of them, they will not be familiar with it. They will not give a crap about what technology you're running in the background. How do you incentivize them to make that switch? So how do you actually get them on board? How do you reward them?
That's a great question. First of all, you have to hide the Web3 stuff. So hide it as deep as you can. Second thing, solve their pain points. Solve their UX problems. If you can solve their UX problems, their user experience problem, if you can make it easier to find qualified peer reviewer, they're actually motivated to deliver in time, that's a huge UX problem you solve. And the last thing is if you can incentivize them. And I think there's a powerful thing here. I'm not saying we should pay peer reviewers piecemeal for reviews. I think that is a risky path to go down. I think, however, that allowing scientific societies to recapture the value that they create by curating our scientific record is pretty fundamental. And we need to create systems for this. And so I think that if you can get a stream of value capture that is returned to the scientific society that has a scientific community to create micro-fellowships for scientists, that would be a motivating force to contribute to an open and transparent peer review system.
Yeah, so just to add, I mean, there is a lot of goodwill among scientists to do, the right thing and to help with these kind of things, right? So, one problem is that now essentially, if you are an editor, well, you know this better than me, but I got an offer to be an editor for an Elsevier journal, and essentially the offer is, hey, why don't you do a bunch of work for free for us so that we can maintain our 70% profit margin, taking work that's not ours and selling it back to taxpayers who paid for it in the first place. And there is a lot of discussion of that in the scientific community. The NWO, the Dutch Science Foundation, tries to stimulate this as well. So I think also the Ministry of Education, there should be a lot of people who are interested in helping you with this, including in science, but also the facilitators around this who want to push this, I would imagine.
So actually, I have a question to you as a behavioral economist. So we talk about incentive design. So what do you think would be an efficient incentive design for referees? So how do we incentivize them to do the work that we expect them to do quickly and diligently and honestly?
Yeah, so it's a hard one. So in economics, there are journals that pay for reports. So you get $100, let's say, if you provide a report in within a month. And the danger, well, maybe that's what you alluded to, is perhaps that, well, maybe I'm already motivated for, to do the right thing, and now, that I get the money, maybe that sort of displaces that, or maybe it's not even really necessary. But I find that at least within the current system, I don't know if that would work with in another system as well that works with different, has different institutional framework. It's a feeling like, okay, well, at least they take me and my work seriously, and at least I'm getting recognized for what I'm doing, even if it's even if it's not a high amount. So I don't think that's necessarily a bad thing, but yeah, I mean, people are different in that respect, so it's hard to make general statements. but some form of recognition would be good. And I think also you see that now in other ways, people trying to do that in other ways, like having awards for, you know, our top referees from the year, where the editors say, well, these people have been particularly helpful. So I think experimenting with those things, I'm not aware of real research that compares, you know, these themes, but would be very valuable. Yeah.
Yeah, I mean, there's always a question of, you know, how much of behavior, especially in science, is driven by like hard incentives, whether those are monetary, versus softer incentives, whether those are reputation, cultural factors, a feeling of duty to, you know, give back to the research community you're part of. And so one of the things that I think crypto often over-indexes on is perhaps the financial incentives too much. And I think especially in these public goods areas, sometimes over-indexing on the financial incentives can kind of backfire. And so I think there's going to be a mix of things. As Chris alluded to, I think a lot of the things may actually be more product design than incentive design. If you're actually building better workflows for doing the review, doing the collaboration, that actually in of itself may be a very valuable thing for both the reviewers and the research community, the original researchers.
Okay, let's end it here, and I thank you all for taking the time to discuss this important topic with me. Thanks.
Thank you very much. All right, thank you guys. Thank you all very much. As we get ready for the next panel, so let's get Brett up here. Let's just move the chairs over. Perfect. I think we just need 3 over here, right? Yeah, we're good with 3. All right, cool. So I will hand it off to Brett, who is moderating, and I don't know Tyler or Lawrence who wants to take that up, but all yours.
Okay, hello everybody. This is the panel on Web3 funding and funding tools to enable Web3, DeSci, decentralized science. So with me we have, well, I'll let the panelists introduce themselves. Go ahead, Tyler.
Hey everyone, I'm Tyler Galato. I'm a biochemist by training, and I'm one of the founders of Molecule and one of the co-initiators of DAO.
Hi, I'm Lawrence Ion. I'm a computer scientist by training with a huge passion for biology and personal health, and I'm a steward of deal flow at DAO.
Hey guys, Martin Kodire is my name. I'm a co-founder of Fleming Protocol. I'm, I suppose, relentlessly patient and product-focused when it comes to looking at things that can come out of the DeSci world. But I also recognize that DeSci and traditional science is actually broken for many of the scientific participants in it, or as it is, and we need to fix that almost above all else.
And yeah, I'm Brett Cornick, one of the co-founders of Impact Finance, with a background in material science and some experience commercializing technologies for a number of different startups. So I wanted to start with the question of, let's talk about, you know, today, what's broken. Let's talk about current funding mechanisms, current funding structures, and why they aren't working and why we need something new. So whoever wants to take this off.
Sure, I'll go first, I guess. If you look at starting from first principles, we mostly have taxes being paid, and then usually centralized entities making decisions on what should be funded. One of the problems, of course, is relying too much on citations. The incentive structures are broken. I like this study that is looking at basically within the replication crisis that many of you might be aware of. If you read the study, it's actually less than 50-50 that the results reproduce. So that seems like a problem to me. So we definitely, not just, if we just provide funding, it's not enough. We definitely need the whole DeSci ecosystem for I guess, incentives for reproducible research, so on the execution layer, but also maybe on the publication distribution layer.
Yeah, so I think currently there's a fairly robust grant funding mechanism that's in place in places like the United States or in Europe, things like the NIH that provide substantial funding for basic research. But one of the interesting things about that funding mechanism is that less than 2% of it is allocated towards researchers under the age of 35. So you have this massive amount of funding that tends to be going to sort of, whether you call them tenure track professors, very tenured researchers, and I think this is a huge problem. We know from the startup world that we have people in their early 20s building billion-dollar companies, doing a lot of innovative stuff, and the fact that less than 2% of this money is going, in the context of biomedical research, to people under 35, I think is a huge challenge that we need to overcome, and I think this would be a way to unlock a huge amount of innovation by creating a more sort of balanced distribution mechanism. When my perspective is very much influenced by drug development, this is the sphere in which I work, and in that sort of ecosystem, I think you have a couple of core problems, but the most fundamental is really this sort of translational valley of death that occurs between going from sort of early stage academic drug discovery and translating into the clinic. And one of the primary issues there is that drug development is extremely expensive. And one of the, I would say, driving factors for a therapeutic to get developed is whether or not a pharmaceutical company is really going to be able to generate a return from a sort of investment. This is challenging because there are a lot of rare diseases and a lot of ailments where there are just not strong incentives to develop therapeutics, but you actually have a very robust sort of research ecosystem happening in the earliest stages in academia. So one of the things I think that we could work through with Web3 and that could be particularly promising is just aligning incentives by getting patients and some of those researchers much more directly involved in the process. I think it would be bold to think that we could change the behavior of legacy institutions like pharmaceutical companies, but I think there's a strong chance that if a patient owned intellectual property around a therapeutic or had governance rights over how it came to market, their behavior would be fundamentally different from that of a pharmaceutical company, for example. So I think this could be quite promising and primarily focusing on this sort of translational gap and where we could really intervene in a drug development context. Martin, did you want to?
Yeah, so I came into the drug development or science world really when I suffered a spinal cord injury about 11 years ago, and I was kind of led to believe that science can solve everything and put a man on the moon, etc. It's all quite easy. I was like, no, it'll be fine. I'll walk again. It's no problem. And I jumped into trying to find where the cure was, and I found a lot of people are willing to tell me that their science was the solution. But I also then started learning about this reproducibility crisis that's already been cited. And that was incredibly devastating to me to learn that 90% of the work, and this is within spinal cord injury research itself, which I'm very, very knowledgeable of, couldn't be reproduced. And we actually tried to reproduce it. There was an initiative, a really great initiative within SCI research to try and reproduce it. And you're going like, well, what are you spending all this money on if no one can make any of it work? And then when I started talking to some of the, when I started getting really involved in the field and going to all the conferences and meeting all the clinicians, the scientific practitioners and the clinicians, you talk to them in the halls and they say, oh yeah, well, we tried that. We knew that wasn't going to work. We tried that in our lab and it couldn't work. You know, well, why didn't you tell anybody? It's not, you don't get incented to publish negative results, I was told. Like, well, that would have been more valuable than allowing the whole field to work on something that no one could reproduce for a decade, that then gets acquired by some biotech company and funded by a VC to the tune of possibly hundreds of millions, and then fails in phase 3 clinical trials for $1 billion. Like, if the science at the very beginning was reliable and everyone was incented not to game the system to get more grants, but to provide something that really was going to provide a positive outcome for society, we just have so much more resources to spend on stuff that will help society. And that spans all science, I guess. I'm not an expert in photovoltaics or battery chemistry, but I guess it's the same. And I think that when you look at it from the end user, the taxpayer, as we all are, and as everybody who funds all this stuff is, that needs to be fixed. And I think we have the opportunity here to do that. And I'm not saying that blue sky research can't be part of it, because I think that's almost more important than the translational side. I think also everyone's told that you have to say what the application of your science is. So you're kind of saying, oh, well, this can cure MS, or this is a battery chemistry. And everyone knows, no, it's not really translatable. It's not likely to translate. It's too far away from that pipeline. So even in that regard, we need to segment, like blue sky, new stuff research from translational stuff. And people shouldn't be trying to game that system, or shouldn't be encouraged to game that system based on what the legacy system that exists.
Yeah, and so I'll just add that I also believe that with current funding structures, there's not really a good evaluation of product market fit before research is even started. And it's because a lot of funding, especially SBIR funding and some grant funding, is in response to solicitations by centralized bodies, as opposed to, say, something that is selected by a diverse community that, say, votes on funding. Because if you're able to select research to fund through that type of mechanism, you've already been able to validate some type of product market fit in the community before engaging in research. And I think you can eliminate a lot of the failure in the valley of death and wasted money spent on research if you can validate that. And that's maybe a segue into the next question that I have, which is, should commercialization of research be a primary goal for research? And if not, what Web3 and DeSci incentive tools can we use to incentivize research that maybe doesn't have a clear commercialization path?
Yeah, well, I think that this is, it kind of harks back to what I was saying a little bit earlier, whereby, no, absolutely not. Not everything needs to be translatable. And there needs to be a clear divide as to what is novel and what is translatable and what's closer down the pipeline. And I know they have all these technical readiness levels that I think NASA created them, and a lot of the NIH, et cetera, uses to define where you are in the pipelines. But I don't think that's really used as much, because so much of this is also about like what the media think or what the public think. How many YouTube views did you get on your YouTube paper, or when you've made it into a YouTube video? And I don't think that's really compatible with good solid science. Solid science is really hard to understand. And you can't put it into a tweet or a little YouTube video. It's hard to understand, and we shouldn't be trying to optimize for, public likes from people who aren't educated in those fields. So that thing, it just simply means that we should segment them separately. And if one of the guiltiest parties in this regard is university media departments. Like, when you talk to the scientists, they say, well, I'm sorry that came out in the media that way. Like, that's not what I said. And the media department tells it, oh, this is going to cure, or whatever it might be. And then mouse walks again, or there's a lot of mice walking, right? And the media, like the universities, are doing the same thing. So we need to stop that.
Yeah, I philosophically strongly agree with everything that Martin said, but I think that there's a couple of things that in the context of DeSci we have an opportunity to focus on, being that this is largely Web3 and crypto-driven, which means that we can leverage a certain financial infrastructure that was previously unleverageable. And so in my view, one of the exciting things that we can do here is tackle some really, really core pitfalls when it comes to translational and commercial research, and try to create funding mechanisms that are inherently sustainable, which is something that has been intrinsically difficult to do before. So just from like on a philosophical level, strongly agree that basic research is extremely important, but it's also very, very difficult to create sustainable funding mechanisms around this. So one thing that I think we could focus on that is quite interesting is creating a mechanism where you have incentive-aligned communities that are funding translational research, with the economics being such that all of the money is basically returned to a treasury that's managed by those core stakeholders, but not, let's say, through a mechanism of paying dividends or something like this. This is a mechanism that is implemented in VitaDAO, for example, where you have a community that is generalist, enthusiast in many cases, with another layer of researchers and domain experts that are helping guide that community in making decisions. They work to fund specific research in exchange for ownership in the intellectual property that results, and then they basically work to commercialize that through a mechanism where any of the proceeds go back into the treasury to fund further research. And I think this is quite important for the field at the moment, because I think what we want to demonstrate to the sciences broadly and to funding bodies is that there's some sort of real mechanism here to have economic power to actually fund science. In the end, science requires a lot of money. Something like drug development, to develop a therapeutic to market, for example, costs upwards of $2 billion. And I think we have a lot to prove if we're going to really become a meaningful player in this space and actually make a difference. But I would also be extremely excited to look into more experimental ways, maybe even leveraging DeFi or something like this, to actually fund basic research and have some sort of commercializability from that, or not commercializability, some sort of sustainability from that.
I sometimes talk to researchers as part of my job at VitaDAO, trying to source projects, and they are working on pretty basic research, and I really want to be careful. I don't want to skew the research towards some translational aspect necessarily too early. I suspect most of the most valuable things come out from unexpected places, and we should let people sort of explore and provide a safe sort of provide long-term funding to allow curious people to explore, and at the same time not go into the other direction either, to just have papers for the sake of writing papers. So it takes a good eye there, I think. Which I don't necessarily have, but I of course talk to amazing people on the team, and to see, is this adding anything in terms of basic research, or would this rather benefit a lot more from going translational? Because ultimately that is what we really want from research. Apart from curiosity, sure, most of it is because we want therapeutics that keep us healthier for longer, right? Takes some expertise, I think, to identify when it's good to translate and when not.
Yeah, and I think that ideating around solutions to these types of questions is what really gets me excited about what Allison at Foresight Institute had presented on earlier with these technology trees, where if you can connect basic research to the actually commercializable technologies that they're able to lead to, and then reward the researchers that are doing the basic research, I think that that is a phenomenal way to incentivize something that may not be directly commercializable when it's proposed.
There is another aspect of your question there, right? What if it is translational, but it's not really commercializable in the sense of it can't really make a profit. It doesn't have a business model. Like it's a clinical trial of a repurposed drug, like rapamycin. And what do you do there? Well, there are some ideas like pay for success. You get a health insurance, maybe, or more likely life insurance, or governments to pay if you reach this endpoint. Actually, even XPRIZE, right, is sort of a pay for success. They can say, if you have 20% reduction in this with any drug, it could be even novel molecules, of course. That's going to cost a lot more, but yeah, you could fund the whole pipeline that way. But yeah, even if there isn't a business model, I think we can iterate a little bit. So start with something very clear, like repurposing something like rapamycin. If you get some success, you get paid. So basically you have this payer which only pays for success, and then you have investors who, just like with XPRIZE, right? You can invest in small teams to try to win that prize. So you create some capitalistic incentives.
And so I think we're already pretty much at time, but to wrap up, I want to ask one question and ask each of the speakers to keep their answer to like one sentence, and this will certainly not be adequate for answering this question, but what role, if any, should VC money play in decentralized science?
yeah, I think VC money could play a very important role so long as it comes after there's initial distribution of ownership to the community. So my sort of main point of importance is that we need a lot of liquidity in this space to be able to have impact, but it cannot come at the cost of community ownership and community governance. And if we can solve that paradigm, I think there's plenty of room for both to coexist.
So we at VitaDAO fund before it's a startup, so we can bring it to a stage where it's de-risked for VCs, but also there could be other decentralized funding vehicles to compete with VCs, and that's going to be, it's going to make them improve. So.
Yeah, so VCs is a particular group. VC money is a particular type of investor that requires very large returns, right? I think that's most investors at the end of the day. But if your VCs or your investors are aligned and knowledgeable about the area that they're investing in, I think it can be like a win for both sides of the equation. But I also think that within the, as Tyler said earlier, within the DeFi community, there's a lot of people out there who came for the returns in the DeFi degen world, and then they stick around for the excitement of what we're trying to build here. So maybe there's new types of VCs.
Totally agree. And so thank you to everyone, and we'll wrap up. Obviously a lot more to talk about here, but I'm sure we'll have those conversations in the future. Thanks.
Thank you.
Thank you. Thank you all very much. And next up, we're going to transition to sort of one presentation split between two groups. I don't know, Lawrence or Nicholas, I don't know which one of you is going first. But yeah, please feel free to hop up. Yeah, we have the VitaDAO slides up first, so all yours.
Yeah, I'm Lawrence Ion. I'm a deal flow steward at VitaDAO, as I said before. Not Molecule, the slides are a bit wrong, but yeah, I have some uncomfortable questions. How would you like to die? Actually, statistically, a third of you are going to die of cancer, a third of you of heart disease, and the rest are going to be lucky enough to pick off some other goodies off of this list. You know, diseases and mortality go up exponentially with age. Most people over 65 have at least 2 of these diseases. So there are good news, though. We can change that. Our mission at VitaDAO is to extend health span and lifespan through researching and incubating therapeutics, getting them closer to market. We don't have any therapeutics yet available. Don't listen to snake oil, but we are trying to approach medicine in a different way. Just like crypto, which is sort of changing the way finance is done, longevity is also revolutionizing the way medicine is done. There is actually a huge overlap between the key opinion, well, actually, alignment with longevity for the key opinion leaders like Balaji. Actually, a lot of top key opinion leaders in crypto, for example, Vitalik and you know, Brian Armstrong from Coinbase and Jed McCaleb from Stellar and so on. And I think it makes sense because both fields have been dismissed by the incumbents. We are basically aligning the most forward-thinking scientifically with the most forward-thinking economically. And you have a lot of newly minted millionaires and billionaires who want to do something impactful with their wealth. So we are a decentralized collective, incubating and funding longevity research projects before they're a startup, trying to create more startups for VCs and angels to fund. We are democratizing the advancement of and sort of exposure to the rejuvenation biotech industry, geoscience, also another name. So versus a traditional startup or VC that would try to do this, we can definitely scale much faster, deploy much faster, because we are open and permissionless, and we have network effects with our community and token. So usually drug development is stuck treating the effects of disease instead of the causes, like aging itself. Most chronic diseases of aging, that come with age. Hello, hint. And intellectual property ownership is even more behind other financial assets. So yeah, it's really got to bring this into the 21st century. It's currently liquid and difficult to transfer, and it's got a long horizon to exit. We, the public, don't have any real ownership in IP. There's this translational gap that Tyler mentioned earlier, the valley of death, between having some scientific discovery in academia. There's a lot of valuable IP sitting in university shelves that we want to de-risk for further investment by VC and pharma. Also, government grants are very bureaucratic. You have academics, like the PIs, spend 80% plus of their time on writing grants because they're so long and boring. And instead of actually thinking high level, designing experiments and so on. And of course, they're slow. And yeah, risk averse, iterative, keeping the status quo. So talk to any pharma person, they'll be very impressed when they hear that we have slowed down. This is super feasible. We have slowed down aging in animal models by over 20 different pharmacological interventions. So yeah, we solve this by finding the best aging research at institutions and holding IP on chain. And so we enable liquidity, fractionalization, and I'll talk a bit more about that soon. So yeah, we leverage our community to develop the assets, de-risking them for further investment. And we have an easy application, very short, quick funding decisions, and so on. And we want to be sustainable. We want to have longevity as an organization as well, to reinvest the proceeds that come from the monetization of the IP that's generated with our money, and therefore we can have more impact and decide what to do with the treasury, govern it with the governance token, VITA. The past 10 months since we've started doing things, we've actually been pretty productive, looking, sort of zooming out, a lot of deal flow, projects, really interesting projects funded, a lot of people getting involved, hundreds of researchers and a lot of enthusiasts and operators helping us, and yeah, we've deployed a lot of money. Typical check size from 50K to up to $1 million. Typical is like 250K. Yeah, so to explain a little bit how a DAO can hold intellectual property on chain. Well, we have this NFT that is sort of tied together with a legal contract. You got that legal, real-world license, exclusive license or sub-license, or future of a patent rights, and then the NFT is sort of storing those licenses and the data, those agreements. And of course, this can be super easily transferred. It's programmable, and it can be fractionalized to our friends. We call it fair, reasonable, ethical, non-discriminatory sub-license. So if you want to do a research project, you could have your the FAM NFT, which is the fractionalized asset manager held by VitaDAO, and the friends, which are individuals. And yeah, you do your friends and fam round. yeah, much cooler way to do research, I guess, and find funding. So sort of demystifying the IP NFT. It's pretty simple. You've got the legal contract referencing the wallet addresses. You've got the the NFT unlocking metadata and encrypted data, and it can hold the legal contract there as well. So they reference each other. Pretty simple thing. How am I on time? Okay. Did some projects that we funded that want to feature. Check them out later on our website, even nonprofit initiatives as well. So yeah, I'd love for you guys to join. It's an open and permissionless community. If you're a researcher, you can apply for funding on our website. If you know researchers, we have bounties. And yeah, if you love it and want to help, we have open roles. And yeah, I'm Lawrence. I'm the Deal Flow working group. And yeah, get in touch. This is my information. Thank you, and live long and prosper.
Perfect. Thank you, Lawrence. And then next up, for the second half of this group presentation, we're going to have Nicholas from LabDAO. So take it away.
Hi. I'm going to talk about LabDAO. At LabDAO, we believe that open tools accelerate progress. And sharing open tools among scientists is actually not a really new idea. Scientists have been sharing tools for most of history, and this is just one example from the Cold Spring Harbor summer phage courses after World War II, where scientists, both from biology, physics, chemistry, would come together and they would share instructions of how to culture phages, how to experiment the interactions between phages and bacteria, and they would also sometimes share scripts with each other and maybe even do experiments for the other person that doesn't have access to phages or bacteria, for that matter. However, in those small-knit communities where scientists exchange services, exchange favors, a lot of these favors are exchanged based on trust and based on a gift. However, as groups of scientists grow, and we want large groups of scientists to work together, we need a better tool to allow that to happen. And that's what we're working on at LabDAO, where we want to build a global community of scientists that work together. And scientists tend to gather together in teams, and then between these teams, however, where the trust is maybe not that strong because the focus of the different teams is so diverse, you need an exchange to trade favors. So for example, over here you have a lab that's developing a new method to fold proteins using deep learning, and over here you have a lab that does a lot of mass spectrometry. Wouldn't it be great if they had a relatively low trust way within a community to exchange services that was somewhat programmatically? And this gets us to the point where maybe if that exchange existed, we could even abstract biology into something that felt a lot more like code, where code has a very low cost of execution and high reproducibility, and bio is the total opposite. It has a very high cost of execution, very high capital expenditure to just get started, and then a very low reproducibility. So can we abstract the process of running an experiment, the process of running a laboratory service, to the point where it's just basically submitting a transaction using a smart contract, and you can do that from your command line because you know within that community that's correctly incentivized that someone else within the community will pick up that request and do the job according to rules that the community has agreed upon. So this is where the Open Lab Exchange come in. That's really step one of what we're building. The Open Lab Exchange is at the heart of an exchange contract where clients that want to consume a laboratory service can pin a request, it's really just a JSON, to IPFS and share that with the whole community. And then a provider, another scientist in the community, can actually read that request, claim the bounty that has been placed in the exchange contract that is in escrow, and get to work and pin the result back to IPFS. So the core elements of the stack are really IPFS estuary, which is a wraparound Filecoin. We use the graph to read the state of the contract, and we deploy on very low gas chains such as Gnosis chain and Polygon. So what this entails is you need a standardized laboratory instruction, an instruction that both a computer can read and a human can read. And this is just one example for a prototype for DNA sequence reverse complement, which is sort of our hello world. And then you need an exchange contract, and you need a tool to interact with that. So this is the Open Lab command line interface, where here on the black side, you have a client that wants to consume laboratory services that's basically now submitting a job for a couple dollars referencing this instruction using the command line interface, where you have a wallet locally on your hardware, and basically submits a job to the exchange that's maintained by the community. And then on the provider side, here green, a provider, another scientist within the community, can look for jobs that are open, jobs that could be worked on, and basically checks, all right, which jobs are open, downloads the instruction for the job that is open, and then gets to work, takes the result, posts that back to IPFS, and collects the bounty that has been placed by the colleague that is requesting the service. So the output of that, when you have standardized laboratory instructions, is a tokenized lab result. And this is just one example of a reverse complement that we can display on OpenSea or dedicated exchanges, such as the one that Molecule is building. However, an exchange in which favors are traded is just step one. Step two is you actually have to standardize the way that these favors are defined. You have to standardize the laboratory process itself. And we believe that that standardization will come because there's a very high cost to conflict resolution if everybody gets a tailor-made solution. And everybody that's been working in biotech or that's been working with contract research organization knows the pain that it takes to go through these negotiations and go through these sort of custom-made contracts. So we're starting out with very, very low-cost laboratory services, which are laboratory services that run on your computer. And we take tools that we believe to be extremely useful, but also extremely hard to use. And as an open source community, we clean them up and we put them into containers and we make them easily executable. We do this for small molecule research, but we also do this for protein engineering. And I'm extremely excited that we have people from the deep community, Stanley Bishop, for example, that helps us with MolPol, small molecule design using active learning, or people that used to work in the University of Washington and the protein engineering side, RiffDoc, for example, Brian Wetzner, who is helping us with the protein engineering side and basically just making these tools more accessible for everybody in the world. And then step three, really the long-term goal of what we're trying to do with LabDAO is that if scientists come together in a community, in a DAO, and they exchange favors with each other, those receipts that are created by exchanging favors, they actually are really useful metadata. And that metadata is basically an organically growing knowledge graph for biomedicine, where every job that I submit is a metadata object, and every result that comes back is an NFT that contains information. I can query those token descriptors, and I can basically create a whole index of experiments that has been run before, and I can access the data that has come out of these experiments. The DeSci future we want to live in is a future where everybody can raise funds using tools like Gitcoin, VitaDAO, Science Fund. We want to live in a future where also everybody is able to run laboratory services, no matter where they are, using the tools that we're, for example, building at LabDAO. And then we also want to live in a future where everybody is able to share and distribute their insight using the tools like OpSci, Molecule, and DeSci Labs is building. We're building LabDAO right now. We're a fun group. And if you want to join us, head to labdao.com.
Damn, good on you. You ended early. Thank you. First person of the day to end early. Uh-oh. Slide. Oh, what's going on? Alrighty, so next up, we'll be having our final panel of the day. So if I could please get Vincent, Tyler, oh, Nicholas, yeah, you didn't have to leave, you're coming right back up. Nicholas, Tyler, Lawrence, and Vincent for the final session of the day. Where's the other microphone? Here you go. Here's the other mic. Hello. All right, I'll pass it off to y'all for...
Hello again. Same people. All right. Welcome everyone to the panel about IP NFTs and their role in the DeSci ecosystem. I think I should know the title. So let's start with some introductions. I'm Lawrence Ion, a steward at VitaDAO.
it's unnecessary to introduce ourselves again. But I'm Tyler. I'm the Chief Scientific Officer and co-founder at Molecule, and a steward within VitaDAO as well.
Hi, I'm Nicholas. I started LabDAO, and I'm a core at VitaDAO.
So I'm Vincent. I'm kind of the tokenomics and product steward at VitaDAO, and then also joined as chief product at Molecule.
All right, let's establish a flow here. So let's start with a quick introduction about what an IP NFT is, and can anyone use the platform to create an IP NFT?
Yeah, so IP NFTs are basically just a way to leverage NFT technology, a non-fungible token, to bridge intellectual property into Web3. So as Lauren showed earlier, there was a sort of anatomy of an IP NFT. It's basically a smart contract that's referencing a real-world legal contract in a specific jurisdiction, typically in the form currently mostly sponsored research agreements or contract research agreements, which basically allow a funder who's interested in funding a research project, whether that be an individual or a community like a DAO, for example, to enter into a contract where they fund a specific set of experiments in exchange for ownership in the intellectual property that arises out of those experiments. In essence, it's almost like a futures on intellectual property, but the design space for them is much wider than this. So we're currently looking at the implementation that I'm describing is the one that Molecule's sort of been pioneering and is currently in use by organizations like VitaDAO. But I think there's many other interesting ways to use these that go far beyond these sort of high-ticket, high-budget research projects and having community-owned things. For example, the implementation that Nicholas has been designing in the context of LabDAO. But yeah, maybe one more quick point on that. Currently, we're doing a lot of the design mechanics around IP NFTs are quite primitive, I would say. Like the way that we're using it in Molecule, it's sort of like when Netflix used to ship you DVDs to the house. We kind of need to think more in terms of like, what does the streaming model look like? And what I'm personally interested about is how we move beyond patents, contract research agreements, and actually develop a sort of new intellectual property system that lives fully on chain.
Yeah, I tend to think about IP NFTs in a sort of 2x2 matrix of, on the one axis you have, is this traditionally legally backed intellectual property asset, or is it completely only backed by cryptography? And then on the other axis, is it a future on IP? Like, is it future IP, or is it IP that has already been generated? And then at VitaDAO, we care a lot about legally backed future IP, and that's basically we fund scientists to generate future IP, and then we want to own some of that future IP. And then at a marketplace like Molecule, and you know this way better than I do, you can also purchase IP that's already been developed and that's been tokenized. So then you're sort of on this other bracket where you have a legal protected form of IP that's already been developed. And then what we're doing with Open Lab is we're basically creating a minting machine for IP NFTs. They're not legally backed necessarily. They can be legally backed, and we're working on making these things extremely well interoperable. But they're just protected by cryptography. And that's totally fine because the result that comes out of one experiment, you don't need to register with your technology transfer office at a university every time you run the Western blot, right? That doesn't make a lot of sense. So you just need to encrypt the result of that Western blot if you want to eventually maybe license it out to someone else. So we just by default, not yet, but we'll get there, encrypt basically the result that comes out of an experiment that you're requesting, and then that is your IP NFT, and only the holder of that IP NFT can access the result. But then they could seek legal protection for that as well. So that's the sort of the 2x2 matrix that I think about.
And I think one helpful thing also from a framework, it's almost like a ERC20 token standard, should be like a public good and open protocol that like everyone can like freely use for build on and get grants to build on. Because I think ultimately it will only succeed like long term and broadly if like people are like adopting those standards and building on top of them and adding to them like a ERC20, like a ERC like 721, like different token standards that emerge out of Ethereum and like basically became the prominent ones. And I think that's something where also like all of you can like at some point like help build this out, but also get grants to build on top of this or add to it. So I think that's where we want to go over the next few months.
Question I get a lot is, how can this NFT thing on blockchain be legally binding? Who the parties are that a court would talk to? You know, who is like owning the actual IP? Who's it sub-licensing it to? Does it say like, oh, it's sub-licensed to like an Ethereum address? Like, how's the?
Yeah, so I mean, this is a framework that we've been working on developing for a couple of years, specifically because there's a really high sort of legal overhead. So, I mean, DeFi, I think, in a lot of ways, was very successful very quickly and scaled very rapidly because it didn't have to have touch points with real-world financial regulations and infrastructure. DeSci doesn't really have this luxury in a lot of cases. Most scientists are employed by a university. In most cases, if you're dealing with intellectual property, you're dealing with a tech transfer office. So you need to figure out ways to integrate sort of in the context of this pre-existing system and interoperate. And so from a legal perspective, the frameworks that we've been developing are mostly focused, again, on, let's say, if you're looking at sponsored research, leveraging pre-existing sponsored research agreements with a specific clause that enables sort of limitless or unlimited sub-licensing by parties. So the way this actually technically works is you would have two parties engaging in a transaction, a proper legal transaction. They would then sub-license to this IP NFT framework or to a specific address, for example, and then that address would have the ability to further sub-license to parties where the identity is known. But this is also a limitation. I mean, some universities, for example, in the United States, have, it's very difficult to transfer IP without any restrictions. So at the moment, the framework is somewhat modular and is sort of adapting to these different use cases. But in order to have it be successful out of the gate, and in order to be able to get the University of Copenhagen and Washington University and some of the universities that have sort of taken the leap to actually use this framework to use it, there was a huge amount of legal engineering that had to go into that. I think in the future, the more interesting space is actually going to be one where you try to create sort of technology-based enforcement around intellectual property. So how could we use smart contracts themselves? How can we leverage the blockchain being permissionless, being immutable? How can we leverage the programmatic nature of NFTs to create a system where people simply wouldn't go and file a patent because it's easier and maybe more economically stimulating to actually just plug into this sort of technology-based system. But I think that's going to take a lot of work and a lot of effort and a lot of collaboration. We're also, I think we all have this sort of, on this stage at least, like strong bias of biomedical research. Obviously, this science is incredibly broad, goes well beyond this space. And really looking forward to seeing a lot of other bright people in the space come in and try to figure out how we can actually architect an intellectual property system that works better for everyone.
Yeah, I think sort of complementary to protecting your intellectual property using legal means, if you wanted to go completely cryptography native, there are some, I think, elements that people would be very uncomfortable with. So, for example, if your wallet, if your seats are lost or spread, then all that valuable data would be completely shared. And so it's sort of, I think, also on a cultural level, we just have to get there. The walls have to get better. They have to become more fail-safe. But I think in the end, we might live in that future where the value of a legally sort of backed IP NFT and just a cryptography backed IP NFT are going to be considered almost the same, because if you also have the on-chain record of how that cryptography-based IP NFT was generated, which, for example, on the Open Lab Exchange you do have, like people see how much money you paid someone else to run the experiment that generated the data that you're now protecting using your IP NFT, and you can even, eventually maybe you can run zero-knowledge proofs on that data, and you can show the Kaplan-Meier curve, and other people can actually validate that your drug has that Kaplan-Meier curve. Then you might actually have all the properties that you need in order to make that a viable alternative to like patent protection.
Patent is just a legal way of being like first, and I can prove it.
Like dips, yeah. And I think actually this sort of idea of like calling dips in biomedicine has really helped the field back. In tech, nobody says dips. Like I discovered random forest classifiers. Okay, cool, right? Like what does that do? Right, you only become extremely wealthy, or you only create a lot of value for others if you actually then take that and you build a really good product, and you're the first that builds the product, or you built the best product, or you built the most affordable product. And we need that same culture in biomedicine too, where it's like, oh yeah, you discovered this, cool. Now, like, be the first to market, have the best medicine, have the most affordable medicine. And our regulatory infrastructure does not allow that because, for example, the FDA requires every company to be extremely transparent about what is the formulation of the medicine that is going through clinical trials. And you could, when you hear about this the first time, you could think, oh, that's actually a good idea, right? It should be fully transparent what goes into a patient when you enter a clinical trial. But the sort of second-order negative effect of that is everybody knows the moment that you go into clinical trials, and if these clinical trials take a long time, there's no competitive edge. So we need to maybe rethink really on a very systems level how we how new medicines enter the market. And for the time being, where this is not the case, we just need to work with the system. And I think that's really what you're doing and what we're sort of complementary to.
So as these IP NFTs can sort of act as access keys to data, how does that work with fractionalization?
Yeah, that's a great question. I think in the end, it'll ultimately come be up to the NFT holder to decide what the access tier on that sort of, or what the access control to that data repository layer looks like. I mean, what's interesting about IP NFTs is, in theory, you can package together as a sort of programmable, transferable unit all of the ownership rights and all of the data that would be relevant. But you might, for example, depending on, you might need to sign, for example, an NDA to say that you're not going to leak this if you access it. You might need to have, like, for example, in the context of friends tokens, it might be only holders above a certain threshold have access to data, for example. But yeah, I think this is something that, again, due to the nature of code, is highly programmatic. And I think in many cases, the value of these data sets might be something that sort of transcends simple pay for access, or at least that's a hope that I have, that it's not a function of a bunch of people just getting together, fractionalizing something, and then saying we want to keep this data hidden, but trying to figure out what is the same way with open source software. What are the sort of new business models that enable open source to thrive, that enable a community to come together, share access to data, and maybe have an exchange that goes beyond something financial. I mean, similar to what you were talking about with LabDAO, you can have exchange of services or exchange of knowledge rather than just pay for access or something like this.
Yeah, I think the big power is just that ultimately it's, I think, even of crypto and of what we do, just in the grand scheme of digitalization and with research and science, we're still stuck in the paper age kind of with patents. And I think same for DeFi and NFTs, like DeSci and IP NFTs and other building blocks just enable fundamentally new technological possibilities, like unlocking the data with NFT, even at some point having liquid IP, and just ultimately in a sense for me, technology is neutral. It's just how you shape it and how you use it. I think it's pretty wild what you could do with a liquid IP NFT. You could have an index of research. You could borrow against research if it's liquid. You could do all kinds of crazy things. And I think that's the power of crypto, is just that we can run all of these experiments in parallel. We can have 100 IP NFTs and fractionalize some, open source some, do all kinds of weird shit with it, and see what works and what ultimately translates or leads to successful research outcomes. So I think this speed and iteration of digital experiments, I think, is the biggest power that will make it successful.
I think that's really the hallmark of a standard. And I think why we care about it so much, because we want to invite people to experiment what can be done. One use case that I tend to think of quite a bit, and I think VitaDAO was sort of also launched around that spirit, was people coming together and buying up future IP NFTs, basically creating something that Andrew Lowe sometimes considers the biotech mega fund. You just pool a lot of capital, and then you take a lot of very high risk bets. And given the fact that if you construct a portfolio of research projects that are relatively low correlated just in terms of the biochemical risk, then this can actually be a sustainable business model, and you just channel funds into research and make that sustainable, which I think is extremely exciting.
Yeah, I think that the next phase of this, although it's legally very challenging, but the current way that the IP and NFT infrastructure sort of works is that you're really making bets on a very granular level. So there's a scope of experiments that might yield intellectual property. Research often fails. This often doesn't work. A lot of these things will ultimately not have real value. But I think a next phase of that might be, what if you tokenized, for example, a laboratory, and you had people that instead of betting on the success of a single set of experiments, you were really betting on the long-term success of an individual. Scientists might have many hypotheses that fail, but if you work on a single protein for 20 years, it's very likely that you'll ultimately have some really valuable insights and successes. And you can imagine taking a sort of DeFi approach. You have an IP NFT that represents ownership in IP that's coming out of the laboratory, sort of in perpetuity. You fractionalize this. You have a market now that is where all of the trading fees are then just going back to the researcher to fund research in perpetuity. And I think this is where you can get these really sort of colorful, interesting mechanisms that would actually be revolutionary. Like, could we create a sort of evergreen funding mechanism in perpetuity that was in some ways driven by maybe even speculation, but ultimately driving funds into the hands of the right researchers? Obviously, this comes with risks, but I think there's a huge amount of space to experiment with really, really interesting designs here, and really, really excited to see what people come up with.
Thank you. That's deep. Would you like to, each of you maybe think about the future? How can we move beyond the patent system? Maybe also within the context of public goods through IP NFTs, like pay for success contracts, open science.
So I think that with VitaDAO, we really care about making funding science economically sustainable right now. So our primary strategy is going to be able to fund more future IP NFTs, and then try to capture enough value that we can redeploy that into the next generation of projects that we want to fund. But you could definitely see some kind of Ukraine DAO, Assange DAO, Pleaser DAO like dynamic, where people are just based on a meme coming together and say, let's just buy out this IP NFT, and then we unlock it, and then everybody can just do whatever they want with it. So I think there can be different ways, and it really just comes down to what do people care about, what do they value, and if they think that completely open sourcing the IP that's within an IP NFT is reasonable and what they want to do, then they can go and do it.
Yeah, I think it's interesting because there is like always this like kind of like too simplistic criticism of big pharma and research and this and that. Like ultimately, like without it, like we wouldn't have solved COVID. So it's like the thing is, it works, but it has flaws and problems. And I think the thing is, it's too easy to say, oh, capitalism is bad, big pharma is bad. Like, but then like offer a better path. And I think the problem is, a lot of the critics are like in that sense bad critics because they don't offer a better path. And I think the better path could be kind of like retroactive public goods, pay for success, and kind of like aligning incentives, like this meme of like diabetics funding, like insulin. Ultimately, if you have a big patient population, and the patient population collectively is leading like the research, then I think it already creates more alignment. Like if the parents of like children with rare disease fund and govern the therapeutics for their children, they'll probably do it like in the best way possible. But ultimately, I think the power is to explore the design space of all possibilities of like retroactive public goods, pay for success, more like traditional pharma-driven development. And I think ultimately it's a question of scale, right? Like ultimately the COVID vaccine costs $20 because it's at scale. And like same for longevity or even psychedelic therapeutics. If they are deployed and like used at scale, they could also cost $20 or $50. And ultimately, like go completely against the grain of like traditional pharma incentives of like having like much higher pricing for smaller populations.
Yeah, I mean, in the end, science and healthcare should be open source. It should be a public good. I don't think anyone fundamentally disagrees with this, but we also have this core problem that is that it costs a huge amount of capital to develop a drug or to do science. And so a few years ago, there's an amazing consortium of scientists working on a project called Open Source Pharma, led by Matthew Todd and a couple others. I think they're doing amazing work. They have, data being committed to GitHub repositories in the context of like malaria, mycetoma, other disease areas. But one of the core challenges with a lot of this is the translational component. In the end, who's ultimately going to pay to take the risk to bring this to market? Is it going to be a government? Is it going to be the WHO? And I think what we've been trying to explore, heavily inspired by that system, is like, okay, is there something that is a little bit of like a transitionary species between this highly monopolistic system that tends to be fundamentally misaligned with core user groups and stakeholders, patients, researchers, et cetera, and a system that is entirely open source? And in my mind, the way that we do that and the way that we bridge that is this sort of Web3 angle where you're basically making something, would pharma be a problem if it was monopolized by patients? Probably not. You know what I mean? It's like if the core owners of if the COVID vaccine was owned by everybody, would it be a problem to have these sort of patent systems? Probably not. I think the real risk is in the centralizing with a single stakeholder that has sort of asymmetric power in that case. But yeah, I think fundamentally we should be, I'm curious, if you look at like a life insurance company, they operate by having a huge amount of capital and then, taking bets with that capital, for example, not by having more people paying in than dying. Maybe with basic research, if you could pull together $1 billion and leverage it into some interesting ways in DeFi, maybe you could do a bunch of open source science in a sustainable way. So yeah, really curious to see what comes out of it.
Okay, thank you. Any closing thoughts or question you wish I would have asked? Yeah, we're out of time, so yeah, up to you if you have anything else. Otherwise, yes.
Yeah, so two things. I think the one is that we'll announce it this week. We'll host in Berlin, and I think 22nd and 23rd of May, DeSci Berlin. Like, we'll open up kind of like applications for speakers and sponsors and people that want to participate. And another thing is that with Molecule, we want to like fund projects. We want to like give grants to like open source devs building on IP NFTs. So feel free to reach out to us, like Vincent at molecule.io or Tyler at molecule.io, and yeah, get in touch with us. And yeah, we'd love to support and build this together.
Cool. Thank you, guys. And actually, so one thing, I am shocked that we are actually on time today. So I thought we were going to run grossly over time. So I figured because we're ending, with 30 minutes to spare that I was not planning on us having, I actually want to do kind of a communal Q&A session. So invite as many of the speakers or panelists who have been up before to hang around, and anyone who does have questions. We didn't have enough time to pepper it throughout the day. It's going to be a little bit of a Q&A mob up here, but nonetheless, if anyone does have any questions, please do feel free to raise your hands, and we will do our best despite the glare. I see one in the back, please. And yeah, and everyone who has spoken, who's been on a panel, who's presented at any point, like, please come on stage. This is going to be, I feel like, a good segue into the Q&A later anyway. So yeah, and there was a hand raised somewhere in the back. Actually, yeah, give me one of the mics so I can run around and give it to people. Yeah, sure. Yeah, again, so anyone who was on a panel, anyone who presented, this will also just give you a sense of just how many humans it takes to put on something like this today. So, yeah, this is at least a fraction of who we've had involved. So, yeah, please, if anyone else we've missed, please feel free to come up. Yeah, and please take it away with a question.
Hello. Thank you so much, everyone. If we could, please give a round of applause to all the people that came in to talk today. Awesome, thank you so much. So we've clearly heard a wide diversity of perspectives on how we can decentralize science. I come from a scientific background. I'm a chemist and materials engineer. I've had startup experience starting 2 startups. I'm with Orange DAO, Y Combinator. We've done venture funding, the whole 9 yards. What I haven't heard today that I'd love to get some perspectives on is how should people that want to break into the space consider, do they build open source? Is this the kind of solution for a DAO? Is this the kind of thing that you build open source and then privatize? Is this the kind of thing we want to bootstrap? Do we want to get crypto money involved? Is it venture capital funding, so on and so forth? I haven't seen a guide like that, and I think we have all of the intellect in the room to chip away at that. What do you all think?
Cool, thank you.
Maybe pause the question to someone, or?
I think that might have been an open one. I don't know if anyone, yeah. In the future, if you want to target it at someone, feel free, like y'all, or from a specific panel or group or whatnot.
So I think there are two questions here. The first one is how do you contribute if you really care about decentralized science? And then the other one is how do you capitalize institutions that are active within decentralized science? So I think the first one is a bit easier than the second one. You can contribute in various ways. I think there are DAOs that are extremely permissive organizations. You just get into the Discord and you see whatever is the mission of that community. And in case of VitaDAO, the core activity is to help us identify really interesting, potentially commercializable research around aging biology. And in OpSci, it's really about developing open source tooling to make the sharing of scientific data sustainable. And within LabDAO, it's really about, let's take this really interesting algorithm that was published on bioRxiv last week and clean it up so everybody can run it in a sustainable way. So that's sort of maybe the first part of the question. And then the second part of the question, at least on my perspective, is how do you capitalize organizations within DeSci? And that's actually really, I think, a tricky question that we're all sort of answering on our own, and we're all sort of walking to different directions. And some of us have started companies first and then launched decentralized projects on top of that. And some of us have launched communities first and are now thinking about, okay, how do we make this financially sustainable, and how do we keep the teams going that are actually pouring their time into this? And I think the reality that we might converge to is that both of these paths work, but at the end of the day, we're probably going to have this sort of duality of, right, there's this community nonprofit element, and then there needs to be at least one entity that can also take on legal risk and take on capital to further drive the mission if you want it to really hit the mainstream.
Yeah, so just to quickly add on to that, I'm going to stay away from how do you capitalize the 10-foot pole. Thank you for that one, though. In terms of how do I get involved in the space, 3 different direct pathways for you.
Right. First off, we will be posting a link to the Blockchain and Science Telegram in that ethAmsterdam Telegram chat. Actually, I'll be posting a link to everything that I mentioned. So for starters, there's a lot of activity in that Telegram, and we'll make sure that that's a central point for other resources to spread out. Cool. Next, I would point you to 2 different websites, one of which being DeSci.community, which has been the focal point for this entire conference, but will also transition into a more community-centric website in the future. I would point you to DeSci.world, and you can actually go back through a lot of the demos today. Their whole mission is kind of being the speakerphone, or the megaphone for the space itself, where you can learn about individual projects, find their discords, find the calendar of calls and everything else that's happening there. Then the last thing that I would point you to is at DeSciEth on Twitter. That is our community Twitter. And the whole point of that is community calls, promoting public goods, and giving people ways to actually be involved. So I'll make sure that there are links to all of what I just mentioned in the Telegram. Does anyone else have something they want to add?
Yeah, just to add really quickly to that, just to echo what Eric said earlier, onboarding people to this ecosystem is the public good. And Eric from DeSci Lab and I actually working on something to help with that generally. So if anyone wants to start working this ecosystem, come talk to us. We value your perspective, and we would really love to have your help as an outsider to build this pipeline out.
I think one interesting perspective for me, what I hear from the question is kind of should everything be a DAO or a community? And I think it definitely shouldn't be. I was excited for DAOs since a while, but very few succeed, I think. But I think the most successful ones to me are projects like Gitcoin, like that really have like a huge intrinsically motivated crowd that is like coming together to do something like for pure intrinsic motivation and like coordination. And I think a lot of the projects are more like a startup, like a product-centric team, where like a DAO might not be the best for building product or doing science, but it might be perfect for like collaboration and coordination and bringing a lot of people together. So yeah.
And slightly more intangible, but I think just as important, is like tell your mom about this, tell your friends about this, like tell everyone you know about what we're trying to do here, because I think that once people kind of get it and see what we're trying to work on, it's hard to not resonate with a lot of people, especially those coming from the scientific community. So just become like a DeSci evangelist if you can.
And we should be experimenting with everything. I mean, realistically, we don't actually know the answers to most of these questions. The field is so nascent, and the rules will sort of be like written in blood, as they are in most cases, through a ton of failures and a ton of like recapitulating the same things that we see happening in companies and the traditional sciences. But I think that's okay. I mean, the tool set that we have here is one that allows us to experiment, and I think this is, we'll see in 2 or 3 years, like, what are DAOs good at, what are they not good at, where is it safe to raise, from VCs that are doing impact investing, do they dump on the community? Like, these things are, unfortunately, probably going to be like hard lessons learned, but important nonetheless.
I'll add one thing. The most important thing are people, right? I mean, at the end of the day, everything we're doing is about people. I would always talk about DAOs. One of the critical things about DAOs is having leadership, right? This conference was put together by Eric and, what's your name?
Eugene.
Eugene, right? Eric, I just had to do that. Eric and Eugene, they put this thing together single-handedly. Yeah, and the other thing I would add is there are other ways to attract talent. I have a couple interns that work with me. They're not really, they're shy and bashful. They don't want to be in a community where people are looking at them and critiquing them and potentially bashing them. But they come to me privately and say, hey, I really want to learn more about this. Can I get involved? And so don't think that you have to be in a DAO in order to get involved.
Absolutely. I think I'm going to pick up the 10-foot pole that Eric dropped and maybe poke it a little bit. The question of funding and soliciting capital. So as a scientist, definitely in my experience, money and commercialization has always been the scary thing, right? It's the monster in the closet. You look at your friends that go off after they get their PhD and work in venture capital or Wall Street, and it's a completely different lifestyle, and like, oh, well, they don't believe in the same things I do. I'm doing this not for my reputation, that's impossible, but really for the good of humanity, and you try to convince yourself that. I think VC funding shouldn't be treated as a bad thing. It's just a neutral force that we should consolidate all of the best aspects of our community around to take advantage of as a resource, right? So I think where VC funding can go wrong, maybe potentially, is where you have a young, growing community around kind of open source or public goods, and maybe some elements or contingents within the community go off, raise a lot of capital, and then maybe splinter off, and the sort of fabric or support that could have been there isn't there anymore. So the best thing I could imagine is that we just talk about it. We have a conversation, we build shared resources. If you're soliciting capital or looking to spin out a project, maybe talk to other people, or maybe if you have done so successfully, offer to mentor those projects in the space, and where did it go right for you? Where did it go wrong for you? What did you wish went differently? And I think and we had a Twitter space a couple weeks about some, these aren't like my original super thought. These are just thoughts I'm transferring over from that conversation. And this is something that other people have brought up to me multiple times. They said, how do we band together as a community, as a show of solidarity, and demonstrate that we're a bunch of serious folks with great ideas, and we can execute, we can deliver, we can ship. We just need a little bit of support. It doesn't even have to be like, a massive injection of funds, right? It just needs to be enough to keep, to get the project managers in the space talking, going across teams, building that cultural bridge across the different elements. And so that lets us focus on what we do best, right? So I love to build, I love to experiment, I love to try to break things, but unfortunately I spend a lot of time doing ops stuff, right? and so I don't want to do that anymore. So Scurf, please save me.
We're working on it. But yeah, I also just want to add, and if anyone else does have a question, please feel free to come up. I feel like we'll have time for like one more round of a group thing. So we'll see what I say, because I want to push back on something Shadi just said. So we'll see if that spurs enough interest here to keep us going. But one thing I also just want to plug on getting into the space are the DeSci Twitter spaces that are run. And fortunately, it is kind of communally run at this point, where it's not a single group or a single organization. Kind of whoever, if anyone here feels like hosting a Twitter space on a given topic, like cool, please use that. I think the slot is 1 p.m. Eastern time on Thursdays. Yeah, cool. So yeah, that is meant to be like a welcoming space for people to get to come in and be part of these discussions and learn more, where you don't have to be visible, you don't have to get the spotlight on you. Yeah, I think that it is good to have that kind of comfortable space to first hear about these ideas. The idea that I want to push back on is the idea of like VC, or really anything as a neutral force, because like I don't think anything like tools are neutral, right? Like that's something that gets thrown around a lot. I don't believe in that. Like everyone who builds things has intentions, and that inherently colors the release of things as they come out. And so like when you have money and you want to make more of it by throwing it at people, and you know like 5 to 10% of them will do great and that'll get you more money, like you have certain intentions. You're playing a certain game, and you are always incentivized to be like, well, do a little more, a little more, a little more, a little. And so like I am actually hypercritical of VC from the perspective of like their incentives are not always aligned with the community and aligned with projects and aligned with companies, because they're playing a numbers game. And so like if you find a good VC that is genuinely like commits to projects, helps them through the long term, that's a different discussion. I just think that like those VCs are much fewer in number. And so like, yes, like this space needs quality VCs that like want to partner with us for the next coming decades to genuinely build bridges between us and meta research and meta science, and like genuinely move these problems forward. And there's inevitably going to be VCs who are like, I could not care less about what you're doing. I just want my 100x. And like those are going to try to ruin the space unintentionally, while the former will help all of us hopefully grow, succeed, and affect change. I see Nicholas already wanted to respond to that.
So like rate my professor, but
rate my VC.
Yeah.
I'll hang out with you.
Yeah, let's rebrand VC to venture contributor.
I see how they like that one.
Yeah. So at the end of the day, a VC is a professional capital allocator, and they're actually allocating capital that, in the best cases, comes from institutions that are all of us has gone through or will be part of, right? So university endowments, they're institutions that are really building nations and building people, and they need to allocate the capital, and they're giving it to capital allocators that do this in their full-time capacity, and they probably should, because VCs usually know what they're doing. Now with these movements, these DAOs, it's a bit of a tricky topic, because we're not a company that's returning money at a liquidity event. We're literally like an alternative to the institutions that are LPing into your fund. So we are going to be the ones that will eventually manage endowments and actually give funds into professional capital allocators. So that makes it a bit tricky. That said, the way that I personally, for example, think about LabDAO is I'm basically building this garden where the mission is open tools accelerate progress. That's the mission, just like the mission of a U.S. university is to educate the brightest and to like bring knowledge into American society. And I care about open tools, and that's sort of the purpose of my endowment. That's the purpose of my DAO. That's the purpose of our DAO. And we're going to build companies out of that. We're going to not build one. We're going to build hundreds. And they're going to create a ton of value, and a lot of that value will flow back into the DAO. And that money will not appear spontaneously, but that money will need to come from the people that are currently allocating capital, and those are the VCs. So, you can be a contributor in LabDAO, and you can be an investor in all the great companies we're going to build within LabDAO. And I think the same is true for a lot of other projects.
And am I getting played off?
Just background music. We got another 10 minutes
I
out
think
there for Q&A.
I think it's possible to, just as like a real world example, VitaDAO did its initial Genesis fundraise from a community of people. We had no idea who they were. It was just a bunch of wallet addresses. Did a proper fair launch. The team did not receive any tokens. No VC received any tokens. And that model can also work. And then I think we're in a space now where the tokens are mostly held by the community, maybe it does make sense to bring in some institutional capital from people who are like really mission and vision aligned and have something to give. But one piece of advice that I would give to anyone who's raising capital, having done it now a few times, is raise money from people that have something to give beyond their capital. Money is actually really cheap and really available, especially in Web3 and in crypto. You could probably find, with a good project, someone who will just throw $100,000 or $200,000 at you, no strings attached, maybe expecting that you toss them a few tokens if you ever launch one. And I really mean that. So I think you want to find people who are going to go to bat for you, that have something to add as a contributor to your community, that are going to serve some real function, and that aren't just giving you cash. Because in the end, like, you can get cash from a lot of different people, but some VCs, and some professional capital allocators have a lot more to give, a lot broader network. Maybe they want to work in your DAO. Those are the sort of people that I think you should align with, in my experience at least.
Cool. Is there anyone else on stage who hasn't had a chance? Or Brett?
Yeah.
Oh yeah, please, Josh, and then Brett.
So VC funding and funding from, funding sources in DeSci is something that I'm really passionate about. I just think it's probably one of the most pivotal parts of it, because funding is the most important part, and who we get that from really does have an effect. So basically completely agree with most of what was said on here. I do kind of echo Eugene a little bit in my skepticism of VC's intentions. Their kind of direction tends to be kind of self-profiting, which is kind of antithetical to positive science, but one thing I do think though is that we get to make a choice in this set. We're early to DeSci. DeSci is growing. We're some trailblazers are sat here on this stage. We get to kind of make a choice about who we get our money from and what incentives we give them. Now, if we take money from people who are purely motivated by financial return, that's fine, but we can give them returns that are based only on like progress that we deem as ethical or positive, right? So say, for example, someone can donate some money to you, you can use that for goals that are aligned 100% with what you want to do, and if that produces financial return, then fine, return it to your VCs. But we do kind of get, and I think we think it's kind of our responsibility as a group at this early stage to be strong with our ideology, I suppose, with the direction we want to take, and be open with the VCs and say, hey, look, if you're going to give us some money, we're only going to accept your money under these conditions, that you maintain this sort of direction, that you maintain this understanding that we're going to do it decentralized, we're going to do it with these ideas. I think there's a lot of money in this space in crypto and Web3, but the DeSci space is going to be absolutely awash with cash, because there's so many brilliant people up here, and it's Web3 native. It's like crazy. So we can be picky, and I think we should all be picky, and I think we should all be as strong as we can to our idea of what DeSci is capable of. That's my thoughts.
And yeah, I think a trend that really works in our favor is the rise very rapidly the past couple of years of ESG investing, which is environmental, social, and I think the G is governance investing, for investing in companies that are actually trying to make positive change either in the environment or for social causes. And I think that has maybe shifted the focus of a lot of investors and a lot of VCs to no longer be trying to just squeeze all of the juice out of the orange, and maybe actually be seeking some ulterior goals. So just as long as you don't fall in the trap of trusting the VCs that are just out there greenwashing, and we really are picky. I do think that the trends are working in our favor right now for funding, and we shouldn't be, take a hard line and say no. I think importantly, if you approach a VC with a well-defined roadmap for your project, and you're very staunch and rigid on that roadmap before you accept funding, then I think that's the right path to take to make sure that they don't really change your plans moving forward.
I guess I also want to echo that to some extent. I think just like, it would be really nice to build bridges with the scientists that may not already be Web3 native. I think we can also just take a lot of folks along that even though they're natively come from the VC space, they really have a deep interest. I interact a lot with VCs or with VC-like funders, and I know personally a few that really deeply care, and I think they've grown out of a certain system, they've grown up within it, but they actually really care. And so I think it's individually, it's person specific really, but many people are really along for the ride. And I think as a abstract concept, one could say it as a genetic takeover, which is a term, I guess, from biology, really, where you grow a new system within a previous system, and it's constrained by the constraints of the old system, and it gradually, collaborates, outcompetes eventually the existing system, but you don't have to do that in one wash. And crucially, I think the new system is constrained and also really deeply influenced by the old system that you're working with. And so whenever you have code absolutism versus legal absolutism or whatever, like I think the same is true with this, with normal science and now DeSci, and with funding and now, more of the decentralized funding. I think that people have a lot to contribute, and I think we shouldn't leave people alone or like leave people on the sideline just because they grew out of a specific system. They have a lot to contribute. So and I think it would be nice to take them along to the extent that they want to.
Awesome, thank you. I'm actually going to ask to transition to another question because we've already spent 24 of 30 minutes on one question. So let's diversify the questions a little bit.
Yeah, perfect. So, I mean, this question is a bit broad, but I think from the investment space and in the science space where you're trying to figure out how to allocate funds to different scientific projects, there is this whole question of risk. So how do you see the risk allocation within each of these spaces, and how do you actually produce a portfolio that's risk mitigated? Because I think that's generally where both investment and all kind of funding in the scientific space needs to go.
I'll jump on that real quick, because that's all I am as a risk mitigator. One of the great ways to mitigate risk and at the same time raise capital is to partner with strategic partners. People that will actually use your product and validate through that use, and then become as an investor in your company, or your DAO, whatever it is, your organization. I have never experienced anything better than a strategic partner for proof of concept and funding.
Cool. Yeah. So my personal risk allocation metrics are kind of not risk mitigation at all. So just kind of following the philosophies of AstroTeller. So AstroTeller is I believe he's the captain of Moonshots. That's his formal title, but he's basically the CEO of what's called the Moonshot Factory at X, and basically.
Enough. Hold the mic closer.
Oh, sorry. Yes. Okay. Can you guys hear me now? Okay. Hopefully, yeah. But anyways, so AstroTeller is the CEO of the Moonshot Factory, which essentially it basically think of it as the innovation hub, right? And one of their biggest things is that innovation is inherently risky because it's non-intuitive, right? If it was intuitive, it would not be innovation. Right. So when it comes to funding the absolute bleeding edge of neurotech, for example, with NeuroDAO, it's totally I don't know, this is totally going to be risky. That's the fun part, is it not? But yeah, it's kind of don't mitigate risk too much. Have an obvious plan, obviously, but yeah.
Yeah, I think maybe one sentence is that ultimately the current institutions are too risk averse. So we need to be riskier. And I think you see it with the most ambitious crypto philanthropists shaking up science funding, that there are much more risk taking, and more like an angel investor, spread their risk so they fund a lot of research, and then some of the most interesting research will come out of it.
Yeah, just real quick, I just want to manage stage time as well, because I know Nicholas, Brett, and Shadi want to speak, but there's many more folks who haven't spoken on stage yet, so I just want to make sure everyone who wants to has had a chance to respond to a question.
Yeah, regarding risk, there's also another risk, basically 100% that we are all going to die if we don't fix healthcare. So not just financial risk. Let's think about other risks as well. That's in my that's all.
Yeah, and then can we let Philip answer? Yeah, and then I know Nicholas, Brett, and Shadi in terms of folks who have already spoken.
Yeah, so one thing I just wanted to point out is that in the Web3 sphere, it is so much easier to split your investment into smaller chunks. So you can do very efficient, targeted micro investments. You can pool resources with others. And just because of the technology that we're using, it is inherently much more easy for investors or for patrons to diversify their risk in the space as soon as we have enough projects up that they can invest in.
Yeah, and I think it's really important to translate that risk to the actual investors that might be investing in a token or in a project that maybe they are not well versed in. And I think it's really great to use already established, tools such as technology readiness level. I think Martin had talked about technology readiness level before. Maybe you diversify your portfolio with a few that are at a 2, some at a 5, and some at an 8, and you manage your risk that way. But I think we need to use tools and metrics that are familiar to other people so that then that risk can be very clearly translated.
So yeah, my background is legal, so I see things in terms of contracts. But basically, risk management is just about transferring risk from those that don't want to take a risk to those that do want to take a risk. And I think with programmable money like crypto, you can do this, and you can basically create incentives that are aligned with people that don't want to take risk and then people do want to take risk. So you can basically program that into the token, and there's this massive opportunity to basically play around with a new system that doesn't necessarily rely on patents. You can solve a lot of these issues that VCs have where they're just totally focused on patents, and you can create other incentives, and you can basically de-risk, allow VCs to take risk on bets that they wouldn't normally take risks on.
Yeah, so that question was for the stream. That question was, how do you, when transferring that risk, how do you make sure whoever is now receiving it fully understands the risk they're taking on?
I mean, in my view, the markets should do that. It's tough luck. Like if you don't know what you're doing, then you deserve to lose, and that's the kind of Darwinian.
I think the complementary take would be to try to stay within your circle of competence, both as an investor and as then the allocator that's receiving the funds. So within VitaDAO, for example, we concentrate the competence. Our circle of competence is identifying interesting research projects that have the prospect of developing viable IP, and that's what we're building the whole organization around. It's sourcing the project and then having a group of people that have the expertise to review the project and then formulating good, solid proposals that then go and vote on chain. We don't do the whole process on chain. I think that's important as well, right? There is something like a deal meeting, and it's happening Fridays, and the sourcing is extremely decentralized, but the preparation takes some competence, and that competence can be concentrated within the DAO, but then the decision, once it's made that it goes on chain, is made again in a decentralized manner. So that's sort of how do you define competence, and then what are we not as competent in VitaDAO? Well, we're not a treasury manager to the extent that we're like going to the next Shiba token with our endowment. We're taking a conservative approach because this is not what we're specializing in, or we might even have to work with someone else that specializes in like large treasury management eventually, or build that competence in-house and sort of build a vertical around that. And the same is true, in other projects as well. Like you take a bet on an open source contributor, say, what you're doing is really interesting. Here's a bit of money. Make it like production ready, please, so that entrepreneurs can use it for whatever they want to do. And then this is my circle of competence. What am I not good at? Again, like managing my ETH treasury. Like, there are other people that can do that better than I.
Yeah, I think something that's been kind of touched upon but not addressed directly is risk. We're just talking about it with the lens of return on investment. Maybe I don't care about that. And if you compare institutions that are funding research for different reasons, their risk assessment is completely different than a VC's risk of investment, right? So the United States government, NIH, investing in COVID research, their risk profile is how many people are going to die if we don't invest in the right places. So I think the conversation changes depending on what metrics of risk, and that's related to what Nicholas was discussing regarding DAOs that are formed around a very specific mission or directive, and that's the most important thing I think you can do, and VitaDAO has been a stellar example in the space of how this could be done in a scientific, with a scientific mission in mind. Really kind of, how do we form around a direct mission, and then having an explicit conversation either in the governance or in the culture that emerges over time within the DAO, how risk is treated with regards to those outcome metrics. And again, that's similar to what Brett was mentioning with the ESGs, right? So it's a completely different world we're living in now. I think like philanthropy is not a side effect of VC, or like, it's not like, oh, I'm gonna get rich and now I'm gonna give some money away to some people because I feel good about myself. It's, we're gonna build protocols and businesses that
are directed towards some end goal that's not just making money.
Woo!
Yeah, right
Convenient.
on.
And so we technically have -4 minutes left, so we're going to cut this question here. Umar is going to ask us a quick one to wrap up the question portion on.
Thank you for letting me ask a question, and also thank you to this amazing panel. It's great to see everyone here on stage and to just have this event. And also thank you again to Eugene and Eric for putting so much time and effort into making it possible. So my question... I'm happy for DeSci. All right, my question is, there's been a lot of discussion already about decentralizing scientific funding, and I'm really curious about the other part of decentralizing science, which is the research and the access to knowledge. So my question is, in addition to decentralizing science funding, what are the best ways that we can make sure that there are less paywalls for people to read papers, that there's more access to information, that the goal of science, which is to uncover truth, is obtained, and not just the fixing of scientific funding? Although I definitely see how both are necessary. Thank you.
I'll give a quick answer. Change culture.
Yeah. That's the problem we're trying to solve. And it's a big problem. One way to go about it is to create true open access, real open access. Now, real open access means more than being able to click the PDF on a publisher website and to click it. Real open access means when the publisher goes out of business, this PDF doesn't disappear. Real open access means that when China decides to censor 1% of Willay's published research, people can still use systems to access that knowledge. Real open access means verifiability. We need to be able not only to read and to learn, but also to have total transparency over the validation trail, over the reliability of the knowledge produced, and over markers of quality such as reproducibility and ultimately replicability.
And then we got Renee and then Tyler.
I will step in for a second just because Talent DAO's logo is literally decentralized knowledge, and it's something I feel very passionate about. I think there's sort of 2 or 3 major bullets when I think of to try to answer this question. The first one to me is community-owned IP, I think is super important. DAO members should own the research being produced. So like with Talent DAO, all of our research is open source, but you have the IP and the license owned by the DAO members, which is very similar to some of the other DAOs on the stage. So I think that's essential. I think the other thing that's essential is resilient data storage and links that are eternal. So that source of truth is, prevalent throughout time, which is kind of what Chris is working on and talking a lot about. And then I think the third thing to decentralize knowledge is we need to mobilize the networks within the community and create an ecosystem where that knowledge sharing becomes very fluid, which is, I think, a lot of what Scurf and Eugene is working on. So I believe that the answer to your question is probably a combination of the solutions on the stage, which is really exciting, right? Because we want DeSci to be a thing.
Yeah, I think the most important thing would be for us all to collectively let go of our egos, which I think is actually the thing that's standing in the way of this system being successful, because there are already many ways to openly publish access to knowledge, but unfortunately it doesn't come with an impact factor of 44 and you guaranteed a tenure-track professorship at Harvard. So the reality is that even for myself, if somebody said tomorrow, I could publish on Research Hub or Nature, I probably would publish in Nature for a ton of different reasons, most of which I sort of hate about myself, but are real. And I don't know. I think it's a cultural problem more than anything else. We need to really, really strongly figure out a way to band together and incentivize people letting go of ego and reputation and creating a new space for reputation, ideally within DeSci that gives, I suppose, the same sort of feelings to academics, which tend not to be motivated by financial interests, but do tend to be heavily, heavily motivated by reputation and prestige.
So I'll add to this. We cannot compete with Nature and Science magazine. What we can do is operate in parallel. It's essential that we create a two-track system. As a scientist, whatever work you produce, you need to be able to use the existing system. That's why DeSci should have a very clear copyright policy. It's like we take none. It's all CC0. We're preprints. We're a preprint platform. It's essential. That's the only way, as a scientist, I would take the risk to explore an alternative system. And moreover, I talked before during my talk about the version of record. The version of record, as it is instantiated today, is the PDF of record. Our claim to value in decentralized science is that we need to claim the research object of record, the reproducible research object of record. And this is how we take the scientific high ground. This is how we will impress other scientists. And this is how ultimately we will gather users and gather respect.
And then for one more response, and then we will actually have to cut it off.
Sorry, I just wanted to comment on a few comments that were made before me. So first of all, I'm not sure it's really possible to get rid of Igor, or at least in a feasible future. Yes, so I would rather say that the incentives should be changed, and maybe we could actually build reputation on chain, as you said, and actually just see, just offer people something instead. This is something. Then about the open access that Chris was talking about, I think the real open access should also come with open raw data, and which also would, yes, and because from my own experience, after my PhD, I only have about 5% of my experiments published. And I think that cherry picking is a huge problem, because for some reason my supervisors wanted to publish the experiments that were in line with the hypothesis, that couldn't raise concerns among reviewers, and so on and so forth. And this biases through so much. Yeah, everybody, of course. Everybody from academia is super surprised about that. Yeah. And so as Martin also from Fleming Protocol mentioned, that he was shocked about the reproducibility crisis and how much truth we can put into what has been published already. And before we achieve that, I think it's really like people can literally be paranoid about whether they can trust what has been published or not. Yes, and okay, you want to say? Yeah, and yeah, I think that's it. Thank you.
Great, and we do, unfortunately, we're well over now what we were with the buffer, but thank you all so much for joining. Let's give a round of applause for everyone up here. These are all the wonderful speakers who joined us for various portions. Yeah, no, sorry, we do have to cut off the Q&A, but folks will be around at the bar area after. We are covering 1K of drinks over there, so please feel free to go grab a drink and have that covered. And yeah, I'm just going to give a few quick kind of closing remarks as we wrap up. But I'm just tremendously appreciative of everyone who joined us for part of the day, everyone who is watching online, everyone who spent time to contribute to this kind of intellectual exchange and capture that's been happening all day today. And so yeah, just huge thank you to everyone. As was mentioned, we have a Telegram group that we'll share links to. We have a wider community calls that happen regularly. And very importantly, as was mentioned, kind of Eric and I were the lead organizers on this event, but we were just happy to step up and make something happen. And now we get to go from something to something great. And that's going to take a community to come together and to really work on it together. So we are definitely going to need to recruit the next round of lead organizers and the next set of volunteers, whether it's virtual, in person, whatever we choose to do next. We're definitely going to have to do a lot of work for it as a wider community. So thank you again, and just like one more round of applause for everyone here. We made it, bro. We made it. All right, cool. Yeah, and we are done. Lovely. Great.
We got a 1K drink budget outside, so please go grab a drink, grab a t-shirt, grab some swag.
Go as crazy as you can with one drink.
Yeah, exactly.
All right, cool.
Thank you, guys.
We're going to